Short Form Catalog. 1991. LSI. Short Form Catalog. Table of Products and Services 5. Contents. ASIC Design Tools 9. Silicon 107611. CMDE, Concurrent Modular Design Environment, 12. MO, Modular Design Environment, 13. Design Builder Synthesis Software 16. Chipsizer Synthesis Software 17. Memory Compiler 18. Test Builder 19. Logic Block Synthesizer 20. Logic Expression Synthesizer Tool 21. Silicon Builder 22. Data Path Compiler 23. Block Compiler 24. Mo Support Service 25. CDE/MG Co-Designer Software for Mentor Graphics 26. Verilog Design Kit 27. Synopsys Synthesis Libraries 28. LLC Valid Logic LCA 10000, LMA 9000 Libraries 29. Third Parties 30. Design Services 31. Design Building Blocks 33. Cell Development 34. Full Scan Testing and ATPG 35. Fault Grading 36. Spice Models 37. Layout 38. Applications Engineering Support 39. Array-Based ASICs 41. LCA 200K Compacted Array Turbo Series 43. LFT 150K Fastest Array Series 44. LCA Look Compacted Array Plus Series 45. Look Embedded Array Series 46. LCA 10000 Compacted Array Series 47. LMA 9000 Micro Array Series 48. BiCMOS LDD 10000 Direct Drive Array Series 49. BiCMOS LAD 310 Analog/Digital Array Series 50. RASIC LRH 10000 Radiation Hardened Series 51. RASIC LRH 9000 Radiation Hardened Series 52. L63500 ARINC 629 Terminal Device, DATAC, 53. Cell-Based ASICs 55. LCB007 Series 57. LCB15 Series 58. IEEE P1149.1/JTAG 59. IEEE P1149.1/JTAG Testability Bus 61. L. Short Form Catalog. Table of Contents. Conted. DSP Standard Products. L64032 32-bit Mac. L64134 32-bit MOS IEEE Floating Point Processor. L64210 11 Variable Length Video Shift Registers. L64212 Variable Length Video Shift Register, HVSR. L64220 Rank Value Filter, RVF. L64230 Binary Filter and Template Matcher, BFIR. L64240 Multi-Bit Filter. L64243-3x3 Multi-Bit Filter, MFIR3. L64245 for Filter Processor. L64250 Histogram/Hoff Transform Processor, HHP. L64260/61 High-Speed Versatile for Filter, VFIR. L64270 64-64 Crossbar Switch, XBAR. L64280 Complex FFT Processor, FFTP. L64281 FFT Video Shift Register, FFTSR. L64290 Object Contour Tracer. Video and Still Image Compression. L6470108 Error Correcting Reed-Solomon Codec. L6475152 Error Correcting BCH Encoder Decoder. L64720 Video Motion Estimation Processor, MEP. L64730 Discrete Cosine Transform Processor, Oct. L64735 discrete cosine transform processor. L64740 oct quantization processor, Octo. L64745 JPEG coder. L64750/51 Chitty variable length coder/decoder. L64760 interframe processor. MIPS microprocessors. RISC products MIPS architecture. LR2000 RISC microprocessor. LR2010 floating point accelerator. LR3000 RISC microprocessor. LR3000A RISC microprocessor. LR3010 floating point accelerator. LR3010A floating point accelerator. LR3220 read-write buffer. MIPSET chips. LR3201 RST int controller. LR3202 bus controller. LR3203 DRAM controller. LR32D04 DRAM data bus buffer, 16-bit. LR3205 block transfer buffer. LR33000 MIPS embedded processor. RPM3310 MIPS 9 module. RPM3330 MIPS 9 module. MIPS system programmers package. L64500 MILSTO 1750A microprocessor. L64550 MILSTO 1750A MBU peripheral. L64501 MIL STD 1750A radiation hardened microprocessor. L64551 MIL STD 1750A radiation hardened MBU. 63, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 81, 83, 84, 85, B6, 87, 88, 89, 90, 91, 93, 95, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117. LSI. I short form catalog. Table of Spark microprocessors 119. Contents RISC products Spark architecture 121. Conted, L64801 integer unit 123. L64804 floating point unit 124. L64821 memory management unit 125. L64822 data buffer 126. L64823 clock controller 127. L64824 cache controller 128. L64825 S-bus video controller 129. L64826 S-bus DRAM controller 130. L64811 enhanced integer unit 131. L64814 enhanced floating point unit 132. L64815 memory management, cost control, and cache tag unit 133. L64850 MBUS DRAM controller 134. L64851 MBUS standard I/O bus interface 135. L6485 Tumbustus Bus Controller 136. L64853S Bus DMA Controller 137. L64853AS Bus Direct Memory Access, DMA, Controller 138. L64855S Bus Video Frame Buffer 139. L64901 Embedded Processor 140. L64951 Integrated System Controller 141. Sales Offices and Design Resource Centers 143. LSI. Products and Services. Introduction. LSI. Products and Services. ASICs. LSI Logic is the leading designer, developer, and manufacturer of the most advanced ASICs, application-specific integrated circuits, in the industry. The company's broad ASIC line includes high-performance MOS and BiCMOS array-based and cell-based ASICs, which integrate random logic, microprocessors, memory, and analog functions on chips, with up to 200,000 equivalent gates. LSI Logic also manufactures and markets Spark and MIPS microprocessors using RISC, reduced instruction set computing, technology and other selected standard products. Military. Radiation-hardened versions of array-based ASICs are available from 10,000 to 50,000. Usable gates with a total dose of 200 to 1000. CRADS, SI. LSI's mill/aero facility in Fremont, CA, is fully self-contained, with assembly, burn-in, test and qualification in one domestic location. MO Design Tools. LSI Logic's comprehensive and flexible ASIC design tools support both silicon-specific and system design environments. The MO Registered Modular Design Environment Registered Design Tools. CDE Registered Co-Designer Trademark Environment Design System and interface tools are fully integrated with the company's advanced manufacturing capabilities. MDE tools offer Design Builder and Silicon Builder, which greatly increase ASIC design ERS productivity while making sure that COR wrecked by construction circuits are designed. Design Builder tools synthesize higher-level descriptions of circuits into netlists. These netlists are then synthesized using the Silicon Builder tools to produce efficient physical layout. This combination produces ASICs guaranteed to meet specifications, whether customers use in-house MDE software, or one of LSI Logic's design resource centers. The MDE tool set, comprised of over 25 modules, is used to design chips with up to 200,000 gates and systems in excess of 2 million gates. More than 1,000 library elements ranging from simple macro cells to complex mega cells are available for both array and cell-based ASICs. Copyright 1989, 1990. 1991 LSI Logic Corporation. All rights reserved. RISC microprocessors. The LSI Logic MIPS and Spark microprocessor SOR product lines provide open architecture RISC design solutions. A variety of peripheral chips and chipsets, including processors optimized for embedded control, and innovative chip onboard module packaging technology enhance the product line. LSI Logic's leading edge microprocessor products simplify design and shorten the time to market for Spark and MIPS-based products. DSP products. LSI Logic manufactures selected standard products, such as DSP, digital signal processing, products. LSI Logic's DSP family currently includes 32-bit building block processors, special purpose memory devices, function-specific DSP, crossbar switch, error correcting Reed-Solomon codec and still image and video compression chipsets. The term function-specific DSP covers a wide range of devices which are optimized to perform a particular algorithm or function. Typically, the system designer turns to function-specific devices when the performance required far exceeds that which can be delivered by a single chip DSP microprocessor. LSI Logic offers devices capable of processing video data at 20 or even 40 MHz in real time. Application areas where this kind of performance is required include image processing, radar, sonar, C31, visualization systems, and any application where video data rates are required. Image and video compression products. The newest LSI Logic DSP products offer the ability to drastically reduce the amount of digital information required to store or transmit images, either still or full motion video. The still image compression chipset is compatible with the JPEG standard, while the video compression chipset is designed to the CHIDI H.261 standard. Introduction. Content. Design concept. Design resource centers. Manufacturing. Fast prototypes. Products and services. Worldwide manufacturing. LSI Logic has state-of-the-art manufacturing sites in the US, Japan, West Germany and Canada. Through these facilities, LSI Logic offers high-performance 1.D micron drawn gate length, D.7 micron effective channel length, processes and more than 400 different advanced package types. LSI Logic design tools are focused on reducing the design cycle and buying you time. This is vital in establishing a market lead in product. Introduction. LSI Logic offers the industry's most extensive ASIC design support network and a full range of hardware and software design tools. At 39 LSI Logic design resource centers worldwide and 12 authorized distributor design centers. Advanced wafer fabrication, assembly, testing, and packaging technology make LSI Logic the leader in prototype and volume ASIC manufacturing, with worldwide production facilities extending from the US to the United Kingdom, Japan, West Germany, and Canada. LSI Logic's manufacturing operations are geared to produce dense and fast chips, a wide variety of packages, small to large production runs and extensive test patterns. These manufacturing sites offer advanced ASIC processes including LSI Logic offers the fastest ASIC prototype services in the industry. Fully tested and working gate array prototypes are delivered in only 2 to 3 weeks, or an 8-day hot lot right first time Elm silicon. Prototype turnaround times average 2 weeks for gate arrays and 6 weeks for cell-based ASICs, the fastest in the industry. LSI Logic's proven track record of over 10,000 successful designs assures right first time trademark ASIC solutions. They also leverage the silicon technology VIDing highly optimized, fast circuits that lead to differentiated products. Experienced application engineers offer training and design assistance, giving customers the expertise, hardware platforms, and design tools they need to integrate systems into silicon. 1.0 and 1.5 micron drawn gate lengths, 0.7 micron and D.9 micron effective channel lengths, MOS, and high performance. By CMOS. LSI Logic offers more than 400 different plastic and ceramic package types with up to 524 leads and accommodating die up to 1.5 cm SQ. These include pin grid array, leaded and lead less chip carrier, chip on tape, plastic quad flat packs, and dual inline packages. VICES is offered if a customer requires faster turnaround. For cell-based ASICs, tested and working prototypes are delivered in 6 weeks. Or hot lots in just 4 weeks. LSI ASIC Design Tools. Overview. Benefits. Features. LSI Silicon 1076 VHDL. Preliminary. Silicon 1076 is an advanced system development environment that reduces the time to market for ASIC-based systems. It provides a complete concept to silicon design methodology based on the VHDL, VSIC hardware description language. Because Silicoil 1076 is integrated with LSI Logic's MDE registered design tools and advanced manufacturing capabilities, it is the only environment that provides right first line trademark manufacturing assurance for the most complex systems. Silicon 1076 eliminates labor-intensive mapping of code from one design level to the next. At the architectural level, partitioning tools turn abstract code into design alternatives. Area estimation software helps the designer evaluate the alternatives. Synthesizing software generates a register transfer level VHDL description of the selected alternative. At the register transfer level, RTL, synthesis tools generate and optimize gate level VHDL netlists. At gate level, the optimized VHDL netlist reduces the time to market for ASIC-based electronic systems, ensures that the complex designs can be built in silicon, facilitates the design of complex systems in silicon, maximizes designer creativity and productivity by supporting top-down design, integrates powerful VHDL design tools with LSI Logic's proven design analysis and sign-off tools and worldwide manufacturing capability, allows flexible VHDL data entry at the architectural, RTL or gate level, provides flexible design optimization, library, independent or based on LSI Logic libraries, partitions functions, estimates area, and SIN. These IS RTL code from VHDL architectural descriptions. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. Can be translated to MO format. After the MO netlist is validated, the resulting delay information is annotated back into the VHDL netlist. Silicon 1076 eases the translation of designs to new or different technologies, shortens the learning curve with its integrated single language design environment, complies fully with MIL STD 454M. Requirement 64. Synthesizes memory and logic blocks through calls to LSI logic distributed experts, logic block synthesizer, LBS, and memory compiler. Memcomp annotates delays from Mo back into the gate level VHDL netlist. Supports LSI logic product line libraries. Assures LSI logic write first line silicon. 11. 11. Overview. Features and benefits. 12. LSI. CMDE design. System. Preliminary. CMDE, concurrent modular design. Environment, design system is a new state of the art ASIC design environment that enables you to meet and beat your time to market deadlines. The CMDE design system combines new capability, ease of use and LSI's proven ASIC design methodology with full results. The CMDE toolset was designed to take schematic capture and simulation through to layout tools into an integrated environment that allows multiple programs to run and interact concurrently. Concurrency and intertasking among applications dramatically cut the analysis and debug cycle. Common design database simplifies the flow of data and reduces memory requirements. Interactive, integrated graphical interface quickly transfers vital design data to the user. Copyright 1991 LSI Logic Corporation. All rights reserved. In the CMDE environment, concurrency and a unified database means designers can open simultaneously a schematic capture window and a simulation window. Changes made to the schematic are reflected almost immediately in the simulation window. This eliminates having to exit schematic entry, transfer the netlist to a file and import the netlist into simulation before proceeding. This rapid feedback speeds design cycle time. Incremental linking and compilation reduces design cycle time. Rule-based automation manages design complexity. Description. MDE Integrator Series. ASIC Design Flow. LSI. Modular Design. Environment. Design Tools. LSI Logic's MDE Registered, Modular Design. Environment Registered, Design Tools represent the industry's most advanced and proven array and cell-based design system. MDE software. Products and third-party offerings, CAE design. Tools, testers, and accelerators, meet any ASIC design requirement and run in virtually any workstation or mainframe environment. The MDE Integrator Series, Logic Integrator Trademark, and Silicon Integrator Trademark, offers a diverse range of high-performance graphics and non-graphic design entry tools supported by the most extensive library in the industry. The Integrator Series includes all the elements necessary to quickly and accurately design arrays and cell-based ASICs, application-specific integrated circuits. The entry-level logic integrator is for designs with complexities up to 12,500 gates. It can be upgraded with silicon integrator modules for building ASICs with up to 200,000 usable gates. The silicon integrator can also be easily coupled to the system integrator's multi-chip mixed-mode simulation capabilities. System design entry pre-simulation. Simulation schematic editor analysis. Behavioral waveform editor path timing. Specification. Schematic builder. Analyzer. Language delay prediction. Multi-chip netlist description chip floor planner. Simulation language. Simulation control. Language. The Integrator series operates on a variety of popular workstations. Highly integrated, yet expandable, MDE config. Urations can include optional hardware Excel, errators and behavioral modeling, plus auto-mated schematic and production test pattern generators. MDE's modular approach allows easy migration into new leading-edge technologies and emerging CAE standards. MDE links the design to LSI logic technology guaranteeing accuracy with the right first-time trademark. Record of over 10,000 successful designs. MDE offerings are backed by LSI Logic's software support and technology training classes. With complete documentation, system consulting and maintenance. A user hotline is available with trained engineering profs. Cyanals on hand to assist with urgent customer problems. MDE tools are also available through LSI Logic's 39 global design resource centers. Simulation systems post-simulation. LDS registered simulator modeling analysis. Accelerated logic multi-chip waveform editor. Simulator behavioral path timing. Accelerated fault. Simulator analyzer. Simulator standard power analyzer. Product. Multi-ASIC logic gate modeling package planning. Simulator. Behavioral simulator. The Integrator Series ASIC design flow lists the MO modules available for each design step. The Logic Integrator, Silicon Integrator and System Integrator design packages each include a subset of these modules as standard and optional offerings. Copyright 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. 13. IJ. 2. I. L. MDE Integrator. Series Products. MDE Integrator. Series Platforms. 14. Modular Design. Environment. Design Tools. CAE Modules. Low Simulation and Verification Tools. Schematic Editor Star. Waveform Editor. Schematic Builder Star. Path Liming Analyzer. Power Analyzer. Chip Floor Planner. Behavioral Simulator. Multi-ASIC Simulator. Multi-Chip Behavioral Simulator. Standard Product Gate Modeling. Hardware Accelerated Logic Simulator. Hardware Accelerated Fault Simulator. Package Planner. Silicon Compilers. Modules included. LSI. Logic Integrator. D modules available as options. Requires graphics platform. T supports I.S micron drawn gate length technology and under. Workstations. Sun Microsystems. 3 Series. 4 Series. Contact your LSI Logic sales representative for specific configurations and availability. Silicon Integrator. D. Sun Unix. The Integrator series runs in nearly any CAE environment. The Logic Integrator runs on Sun Microsystems 3 and 4 series only. Graphics tools are supported only on Sun Microsystems workstations. Copyright 1988, 1989, 1990, 1991. LSI Logic Corporation. All rights are .served. Silicon Integrator. Overview. Features. Logic Integrator. Overview. Features. LSI. Modular design. Environment. Design tools. The Silicon Integrator is a comprehensive GLE chip design system for creating ASICs. Designed to run on high-performance multi-tasking computers, the Silicon Integrator features interactive event-driven simulation and one of the most extensive ASIC cell library sets in the industry. Graphics and multi-windowing provide a high-productivity CAE environment. Non-graphic support on popular mainframes extends the Silicon Integrator availability to most high-powered computer hardware in use today. Extensive library support. Macro cell libraries over 800 fully characterized SSI/MSI logic cells for device families. From 700 gate channeled arrays to look gate. Compacted arrays TM as well as cell-based ASICs. Megafunction and megacell libraries. Optional library set, more than 400 complex LSI building blocks, including industry standard parts and proprietary LSI logic. Functions. Precise gate-level simulation with back-end AutoIt wire lengths guarantees ASIC performance and eliminates breadboarding. Automatic error checking and reporting. Catches design problems early, enhancing productivity and manufacturability. The Logic Integrator is a low-cost entry-level system containing design and simulation tools for creating single-chip ASICs on Sun platforms. Optimized for graphic entry and multi-window tasking, the Logic Integrator boosts CAE productivity for 1.5 micron drawn gate length, 0.9 micron effective channel length. MOS channel-free trademark designs using LSI Logic's design libraries. These libraries contain hundreds of industry-standard logic elements, supporting designs with up to 12,500 usable gates. The Logic Integrator provides a low-cost entry graphic schematic editing with advanced automated features. Graphic waveform logic editing for precise interactive simulation of all or part of a design. Automatic extraction of production test programs, including patterns to evaluate timing. Sensitivity. At 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. A modular system, the Silicon Integrator anticipates a wide variety of user needs with standard features and add-on capabilities such as silicon compilation, chip sizing, hardware acceleration and PLA to ASIC cell conversion. The Silicon Integrator includes the following modules: schematic capture, waveform editor, single chip simulator, test program extraction, path timing analysis, power analysis, chip floor planning and schematic builder. Customers can select optional library support for specific applications. Automatic test program formatting for industry standard test equipment. Add-on capabilities. Design productivity tools such as Design Builder, Test Builder, and Silicon Builder. Multi-ASIC gate-level simulators. Behavioral simulators. Mixed mode simulators. Automatic test pattern generator for scan-based synchronous circuits. Chip sizer trademark. Point to the MDE design tools allowing ASIC designers to upgrade to more powerful tools and emerging technologies later. A modular expansion path offers application and design portability to a variety of hardware platforms as well as upgrades to emerging technologies and mixed-mode behavioral and gate-level multi-chip simulation. The logic integrator features near mainframe performance providing schematic capture, waveform editor, graphic entry and editing of simulation test patterns, interactive, single-chip, simulation, design verification and production test pattern extraction. Silicon-specific designs for guaranteed ASIC performance to simulation specifications. Upgrade path to silicon integrator and system integrator tools. 15. 2. 2. II. 1. Description. Benefits. 16. LSI. Design Builder. Synthesis software. Design Builder enables the designer to design complex ASICs, application-specific integrated circuits, on his own workstation or at any of LSI Logic's worldwide design resource center locations. With this sophisticated set of design tools, the designer no longer needs to worry about designing ASICs at gate level. He simply describes what he wants, be it a state machine, logic functions, ASIC memories or a data path block, such as the adder. Design Builder automatically generates optimized netlists. While designing various components of a SYN, GLE or multi-ASIC system, Design Builder allows the designer to perform quick feasibility analysis and get reliable answers to what-if kinds of questions about alternative chip sizes, packages, etc. Design Builder is fully compatible with LSI Logic's MDE registered design tools and is available on the Sun/Unix platform. Support for other platforms is available if needed. Design Builder demonstrates LSI Logic's design productivity is enhanced and ASIC development costs are reduced. First pass working silicon ensures on-time product market entry. On-site design tools offer efficient project management control and promote a team project approach and the sharing of design system resources. Copyright 1990. 1991 LSI Logic Corporation. All rights reserved. Continued commitment to right first line trademark deliv. Area of working prototypes that are verified and fully tested. Design Builder provides capabilities to implement RAM/ROM, data path logic, control log, IC, logic blocks, and logic arrays on an ASIC. Efficiency. Expert technical support is available in local design resource centers at worldwide locations. Full MDE design tools support including customer training and a hotline service is available. Overview. Benefits. Features. LSI. Chip sizer. Synthesis software. LSI Logic's chip sizer trademark software offers SYS. TEMS designers an ASIC, application-specific integrated circuit, planning environment. In this environment, designers can evaluate various alternatives in determining which system functions are ideal for ASIC implementation, the appropriate technology and die size of an ASIC, and the package requirements based on the die size and the pin requirements. ASIC. Designers can quickly perform this iterative task and document what-if type of analysis to evaluate various alternatives of system PAR. TT1ing. The versatility of the software allows expert designers to supplement the rules based on their experience. The chip sizer tool is fully automatic in effectively illustrating multiple ASIC solutions. The user specifies system components such as logic blocks, memories, lids or other elements via a user-friendly graphics interface. Then the chip sizer tool graphically displays the area allocation diagram and pad locations of various components. Ensures silicon efficiency to a high level of confidence. Analyzes design alternatives without having to describe the netlist or physical design. Describes designs as logic blocks, ASIC MEM, ORI blocks or other LSI logic library elements, such as megafunctions. Describes designs independent of the technology and helps in realizing an optimum system configuration of multiple ASICs. Bases the floor plan of the chip on place and specifies buses as global, that is, with connection between blocks, or local to a logic block. Evaluates multiple ASIC architectures by hierarchical function. Computes memories with the use of LSI logics. Design Builder offers a wide range of user-specified options within each class of logic functions. Describes designs independent of technology. Copyright 199D. 1991 LSI Logic Corporation. All rights reserved. In a system, it also allows designers to fine-tune the floor plan by moving or rotating mega cells. The accuracy of die size estimation improves with design details. Chip sizer enables users to select the best architecture by evaluating different alternatives. Root software algorithms, which can be fine-tuned using graphic commands, such as move, rotate and reshape. Allows expert designers to specify their own rules to tailor the tool to their particular needs. Can easily implement alternative technologies or design rule changes. Documents system concepts and various alternatives. Offers a user-friendly graphics interface. Can easily evaluate a given design under alternative technologies. Bases its floor plan estimation on layout design tools. Automatically calculates power pad requirements. Ensures that packaging requirements are met. And suggests suitable packages. Has full MDE registered design tool support available. 17. Overview. Benefits. Features. Description. 18. LSI. Memory. Compiler. Preliminary. LSI Logic's memory compiler software allows ASIC system designers to automatically compile memories such as multi-port RAMs, ROMs, FIFOs, ROM multipliers, or barrel shifters. The memory compiler generates megacells for cell-based products and channel-free trademark array-based products using 1.0 and 1.5 micron drawn gate length, 0.7 and 0.9 micron effective channel length, MOS technology. With memory compiler, the user can quickly and efficiently generate memories optimized for both speed and area. Memory compiler generates all the necessary data files for accurate timing simulation as well as physical layout design. ASICs with onboard MEM ORI requirements can now be implemented easily, using advanced 1.0 micron gate length MOS technology. Megacells can be compiled and implemented on user's own workstation. Fast megacell turnaround significantly reduces ASIC development cycles. Automatic test vector generation saves significant design time. Memory compiler supports both array-based and cell-based products. Memory compiler supports both 1.0 and 1.5 micron gate length MOS process technologies. RAMs can be compiled with single port, 2 ports, 3 ports, or 6 ports. ROMs can be compiled with maximum block size of up to 64K bits. Single port RAMs can be compiled in 2 types, low power RAMs with up to 4K bits max. The user specifies the memory parameters, such as words, bits, word length, number and types of address ports. As shown in Figure 1a, ASIC RAMs and ROMs can be generated in minutes using memory compiler. Risks are reduced, since megacells are write by construction. Easy to use, graphics menu interface. Fully integrated within MDE registered design tools. Has full Mo design tools support available. Technical training available from experienced staff. IMM, and 1.0 micron gate length high density. Cell-based RAMs with up to 12K bits maximum per block. High density, single port RAMs performance is competitive with commercially available SRAMs, TAA. Programmable I/OS allow easy expansion for wide data word widths such as 1632 or 64 bits. Flexible design allows for easy scan test implementation by user. 32x16 single port RAM with 1 read/write address port and an 8-bit byte write capability is specified. Megacell type, IP_RAM. RT:user environment. Technology, ForlSPA 7. Simulation model. Number of words. 32F memory datasheet/symbol layout environment. Test vectors. Number of bits. 16. Compiler. Memory log layout database. Byte write? Yes. Design verification. Topological cell. Bits per byte. 8 signal pins. V. Figure 1. Memory compiler user specifications and output files. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. Overview. Benefits. Features. LSI. Test Builder. Preliminary. Test Builder is an advanced scan design environment that reduces time to market and improves productivity for ASIC-based systems. It provides high fault coverage and performance based on the full scan design methodology. Because Test Builder is integrated with LSI Logic's MDE registered design tools and advanced manufacturing capabilities, it is the only scan design environment that provides write first time trademark silicon. Time scale for test vector development is substantially reduced. Ensures that the complex scan designs are fully testable. Increases reliability of ASICs. Generates test patterns that typically have 95% or more stuck at fault coverage. Fast and efficient built-in fault simulation and test vector generation. No additional hardware required. Full support of LSI Logic scan methodology. Checks all scan design rules automatically. Automatically converts non-scan design to scan design. Produces compact and optimized test vectors. Provides flexibility in handling special blocks, such as RAM-IRM and megafunction. Copyright 1991 LSI Logic Corporation. All rights reserved. Test Builder is an integrated scan design environment that automates creation of test vectors Tools to achieve high stuck-at-fault coverage for synchronous designs. It consists of scan, design expert, LDMC, scan design, synthesizer, LSCAN, and synchronous. Automatic pattern generator, SATPG. Eases ASICs debugging and straightforward. Timing analysis. Maximizes designer creativity and productivity by supporting higher-level design. Full software support. Easy to learn and use. Technical training available from experienced staff. Enables flexible integration of boundary scan, JTAG, scheme. Works at netlist level. Only one test pin is needed for scan-com. Paintable designs. Scan in and scan out can be multiplexed with regular 20s. Selects best scan chain order to minimize chip area overhead. Detailed summary reports. 19. Overview. Benefits. Features. Description. Availability. 20. LSI. Logic block. Synthesizer. The logic block synthesizer, LBS, is a logic design tool which significantly enhances designer productivity during the logic design phase by automating the design, verification, and documentation of common logic functions. Counters, registers, and muxes are examples of such functions that are part of almost every. Increases logic design productivity, thus reducing ASIC development costs. Data path building blocks such as multipliers and adders are available. As a result of this, data path designs can be built efficiently. Supports most commonly used logic building blocks. Generated circuits are optimized for speed or area, gate count. LSI Logic's block synthesizer generates adders, counters, muxes, incrementer/decre, mentor, decoders, shift registers, and fall-through FIFOs. The logic block synthesizer generates an NDL netlist and a file with file type or exten. Zion of dot pins, which contains the 110 signal names. The netlist can be implemented in channel-free trademark array-based products or cell-based products using 1.0 or 1.5 micron drawn gate length, 0.7 or 0.9 micron effective channel length, MOS technology. Schematic of the netlists thus generated is made available by the schematic builder software. The simulation of the whole ASIC, of which the complied function is a part, is done within LSI Logic's MDE design tools. Technology: 1.5 micron, 1.0 micron. Channel free. Array products: LCA 10000, LMA 9000, LCA 100K. Copyright 1987, 1988, 1989, 1990, 1991 LSI Logic Corporation AII rights reserved. Digital system design. With the LBS, optimized logic functions which are write by construction can be automatically generated from user specifications. As a result, ASIC systems and logic designers greatly enhance their design productivity. 13 logic functions, each with different varieties of modules supported. Hotline service is available. Fully integrated within MDE registered design tools. Technical training available from experienced staff. Wide range of user-specified options within each class of logic functions. DN line help menu available. Easy to use, menu-driven user interface. Logic block synthesizer saves designers time in building logic and data path blocks. Cell-based products. LCB15 / LCB007. Description. Benefits. Features. LSI. Logic expression. Synthesizer. Design tool. LSI Logic's design builder software includes Logic Expression Synthesizer, LA, a logic synthesis tool that helps to design high-performance ASICs, application-specific integrated circuits. LA provides an efficient means of designing finite-state machines, sequencers, and other control logic, which are essential parts of most digital ASIC circuits. It allows design description using Boolean equations, truth tables or a HDL language similar to CN. Associated register transfer level simulator allows the verification of a circuit at the design language level without a gate level translation. As a result, the design can be iterated quickly for evaluating various alternatives. Once the design is functionally complete, LA automatically builds a gate-level NDL netlist for either channel-free trademark array-based products, DR cell-based products. It also features an optimizer. With this logic synthesis tool, design saves weeks in generating gate-level netlists from higher levels of abstraction compared to the schematic capture approach. Simplifies the tracking of design details. Efficiently manages complex ASICs because logic is described in higher levels of abstraction. Optimizes the circuit for area and speed, saving designers a great deal of time. Offers an easy-to-use, flexible, high-level synthesis language. Offers multitasking capability, non-standard clocking and compile time control structures. Synthesizes gate-level schematics directly from Boolean equations and finite-state machines in Mealy Dr. Moore form. Translates truth table input similar to UC Berkeley's format into LA. Supports both combinational and synchronous circuits. Copyright 1990, 1991 LSI Logic Corpora on. All rights reserved. ERS can shorten design time to build finite state machines, data paths, and control logic circuits that are correct by construction. Logic expression synthesizer synthesizes finite state machines, control and data path logic efficiently. Is technology independent. Minimizes production costs by reducing the overall chip size due to increased silicon efficiency compared with schematic capture. Is fully supported by LSI Logic's MDE registered design tools. Offers a logic optimization capability for technology implementation to achieve high performance. Features a source-level debugger. Offers a mixed-mode simulator by translating LA models to behavioral simulation language (BSL) models. Performs static timing analysis using LCAP. 21. Overview. Benefits. Features. 22. LSI. Silicon Builder. Preliminary. Silicon Builder is a suite of design tools that automatically generates layouts of random and regular structure logic block functions. This productivity-enhancing toolset is comprised of two compilers, Data Path Compiler and Block Compiler with its powerful graphics editor, and is yet another MDE registered design tools package. Silicon Builder enables the designer to manage the design of today's and tomorrow's ASICs. Application-specific integrated circuits, by offering complete control of the design process. Because the design tools are available on his own workstation. Improved predictability of the final die size and length of the design cycle. Increased accuracy of simulation and ability to avoid costly post-layout design changes. Although Silicon Builder is targeted for ASIC designers with limited layout expertise, these flexible tools allow expert designers to influence layouts. Actual segment length information enables the designer to verify accurate. Provides access to a proven layout design SYS. TEM with over 10,000 completed designs. Guarantees right first time trademark ASICs. Offers user control off design cycle. Because designers have access to Silicon Builder on their own workstations. Allows easy sharing of design tool resources among various design projects, which significantly reduces ASIC development costs. Eliminates the need for post-layout design change and significantly increases design productivity. Saves silicon area and improves speed performance of ASICs. Offers customer support, training, and a hotline service. Provides a segment length file, SIGLEN, that allows the designer to accurately verify the timing of the compiled blocks or data path circuits. Produces optimized layouts to minimize overall die size and to improve the performance of the ASIC circuits. Allows expert designers to influence the layout so that they can meet their design goals. Copyright 1990-1991 LSI Logic Corporation. All rights reserved. Timing behavior of the circuit including setup and hold time checks. As a result, the designer can design ASICs on time with the assurance of first-time success. With Silicon Builder, high-performance ASICs can be designed quickly and efficiently. Because the designer has access to actual layout information early in the design cycle. For accurate timing verification of the functional logic blocks. 2 logic expression 2 logic block 2 schematic I. 2 synthesizer, lay, synthesizer, LBS, QRNDLNEist. I. Netlist backplane I data path compiler I block compiler I. Layout, LL3, backplane L. Topo cell siglen -1 L3. Floor planning back annotation artwork. Figure 1. Silicon Builder enables ASIC design ERS to build block layouts efficiently, regard less of their expertise in layout. Features a powerful layout graphics editor. GE, with built-in design rule checking. Features a graphics editor with a rich command set that offers great flexibility in the interactive layout process, while ensuring compliance with design rules. Overview. Benefits. Features. LSI. Data Path Compiler. Preliminary. Data Path Compiler is a specialized Silicon Builder design tool that automatically generates optimized layouts of regular data path structures for cell-based and array-based ASICs, application-specific integrated circuits. Its flexibility permits easy handling of designs with regular multi-bit logic elements connected by buses and non-bit slice structures. Unlike conventional approaches to data path compilation, the designer is not restricted to a limited set of cell library elements or a specific design description tool. Data paths can be efficiently described using the powerful schematic editor, LSED, and MDE registered design tool. Alternatively, data paths can be described using a high-level design language. For example, logic block synthesizer, LBS, one of the design builder design tools, can be used to automatically generate NDL netlists of data path elements, such as adders and muxes. Data path compiler accepts a netlist of the design, provides quick, enhances system performance because optimized layouts are produced, minimizes costly post-layout design changes. Because data path circuits can be accurately verified at an early stage, gives the designer complete control of the design process, increases design productivity, thus reducing ASIC development costs, provides expert technical support at world-wide design resource center locations, offers full MDE design tool support, including customer training and a hotline service, provides feedback on area estimation and wiring efficiency, compiles data paths at cell or chip level, allows routing of signal nets over the compiled data path megacell, allows expert designers to use LSI logics, powerful graphics editor, GE, to modify the layout manually, supports non-uniform bus widths and interbit slice wiring. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. Feedback on size estimate and wiring FECN. SI, and generates a completed layout along with wire segment information for accurate timing simulation. Data path compiler produces dense layout data apathy blocks by taking advantage of the regularity of structures and generates wire segment information for accurate timing verification. Netlist backplane IGL backplane. Figure 1. Data path compiler generates layout and segment length information for accurate timing verification. Is compatible with logic block synthesizer LBS, to allow automatic generation of data ADH elements, such as adders, incrementers / decrementers, registers, muxes and decoders. Supports 1.0 and 1.5 micron drawn gate length, 0.7 and 0.9 micron effective channel length. MOS channel free trademark array-based and cell-based products. Allows easy use of graphics interface. 23. Overview. Benefits. 24. Block compiler. Preliminary. LSI. Block compiler is a specialized silicon builder design tool that automatically generates optimized layouts of random logic blocks for channel-free trademark array-based or cell-based ASICs, application-specific integrated circuits. Block compiler offers control of the layout process during the ASIC design phase. Block compiler accepts a flat or a hierarchical netlist of functional blocks. It then places all of the cells and root signal nets within the block, including clock lines and power buses, automatically. ASIC designers with limited layout expertise benefit from the use of block compiler because the compiler produces block layouts that are 100% executed. At the same time, this flexible tool allows expert designers to interactively influence the layout and meet performance goals. With block compiler, sections of the design, including the physical layout, are fully implemented. Actual wiring information is quickly made available by the compiler to facilitate accurate timing verify cation of the blocks. As a result, designers are able to predict both the size of an ASIC and its performance at an gives ASIC designers complete control of the ASIC design process because it's available on their own workstations. Produces optimized layouts, which enhance system performance. Verifies critical sections off-circuit with accuracy at an early stage, therefore, no major surprises are encountered when the chip layout is completed. Eliminates the need for costly design iterations. And greatly enhances design productivity, resulting in minimized ASIC development costs. Offers full MDE registered design tool support, including customer training and a hotline service. Copyright 1990. 1991 LSI Logic Corporation. All rights reserved. Early stage rather than at the chip layout completion stage. Any design changes in the post layout stage have an adverse effect on design schedules. Block compiler virtually eliminates costly design iterations, allowing timely market introduction of products. As a result, design productivity is enhanced. Block compiler produces finished layouts of logic blocks and generates wire segment information for accurate timing verification. Netlist backplane layout, LGL, backplane --= Figure 1. Block compiler provides an easy and efficient means of bridging the netlist and layout, LGL, backplanes. Service description. Features. LSI. MO. Support service. LSI Logic's MO support service offers a comprehensive software support and maintenance package for MO users. The service is the MO support service offers the following benefits to the customer. Hotline support. A dedicated, toll-free hotline is available for MO support service subscribers, 1.800.mo.4545. Customers designate one primary and one alternate contact who may place direct calls to the Technical Support Center. Knowledgeable design. Tool engineers are ready to answer software questions and if software problems arise, assist in resolving them. In addition, users may report enhancement requests for the design tools through the hotline. This service is not intended to replace or augment customer product training. Periodic software updates. Customers will receive regular updates to their MO design tools. These updates include revisions covering enhanced software functionality, support of new hardware operating systems, documentation updates and corrections to software problems. If a critical software problem is encountered, every effort is made to correct the problem and update the user with a software patch required for each computer node authorized to run MO design tools. Periodic library updates. Technology libraries are updated on a regularly scheduled basis. Changes reflected in these library updates can affect design performance and functionality. MO Design Tools User Conference. An annual conference allowing MO users from across the country to meet with LSI Logic's management, engineering, and CAD engineers to discuss various design issues ranging from future Design tool requirements to current customer. Case studies. The conference is free to all Mo support service customers. Note, the Mo support service does not cover hardware or operating system problem support. Installation services and system consulting are available at an additional cost. Copyright 1988, 1989, 1990, 1991 LSI Logic Corporation. Alright. Rev 25. Overview. Overview. 26. CDE/MG. Co-designer. Software for Mentor Graphics. LSI. Co-designer at environment for Mentor Graphics. CDE registered/MG, software allows the user to design. LSI Logic ASICs, application-specific integrated circuits, accurately in the Mentor Graphics environment, enhancing its capabilities by coupling LSI Logic's design methodology with Mentor Graphics tools. CDE/MG software is the result of an engineering partnership between LSI Logic and Mentor Graphics, where both parties ensure that their software and libraries work together. Designing high-performance gate arrays and cell-based ASICs requires accurate timing for successful design implementation. The designer also needs to simulate at the system level to ensure the ASIC works correctly with the other components of system. CDE/MG software features quality silicon specific IC timing within the Mentor Graphics environment. CDE/MG is fully integrated with LSI Logic's advanced manufacturing capabilities. The result is compatible with LSI Logic's modular design. Environment software uses Mentor Graphics simmed and netted for schematic capture. Uses Mentor Graphics QuickSim for simulation. Translates automatically hierarchical netlist between Mentor Graphics and Mo software databases. Offers CSM, the co-designer scheduling monitor. Mentor Graphics COLMG is an ASIC that can be manufactured with LSI Logic's right first line trademark assurance. Floor planning map of a chip. Preparatory to full layout. The blocks have been placed by Floor Planner trademark software, an MDE registered design tool. Making CDE/MG software easy to use results in Mo software quality design sign-offs. Back annotates to QuickSim for accurate SYS. TEM level simulation. Includes low simulation and verification. Floor planner software and bonding diagram programs. Supports selected LSI Logic technology libraries. Assures LSI Logic right first line silicon. Figure 1. Using CDE/MG software in the Mentor Graphics environment. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. Introduction. Block diagram. LSI Verilog Design Kit. The coupling of general-purpose EDA software along with silicon-specific software in the design of ASICs, application-specific integrated circuits, is becoming increasingly popular with electronic designers. The Verilog Design Kit from LSI Logic supports the use of Cadence's popular and highly regarded Verilog XL simulator in conjunction with LSI Logic's MDE registered design tools. Now with the Verilog Design Kit, ASIC designers have a way to blend their Verilog simulator with MDE software. This is yet another example of LSI LSI Verilog Excel. Logic. Libraries. LSI. Logic. Libraries. LSI Logic. Estimated. Delay. Table. Design. Source. Files. Verilog. Data. Structure. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. Logic's open systems architecture, whereby general-purpose EDA software is bridged to silicon-specific MDE software. The results are superior, high-performance ASICs that are designed quickly with right first-line trademark ASUR. ANS. Verilog Design Kit was written by LSI. Logic's software and model development engineers working with their counterparts at Cadence, the Verilog vendor. Interface. Software. Simulation. Control. Files. Net. Files. MDE. Post. Layout. Delay. Files. 27. 1. JL. I. J. I. Overview. Benefits. Features. 28. LSI. Synthesis. Synthesis libraries. The LSI Logic/Synthesis libraries offer the user of the Synthesis design compiler software a link to LSI Logic's ASIC, application-specific integrated circuit, technology and manufacturing capability. A synthesis library, written in Synthesis library language format, contains the timing and functional description of LSI Logic macrocells.lt also contains the definition of environmental delay conditions and wire loading tables. Each table is associated with a die and a package. The synthesis libraries are developed in cooperation with Synthesis to effectively exploit the synthesis and optimization capabilities that the Sign compiler offers. LSI Logic/Synthesis libraries are designed to incorporate MDE registered design tools delay estimation techniques into the process of logic synthesis and optimization with the Synthesis design compiler. Complex LSI logic designs may be synthesized and optimized using process specifications that are offered and maintained by LSI Logic. Accurate timing and modeling. Ease of use and compatibility with most software, logic expression synthesis, design, compiler, etc. Environmental condition scaling factors for delay calculation, i.e., BCOM, COM, NOM, etc. Wire loading tables specific to each die code. Default scaling factors. Macrocell definitions. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. The synthesis libraries software includes NAL macrocells only. Timing and logic information represents specification of most software and its libraries for use with design compiler. Most software simulation and design verification are required for design acceptance at LSI Logic. Synthesis design compiler uses timing models and embedded synthesis strategies in the LSI Logic synthesis library to generate optimized netlists. Cost savings at implementation. Specifications for delay calculations under specific environmental conditions. Instructions for design compiler to adopt native algorithms or actions to comply with LSI Logic modeling strategies. Description. Features. Diagram. LLC. LSI. Valid logic. LCA 10000, LMA 9000. Libraries. The Logic Library Connection, LLC, Design. Interface supports front-end design of LSI. Logic's channel-free trademark array and cell-based. ASICs, application-specific integrated circuits, on valid logic workstations. The LLC interface provides the graphics sim. Bowls off macro cells to support graphics capture. It also provides simulation models that allow the designer to simulate on the valid logic workstation. Once complete, it provides interface software to manage the transition to LSI logic when the design is ready. It generates a network description language, NOL, file for LSI logic's MDE registered design tools. In addition, valid logic simulation outputs are converted to simulation control files, test pattern files and simulation listing files suitable for transfer to MDE software. Interfaces with valid logic schematic cap tour, valid GED. Interfaces with valid logic's valid SIM simu Lashin environment. Offers the LCA 10000 Macrosela library. Offers the LMA 9000 Macrosela library. Includes macro cell elements. Has high drive buffers available. Has configurable buffers available. Valid logic. Symbol and network editor. LCA 10000. LMA 9000. LCB 15. Macro cell. Libraries. Copyright 1989-1990, 1991 LSI Logic Corporation. All rights reserved. Where they will be used to test the chip and to compare and verify with MDE software simulations. For the LCA 10000 and LMA 9000 libraries, the gate delays may be modified as functions of fan-out, voltage, temperature, processing parameters and estimated wire lengths. For the LCB15 library, the gate delay is fixed, assuming no wire length contribution and worst case commercial conditions of 70 DC, 4.75 V, and plus 50%. Worst case process. ASIC designers can use the valid logic tools to capture and simulate an LSI logic design prior to transferring to MDE software for final simulation, design rule checks, sign-off, and layout. This can either be done on-site or at one of LSI Logic's design resource centers. Generates NDL file with complete design hierarchy. Generates simulation source files for function AL test, parametric test, 3-state functional test, and IDD test. Generates expected simulation results listing. Generates logical states for all outputs at end of each simulation cycle. Checks pulse width, setup, and hold violations. Under worst case commercial conditions. Simulation. Listing files. Simulation. Control files. Test pattern. Files. Net file, or MDE software. 29. LICAD Corporation. IKOS Systems. ViewLogic. Systems Incorporated. 30. LSI. Other third-party interfaces. Support for LE, FE, and XP hardware accelerators. All technology libraries supported. Support for 800/1900 hardware accelerators. And simulation environment. LCA 100K, LCB 007, LCA 10000 technology. Libraries supported. Certified LCA 10000 and LMA 9000 libraries. Megafunctions and memories supported. Sun 4 platform supported. No memory or megafunction. At present, Sun 4 and Sun 3 platforms supported. Sold by ViewLogic directly, contact ViewLogic. For ordering information. Note, customers should contact LSI Logic for more information regarding third-party interface offerings. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. LSI. Design Services. Overview. Basic building blocks. Individually licensed. Building blocks. Netlists. Building blocks. LSI. Design building blocks. Design services. LSI Logic supports an extensive library of design building blocks. Complexities of the devices in this library range from gate level macrocells and macro functions through function level megacells and megafunctions, all the way up to system level megacores. Designers can choose from almost 1000 cells including flip-flops for special scan configurations, hard-coded functional elements, RAM and ROM. LSI Logic has the industry's largest collection of design elements included with every technology library purchased. Design elements include everything from flip-flops, shift registers, 110 and internal buffers, latches, clock drivers, clock prescalers, oscillators, FIFOs, UFOs, and arithmetic functions, to multiplexers, synchronizers and RAM and ROM. Configurations. Many basic megafunctions are complex. Megafunctions add significant value to LSI Logic's product offering. These functions are sold individually because of their added value. The megafunction lists in the library catalog are shown independent of technology. Net lists are available for most megafunctions. Megafunctions. Arithmetic functions. Datacom functions I. Microcontroller I. Shifters I. 29XX/29XXX I. 82XX/82XXXI. Copyright 1991 LSI Logic Corporation. All rights reserved. Configurations and multiplier configurations. In addition, there are almost 200 significant megafunctions, including military microprocessors, AMD, Motorola and Intel compatible devices, all types of data communications and microcontrollers, as well as a plethora of arithmetic functions. For further information, please see LSI Logic's Cell Development Datasheet and Design Building Block Catalog. Also provided as an integral part of every technology library along with macro cells, macro functions, megacells, and metal megacells. LSI has a technology library for every technology supported. Technologies currently include the LMA 9000, LCA 10000, LDD 10000, LCB 15, LCA 100K, LCB 007, LI 100K and LRH 10000 and as LSI introduces new technologies, new libraries will be available to support them. Not all megafunctions are actually available at the present time in all technologies. Translation into other technologies or conversions into rad hard technologies or metal megacells can Be done on a case-by-case basis. A netlist license agreement is required. --1 adders I. ALUs. Comparators I. Multipliers/dividers J. FIFO/LIFOs. I. PCED functions J. UARTs I. 68XX. I. Miscellaneous I. 33. Overview. Benefits. 34. LSI. Cell development. Design services. LSI Logic has the industry's largest collection of library elements for designing array and cell-based ASICs, application-specific integrated circuits. LSI Logic Cell Development Design services are prepared to design customer SPE-specific elements ranging from macro cells to circuit performance can be dramatically improved by incorporating macro cells that efficiently fit the architecture of unique system designs. Variations in setup and hold time between register element instances caused by layout differences can be reduced by hard coding the logic surrounding those register elements. Features for register elements such as set direct, scan control and input data multiplexing can all be handled in this manner. Gate level. Megafunctions. Commonly developed cells include flip-flops for special scan configurations, hard-coded functional elements, new RAM and RDM configurations and multiplier configurations. LSI Logic has a significant number of unique RAM and RDM configurations in the megacell libraries. These memories are constructed in an efficient manner optimizing area and speed. LSI Logic will create the correct size or number of access ports for memories needed by designers. Function level, system level. Complexity of building blocks. 1990-1991 LSI Logic Corporation. All rights reserved. Overview. Benefits. Features. Software. Full scan testing. And ATPG. Design services. LSI. LSI Logic supports full scan testing on designs which meet our published guidelines. The customer may supply his/her own vectors or purchase the scan ATPG, automatic test pattern generation, design service option. Purchase of. When compared to ad hoc test generation, scan-based designs reach higher fault cover age in test programs with far fewer engineering hours spent developing test vectors, reaching 99% stuck at fault coverage with less than 3 hours of CPU time is common for scan ATPG. This results in a higher quality product that reaches market faster. Design for testability, DFT, is becoming increasingly important to the overall success of new SYS. TEMS, and scan-based design is the most mature DFT technique. A device can be tested with scan-based tests while it is resident in the LSI Logic has developed a comprehensive methodology for designing a fully synchronous scannable device, and has attained a high level of expertise in scan design methodology. LSI Logic has successfully delivered hundreds of scan-based designs. The software enhancements to the MDE registered modular design environment registered design tools for ATPG include a design methodology checker, LDMC, and a scan chain creator, LSCAN. These software programs allow Greater flexibility for the designer to select scan elements and connection order manually, or to allow the software to make the selections. During the layout process, the scan chain order can be optimized to reduce routing congestion. ATPG algorithms, such as the D algorithm, are well known for scan-based designs and have attained very high fault coverages, even 100%. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. The Scan Chain Creator Program, LSCAN, and the Design Methodology Checker Program, LDMC, provides optimal methodology support. Circuit board. Scan-based tests can be implemented for boards and systems by incorporating boundary scan onto the devices. LSI Logic offers Scan ATPG as a service to those customers who don't have ATPG software themselves. Customers can now take advantage of all the benefits of scan-based DFT without having to make the capital expenditures or learn the complexities of the ATPG software. Customers can rely on the LSI Logic expertise of right first-time trademark success for scan-based testing. LSI Logic has invested significant resources in scan design software, layout programs, tester hardware, documentation, and other support functions. Customers can leverage the significant investment in their designs by utilizing our tools and services. LSI Logic uses a modified D algorithm, FAN, as well as other heuristics. Full scan design requires all memory elements, flip-flops or registers, to be directly controllable through the scan chain, which causes the circuit to appear completely combinatorial, logic. All buried states in sequential machines are thus controllable and observable, thereby making ATPG practical. Partial scan, where some oft-register elements are not part of the scan chain, is not supported in the LSI Logic full scan methodology. An entire test pattern can be automatically generated in a matter of hours, with fault coverage from such ATPG runs consistently above 97%, and often above 99.5%. 35. IL 2L 1 backslash 2 backslash overview. Benefits. 36. Fault grading. Design services. LSI Logic's fault grading design service combines state-of-the-art software with hardware acceleration to provide a cost-effective quality improvement methodology. Through fault grading of the test patterns, the designer can determine the effectiveness in detecting potential manufacturing defects. The results of fault grading simulation can be used as a tool to modify the test program and increase the fault coverage. This improves the quality of LSI Logic's fault grading design service. Addresses the complex issue of assessing test vector completeness. By utilizing this fully INTE graded environment, the designer doesn't need to learn any additional procedures, methodologies, or languages. This saves time and reduces potential sources of errors that can occur with complicated translations. The fault simulations are performed on XiCAD hardware accelerators using fault models that are built into LSI logic macro cell libraries at the primitive level. The XiCAD simulator is socketed into the MDE registered design tools. Studies show that high fault coverage test programs are directly related to higher quality LEF/LS and lower defect rates in end products. This saves significant production costs by reducing yield loss, returns, and repairs of electronic equipment. Product quality is becoming a product differentiator with ever-increasing importance. Reliance on tools such as fault grading is becoming more important in managing the increasing complexity of ASIC application. Specific integrated circuit design. Copyright 1990-1991 LSI Logic Corporation. All rights reserved. Tested devices. Simulation and design files are sent for fault simulation processing to compute accounts in Milpitas, California, or other design centers where XiCAD hardware accelerators are located. Reliable, accurate and convenient fault simulation based on exhaustive or statistical methods is provided, accompanied by comprehensive, easy to analyze reports. Unless a structured design approach, such as scan test, is used, the responsibility of the test program is in the hands of the circuit designer, rather than the ASIC manufacturer. Therefore, the quality of the product delivered will depend on how thoroughly a functional test can be produced by the designer. LSI Logic helps the designer by providing industry-leading tools and services to attain the highest level of ASIC design and quality. Many designers rely on high-node toggle coverage to obtain quality test programs. LSI Logic design methodology requires that a designer obtain 100% node toggle coverage, but this does not ensure the highest possible fault coverage, and therefore, quality. In order for the test program to be effective in detecting potential faults, each toggle node must have the GLE data propagate to an output pin of the device. This fault observability is what fault grading checks for, and why only high fault coverage, not node toggle coverage, can guarantee high quality end product. Overview. Benefits. Features. Support. LSI. SPICE models. Design services. LSI Logic supports SPICE IO models for licensing to customers. Models are available for most technologies. These models are for IO cells. The SPICE IO models simulate the output characteristics and input capacitance of LSI Logic IO buffers. The designer creates his own circuit board simulation to check the operation off-board level circuit. This can also be used for what-if calculations. When there is heavy capacitance, long traces, or concern about round-trip delay and signal integrity, reflections and ringing, in a board design, the designer can use SPICE simulations to analyze circuit operation. SPICE IO models are comprised of sub-circuit and transistor parameter text files compatible with Meta Software's SPICE, version H8701 or higher. Models for slew rate control versions of output buffers are included in the library. Each IO buffer is formed by sub-circuits. For instance, the BT4 is constructed of a pred river, an inverting buffer and a clamp diode. Each of these Subcircuits is constructed of P and N transistor. Models. Transistor models exist for all process. Variations. NRD NRS. Bulk VTO. XLWD. UEXPUTRA. VMAX Delta. MJSWOGDO. Maintenance service for SPICE I/O models is not required. The models are considered STA. BLE and do not require updates. Questions regarding these models should be directed to your local applications engineer. Any questions regarding use of SPICE should be directed to Meta Software in Campbell. Copyright 1990-1991 LSI Logic Corporation. All rights reserved. Only, not internal macro cells. The models are designed only for use with Meta Software. SPICE, not Berkeley SPICE or PSPICE. Simulations can be run for worst case, weak N, weak P, and best case, strong N, strong P. Conditions of the P and N transistors. LSI logic guarantees that silicon passes LDS at MDE registered design tool simulator approved tests, which specify output buffer delays into a lumped capacitance rather than to SPICE simulations. Test programs for all designs are Gen. Errat from MDE design tools and cannot be modified to reflect SPICE results. Nominal. Weak. Strong. Weak and strong P. Strong and weak P. Parameters for poly and metal capacitance are also included. The P and N transistor models include the following parameters: ACMHDIFK pop, TOX, XW, XJ, CJ, OGSO, NSUBLD, UOUCRIT, RSHNEF, MJCJSW, OGBO. California, phone number 800-346-5953 or 408-371-5100. LSI Logic is unable to support any questions arising from usage of these models in software other than SPICE. 37.1. 2. Overview. Standard layout. Merge layout. Trial layout 4. Speed evaluation. 38. LSI. Layout. Design services. LSI Logic offers custom tailoring of every design through the use of proprietary, state-of-the-art layout design tools, optimized for both our array-based and cell-based ASIC. Application-specific integrated circuit, prod. UCTs. Several levels of layout complexity are offered, enabling a choice of cost/performance solutions. The standard layout is included with every NRE for a new design. The merge layout included in every new design NRE is the standard layout. LSI performs a comprehensive series of procedures to ensure a clean, efficient layout for every design. There are over 30. A merge is when a small change is made to a completed layout. That is, the change is merged into the original database. Merges only work for very small changes in the netlist. Even a relatively small change may not work if the change causes a chain reaction to many more nets that drive it, or are driven by it. The wire length estimates for pre-layout simulation generated by LSI's floor planner trademark program are generally adequate for simulation of most designs. However, some design architectures are dependent on precise delay path predictions. The designer in these cases must make design trade-offs based on the precise delay path predictions before handing off the final netlist for layout, ECR. This is much different than creating the fastest possible layout configuration, defined as the optimum total delay sum on all nets in a design, which can be done without going through a trial layout phase. The customer must determine whether or not this kind of trial layout is necessary for the design objective set. There are two ways of performing trial layout. For speed evaluation, auto route only, leave the drops unconnected. Finish all nets, connect the drops as in a full layout. Copyright 1991 LSI Logic Corporation. All rights reserved. Is for small changes to an original LSI netlist. Trial layout has two types. One type of trial layout is for timing performance evaluation and another is for determining die size. Custom layout is for designs pushing the limits of the standard design criteria. These designs will require handcrafting of the layout in order to meet extraordinary design objectives. Steps in LSI's layout procedure. Each step must be signed off along the way, ensuring a quality layout is achieved. Maximum merge amount is 50 macrocells or 100 gates. There is no limit when gates are subtracted. However, any design over 40% utilization is not eligible for a merge layout. This is because in larger designs the chain reactions increase beyond routability. The cost difference between the two options can be significant since finishing the drops will be time-consuming and involves manual intervention. In the case of auto route only option, any critical net necessary for timing analysis is so noted and completed first. This produces a SIGLEN file with only the complete nets. The unconnected nets must have timing information inserted from the pre-layout estimated file. When a timing analysis requires all nets to be completed, the full standard layout procedure is completed in its entirety. A SIGLEN file contains actual wire lengths. This is used by LDEL to calculate the delay times for back annotation into MDE registered design. Tools for precise timing analysis. Overview. LSI facilities. Consulting support. On-site applications. Support. LSI applications. Engineering support. Design services. LSI Logic has produced over 10,000 ASIC application-specific integrated circuit designs. To date, LSI offers the support of the most experienced field applications engineering organization in the ASIC industry. This resource is available. LSI Logic operates 39 design centers worldwide. These facilities include the latest high-performance workstations available for customer use. Customers may use this equipment without making the capital budget expenditures, while gaining access to the latest LSI Logic MDE registered design tools. LSI Logic has extensive system-level architectural experience. Major workstation suppliers have designed multiple LSI Logic ASICs into their most advanced workstations. Architectural partitioning at the system and chip level was accomplished with the aid of LSI Logic experience and expertise. LSI Logic Is expert in many different system design disciplines, including architectural partitioning, design methodologies. LSI logic applications engineers may be sent to the customer's site to perform any of these support functions. If there will be substantial interaction between customer and vendor engineers, it is more convenient to tackle these situations directly at the customer site, where the work is being performed. Copyright 1991 LSI Logic Corporation. All rights reserved. Able to our customers at different levels of support as stated in the purchase agreements. It is also possible to obtain applications support services for specific objectives. Applications engineers are available for consultations whenever the customer is engaged in design activity at the LSI Logic facilities. This is particularly valuable for first-time MDE design tools users. All LSI Logic MDE design tools are available for use by customers at design centers, although the usage fee may vary depending on the type of software desired. Testing methodologies. SPICE analysis of board-level interconnects. Clock distribution architectures. Technology assessments/trade-offs. Design system configurations. The basic design flow for ASICs has not changed much over the last few years. What has changed is the migration in the bulk of design task to earlier in the design cycle. The proper decisions at the early stages of the design will pay huge dividends later. Applications engineers may be assigned full time to a customer site for extended periods of time if warranted by the size and scope of the design effort. 39. Array-based ASICs. Description. LCA200K compacted Array Turbo Series. Preliminary. LSI. The LCA200K compacted Array TM Turbo Series is a submicron array-based MOS product family offering extremely high performance and density. The LCA200K is manufactured using 0.7 micron drawn gate length, 0.55 micron effective channel length silicon gate MOS technology. The advanced feature size of the LCA200K translates into high performance with gate delays of 270 ps and maximum flip-flop toggle frequency of 300 MHz. LSI logic. Proprietary library elements such as the phase locked loop for minimizing system clock skew and new high-performance I/O dramatically increase system performance capability. The LCA200K utilizes LSI Logic's channel free trademark architecture, which constitutes an array core filled with potentially active transistors connected through either two layers of metal interconnect in the LCA200K product line or three layers in the LCA210K product line. Integration of cache memories and microcode is possible through customer-defined memory capability up to 36K bits of SRAM and 160K bits of ROM. The largest master slice is capable of integrating 32K bits of SRAM, 16K bits of ROM, and over 100,000 random gates. LSI offers one of the largest libraries in the industry, including SSI/MSI circuitry and complex industry standard Intel, AMD and Motorola functions, as well as SPARC and MIPS microprocessors and peripherals. This robust library yields many distinct architectural solutions to a given system design, allowing the designer to make performance, functionally, tie and cost trade-offs. Copyright 1991 LSI Logic Corporation. All rights reserved. The LCA200K is supported by LSI Logic's Pro Prietary Seamd concurrent modular design environmental design system that allows a design to be captured and simulated prior to fabrication. New enhancements in the delay prediction scheme utilize piecewise linear modeling of cell outputs as well as considering cell input ramp times and thresholds, providing accurate delay modeling and enabling the designer to access the true performance capabilities of the LCA200K. Optimum performance and efficient layout are assured by consideration of the design hierarchy during the simulation phase of the design. Cell compilation, floor planning and hardware acceleration are available to expedite the design of ASICs. Application-specific integrated circuits low up to 200,000 random gates. Typical LCA200K compacted array turbo device. 43. Description. Features. 44. LSI. LFT150K fastest array series. Preliminary. The LFT150K fastest trademark array series is a unique array-based ASIC, application-specific integrated circuit, product line incorporating the patented cross-check technology. This new family of arrays provides the customer a new design for test, DFT, methodology that transparently generates a very high-quality test in zero test development time. This enhances designer productivity and reduces the time to market. The fastest array series is suited for high performance, complex applications where quality, reliability, fast time to market, and time to production are driving requirements. All design styles are supported from totally asynchronous through to completely synchronous with a GLE clock. A wide spectrum of applications are enabled by the fastest array series to enjoy the benefits of the ASIC technology without compromising test. The core of the 4 master slices consists of an array of proprietary C of gate cells that support the extensive macrocella library of the compacted array TM products offered by LSI Logic. The performance of each cell is not altered by the cross-check technology, providing the designer with a solution to critical timing problems in complex designs. The MDE registered design tools achieve extremely high utilizations of the arrays, providing support of design complexities from 30,000 to 80,000 used gates. LSI Logic's proven experience at implementing complex designs is enhanced by the cross-check technology to provide very high fault coverage with no additional effort. The periphery oft arrays have proven quality test transparent to the designer in zero time. Observability of real manufacturing defects. Greater than 98% stuck at fault coverage. Comprehensive fault modeling capability. Highest performance structured test solution. Test vector generation service. Copyright 1991 LSI Logic Corporation. All rights reserved. Tours that support all of the I/O functions such as TTL and CMOS compatible inputs, multi-drive and slew rate controlled outputs, 3.3V, and ECL interface I/OS that are supported in other LSI Logic compacted array series. The hardware implementation oft embed DED cross-check structures is supported by a suite of software tools that performs fault grading and ATPG to achieve a test tape that verifies the design. The software has been fully integrated into the MDE software, which allows designers to work productively due to familiarity with a widely used and interfaced platform. Typical LFT 150K fastest array device. 30K to 80K usable gates and up to 4141/0S. 4 fastest array master slices, with cross-check technology. Qualified 1.0 micron CMOS process technology. Fault simulation and ATPG tools integrated with MDE design tools. Description. Features. LSI. LCA 100K compacted Array Plus series. The LCA 100K compacted Array Plus trademark series is an HMOS array-based ASIC application specific integrated circuitable product offering. Extremely high performance. The LCA 100K series is manufactured using 1.0 micron drawn gate length, 0.7 micron effective channel length silicon gate HMOS technology. 12 master slice options provide from 6,580 to 234,916 equivalent gates. 2 layers of metal interconnect are used to implement circuits of greater than 100,000 gates in complexity. LSI. Logic's channel-free trademark architecture is employed in the array core, which is completely filled with potentially active transistors. A total of 438 pads are available on the largest master slice for use in most industry standard packages. The LCA 100K is ideally suited for system-to-silicon integration, sophisticated simulation algorithms incorporated in LSI Logic's proprietary MOAT design tools allow very complex circuits to be accurately modeled prior to fabrication. Optimum performance and efficient layout are assured by consideration of the design hierarchy during the simulation phase of design. Cell compilation, floor planning and hardware acceleration are available to expedite the design of very large ASIC chips of over 100,000 gates complexity. Applications for highly integrated array products such as the LCA 100K compacted array Plus series include proprietary CPU designs, greater than 100,000 usable gates, silicon gate, 1.0 micron gate length, HMOS technology, channel-free architecture for maximum layout flexibility, fully integrated with LSI Logic's MO design tools, high-speed performance, 350 PS average. Through high drive NAND, ND2 Pi gate 430 PS. Average through standard drive 2 input NAND gate. Standard load equals 2, VDD equals 5V, Ta equals 25 degrees Celsius. 12 array sizes from 6,580 gates to 234,916. Available gates. Up to 418 signal I/O with choice of input, output, or bidirectional buffers. HMOS or TTL input levels. Copyright 1987, 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. And artificial intelligence processors. Parallel processor designs can benefit substantially from the high gate density of the LCA look. Applications formerly implemented with software, such as image processing and speech Recognition/synthesis algorithms can be poor. Formed in real time with the speed and density. Oft LCA 100K. These high-speed CMOs arrays allow digital signal processing to supplant all but the most advanced analog processing techniques. Typical LCA 100K compacted array plus device. Schmidt trigger inputs. Configurable output drive up to 48 mA. With slew rate, DV/DTL control capability. 3.3 VIO interface capacity. Power dissipation 3.0 f.lw/gate/MHz. Compilable ASIC memory, up to 32K RAM/128K. ROM I plus logic implemented on one chip. Extensive library of macro cells, macro functions, megafunctions and standard memory. Configurations. Over 400 macro cell and 300 megafunction. Types available. Standard and high drive. Versions of macro cells and macro functions. For speed and gate usage optimization. Full netlist compatibility with all other LSI logic. ASIC products. 45. 2. I1. IL1, /. I11. I. Description. Features. 46. LSI. LI 100K. Embedded Array Series. The LI 100K Embedded Array TM Series is an HMOS ASIC, application-specific integrated circuit, product which combines the benefits of cell-based and array-based ASICs. Design SPE. SIFIC, standard cell format embeddable cores. Offer high density and performance rivaling full custom design methodologies. Memory, micro processors, mega cells, and any user-defined semi-custom cores may be placed in any location on the user-defined master slice. The remaining area is filled with potentially active transistors. Using LSI Logic's channel-free trademark architecture. The LI 100K series is manufactured using 1.0 micron drawn gate length, OJ micron effective channel length, silicon gate HMOS technology. This technology provides the advantages of yield speeds with the lower power consumption and the higher noise margin characteristics of CMOS technology, with the added capability to incorporate very high-density cell-based memory blocks. LI 100K embedded arrays offer an effective, high-performance, high-density design capability to implement virtually any digital logic design. Silicon gate 1.0 micron drawn gate length. HMOS technology. LCA 100K compacted array plus trademark series proto. Turnaround time. Array production lead times available through wafer bank program. LCB007 series of cell-based ASIC density and performance. Up to 150,000 equivalent gate capacity. Up to 422 signal I/O. High-density memory blocks. High-speed static RAM up to L44K bits. Up to 5 ports available. Contact programmable ROM up to 1 M bits. Megafunctions, soft-coded LSI and MSI building blocks, including RISC microprocessors and floating point controllers. Motorola, Intel, and AMD peripherals. Communication controllers. Generic adders, multipliers, MACs, and CAMs. Barrel shifters, FLFOS, UFOs, and ALUs. All megafunctions may be converted into megacells, hard-coded large building blocks. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. Li 100K Embedded Array Series device. The Li Look Embedded Array Series offers the very high density and high performance of a cell-based ASIC design, with gate array. Turnaround time. Extensive macro libraries. Hierarchical functional placement. Clock driver distribution methodology. Full netlist compatibility with all other LSI logic ASIC products. Full military capability. Fully supported by LSI Logic's MDE registered design. Tools. Description. Features. LSI LCA 10000. Compacted Array Series. The LCA 10000 Compacted Array TM Series is an HMOS semi-custom technology offering speed performance equivalent to 10K ECL, combined with very high gate counts. The LCA 10000 series is processed using 1.5 micron drawn gate length, 0.9 micron effective chan length, 2-layer metal HMOS technology, and is based on a channel-free trademark array, completely filled with potentially active transistors. Densities from 25,740 to 129,042 equivalent. Gates are offered. Up to 348 signal/OSR. Available from the larger members. The speed and range of gate counts available in the LCA 10000 series make it ideally suited for achieving system-to-silicon integration. Sophisticated algorithms incorporated in LSI Logic's proprietary MDE registered design tools allow a circuit designer's modular hierarchy to be utilized to its maximum potential by performing an optimized functional placement of these building blocks, and then collapsing and compacting them to minimum size. Substantial benefits are realized in both device speed and silicon area utilization. Output buffer drive strengths of 1, 2, 4, 6, 8, 12 RNA and 24 RNA, 24 RNA available with commercial specifications only, are available, and up to 50,000 usable gates. 1.5 micron silicon gate length, 2-layer metal HMOS technology. Speeds equivalent to 10K ECL, 450 PS through. High drive NAND, ND2P, gate, 550 PS through. Standard drive, 2-input NAND, ND2, gate, stan. Dard load equals 2, VDD equals 5V, Ta equals 25 degrees Celsius. Up to 348 signal I/O capability. Extensive library of over 400 macrocell and 300 megafunction types available, as well as stan. Dard memory configurations, standard and high drive versions available for speed and gate usage optimization. 6 array sizes from 25,740 to 129,042 gates. Fully integrated with LSI Logic's MDE design. Tools. Channel-free architecture for maximum layout. Flexibility. Random routing with hierarchical functional placement. Determined by the user during the design phase. A slew rate control circuit is available that allows the dV/dt of each output to be tailored to individual load conditions. The compacted array shown below demonstrates the versatility of channel-free architecture in efficiently implementing random logic, wide buses, and memory elements. Typical LCA 10000 compacted array device. Configurable output drive up to 12 RNA, 24 RNA. Available with commercial specifications only. With slew rate control capability. 3.3V input and output capability. Compilable application-specific integrated circuit, ASIC, memory, up to 16K RAM and 64K ROM, plus logic implemented on one chip. /CMOS I/O compatibility. Inputs and outputs protected from over voltage and latch up. Efficient implementation of large logic blocks. Clock driver distribution methodology. Advanced packaging techniques. ESD protection, 2001 v. Copyright 1985, 1986, 1987, 1988, 1989, 1990-1991 LSI Logic Corporation. All rights reserved. 47. Description. Features. 48. LSI. LMA 9000. Microarray Series. The LMA 9000 microarray series is an MOS semi-custom technology offering both speed and performance equivalent to 10K ECL and high gate density ASICs. The LMA 9000 micro array series is processed using 1.5 micron drawn gate length, D.9 micron effective channel length, 2-layer metal MOS technology, and is based on LSI Logic's channel-free trademark architecture, in which potentially active transistors fill the array core. Arrays ranging from 1,968 to 34,944 available gates are offered. The largest microarray has up to 174 available signals/OS. The LMA 9000 series uses small device structures which exhibit low power consumption. The series is well suited to be used as a high reliability universal logic design vehicle, able to integrate entire printed circuit boards into a single array. The larger microarrays can be used for VLSI implementation of high-performance subsys. TEM architectures such as intelligent special purpose processors or multifunction controllers. The smaller members can be used for replacement of high-speed Schottky TTL or 10K ECL logic. Mid-range microarrays are ideal for high-performance dedicated peripheral 1.5 micron silicon gate length, 2-layer metal MOS technology. Gate speed equivalent to 10K ECL, faster than 74's TTL, 0.57 ns through 2-input NAND gate. Standard load equals 2, VDD equals 5V, Ta equals 25 degree. Up to 174 signal I/O capability. Extensive macro cell, macro function, mega function, metal megacell, and memory library. 10 array sizes from 1,968 to 34,944 gates. Fully supported by LSI's MDE registered design tools. For verification, simulation, and layout. Channel-free architecture for maximum layout. Flexibility. Copyright 1987, 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. Controllers, intelligent support functions, etc. A large library of macro cells, macro functions, megafunctions, metal megacells, RAMs and ROMs is available to simplify the conversion of existing logic designs or to easily produce new circuit designs. Typical microarray die. Random routing with hierarchical function. Placement. Configurable output drive up to 12 mA with Slew rate control. Overvoltage and latch-up protection for I/OS. TUCMOS I/O compatibility. Efficient implementation of large logic blocks. Extensive selection of ceramic and plastic packages. ESD protection greater than 2001 V. Functionally compatible with LL7000 and LL9000 macro cell and macro function libraries. Full military capability. Description. Features. BiCMOS. LDD 10000. Direct drive. Array series. LSI. The LDD 10000 direct drive trademark array series is a BiCMOS array-based ASIC application. Specific integrated circuit, offering the fast speed, low power dissipation and very high gate count of a CMOS compacted array TM device, and the high output load driving performance of LS or as bipolar TTL. The LDD 10000 series is manufactured using a BiCMOS process that has 1.5 micron drawn gate length, 0.9 micron effective channel length, 1.5 micron bipolar emitters, and 2 metal layers. The proprietary 3-region architecture shown in Figure 1 consists of 1. High-density CMOS channel-free trademark gates. 2. Peripheral BiCMOS blocks for high drive of internal loads and 3. BiCMOS I/O buffers with additional gates to implement basic macro cells. The major portion of each array consists of channel-free CMOS logic gates, making the LDD 10000 series functionally compatible with existing compacted array logic/memory Libra, RISE and design software. Optimization of selected internal speed critical paths is possible using the BiCMOS blocks to drive high fan-out nets such as clock lines and buses. In addition, improved I/O characteristics, I/O modules can be configured as flip-flops, latches and gates to allow easy integration of TTL standard logic devices into the I/O area. Sophisticated algorithms incorporated in LSI. Logic's proprietary MDE registered design tools allow very complex circuits to be accurately modeled prior to fabrication. Optimum performance and efficient layout are assured by consideration of the design hierarchy during the simulation phase. 1.5 micron gate length, micron polysilicon. Emitter BiCMOS technology. BiCMOS output buffer performance equivalent to LS or as bipolar TTL, 4.2 ns, conditions, 25. Ma TTL output, CL equals 10 op F, VDD equals 5V, TJ equals 25 degrees Celsius. 8 array sizes from 7,198 to 116,778 avail. Able gates. Fully supported by LSI Logic's Mo design. Tools. Copyright 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. Cell compilation, floor planning, and hardware acceleration are available as options to expedite the design process. Output drive strengths of 6,12 and 24 mA with selectable TTL or CMOS levels are possible from a single I/O module. 3 output buffers can be used in parallel for 72 mA drive capability, allowing direct interface to common bus specifications such as VME and multibus. Differential TTL and backplane transceivers can be implemented for line drivers and high-speed, high data integrity bus communication. Applications. A series termination resistor, selected during the design phase, is provided to tailor output characteristics and minimize bus ringing. Typical LDD 10000 direct drive array chip with 3-region architecture highlighted. 3-region architecture for optimized performance and density. CMOS channel-free gate core is directly compatible with existing logic and memory libraries. BiCMOS blocks allow speed enhancement of heavily loaded internal nets. I/O modules can implement logic functions such as basic gates, latches and flip-flops. Configurable output drive up to 24 mA per I/O module or parallel buffers for 72 mA maximum. Rating 49. IJ. I. Description. Features. 50. BiCMOS. LAD310. Analog/digital. Array series ES. Preliminary. LSI. The LAD310 analog/digital array series is a BiCMOS array-based ASIC application specific integrated circuit, offering high performance bipolar and CMOS analog functions, combined with the speed, low power dissipation and very high gate density of a digital CMOS compacted array TM. The LAD310 series is manufactured using a BiCMOS process that has 1.5 micron drawn gate length, 0.9 micron effective channel length, CMOS devices and 1.5 micron bipolar emitters. FT equals 6 GHz, and 2 metal layers. The array architecture is shown in Figure 1 and consists of 2 distinct sections. The upper part of the chip contains a digital CMOS compacted array surrounded on 3 sides by digital I/O buffers. The lower part is an analog tile array with analog I/O buffers, also available on 3 sides of the tiled region. Equivalent gate densities for the digital section range from 1512 to 114,987 available gates with up to 239 digital I/O pads. The analog section has from 96 to 672 available tiles depending on the array size. Approximately 4 tiles are required to construct a basic operational amplifier, and 97 analog I/O pads on the largest member. The ability to implement high-performance analog and digital functions on a single chip makes the LAD310 series ideally suited for total system integration onto silicon. Using a channel-free trademark architecture throughout the array assures maximum silicon utilization and direct compatibility with existing compacted array logic/memory libraries and design software for the digital SEC. An extensive library of pre-characterized analog functions is available to expedite the design process in the analog section. Each function makes selective use of both MOS and bipolar devices to implement accurate, high-speed and 1.5 micron gate length polysilicon emitter BiCMOS process. Analog and digital functions on a single chip. High-performance bipolar analog functions. 800 MHz wideband operational amplifiers, 3NS. High-speed comparators. High-speed digital CMOS logic, 0.57 NS through 2 input NAND gate, standard load equals 2. VDD equals 5V, Ta equals 25 degrees Celsius. 7 array sizes, 1512 to 114,987 digital gates. 96 to 672 analog tiles. Copyright 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. Array architecture. Low noise building blocks. The analog designer can choose the specifications of a function to optimize the circuit for a particular application. Sophisticated algorithms incorporated within LSI. Logic's proprietary MDE registered design tools allow very complex circuits to be accurately modeled prior to fabrication. Optimum performance and efficient layout are assured by consideration of design hierarchy during the simulation and layout phase. Digital output buffer drive strengths of 1, 2, 4, 6, 8 and 12 mA are available in the digital section and determined by the user during the design phase. Also available is a slew rate control circuit that allows the dV/dt of each output to be tailored to individual load conditions. Analog output buffers with emitter follower and push-pull configurations are available with up to 50 mA drive capability. ECL logic can also be integrated within the analog section of the array with pseudo ECL interface. Advanced packaging techniques. Up to 239 digital I/O and 97 analog I/O. Channel-free architecture throughout array 4. Maximum layout flexibility and silicon utilization. Pre-characterized library of analog functions. Digital section is directly compatible with existing logic and memory libraries. CMOS, TIL, ECL, and analog I/O capability. ESD protection to 2001 V and latch-up immunity. Full military specifications supported including MIL 883 and CECC 90000, H. Description. Overview. RASIC. LRH 10000. Radiation. Hardened series. LSI. RASIC is the LSI logic family of radiation hard and ASICs, application-specific integrated circuits. The LRH 10000 compacted array TM series is a radiation-hardened MOS semicus TOM technology offering speed performance equivalent to 10K ECL, combined with high gate counts. The LRH 10000 series is processed using 1.5 micron drawn gate length, 0.9 micron effect. Tip channel length, 2-layer metal, epitaxial. Bulk silicon MOS technology. The LRH 10000 is a channel-free trademark array, completely filled with potential active transistors. Densities from 25,740 to 129,042 equivalent gates are offered. Usable gate capacity of 50,000 gates and up to 348 signal/OS are available. The speed and range of gate counts available in the LRH 10000 series make it ideally suited for achieving system-to-silicon integration. Sophisticated algorithms incorporated in LSI. Logic's proprietary MDE registered design tools development software allow circuit designers modular hierarchy to be utilized to its maximum potential by performing an optimized function placement of these building blocks, and then collapsing and compacting them to minimum size. Substantial benefits are realized in both device speed and silicon area utilization. Guaranteed total dose specification 1x106 rad, SI. Total dose functional to greater than 1x107 rad, SI. Upset resistant for dose rates up to 1x10⁹. Rad, SI/section. Latch up resistant to dose rates 5:1012. Rad, SI/section. SEU. Temperature on latch type memory structure. Without cross-coupled resistors. Actual value. Will be design and layout dependent. No SEU latchup for 240 MeV branch ions. Silicon gate 1.5 micron gate length, 2-layer. Metal HMOS technology. Speeds equivalent to 10 KECL 0.57 ns through. 2 input NAND gate, standard load equals 2, VDD equals 5V. Ta equals 25 degrees C. Up to 348 signal I/O capability. Extensive macro cell, macro function, and mega function library elements, directly compatible with industry standard LCA 10000 series. 6 array sizes from 10,000 to 50,000. Usable gates. Copyright 1987. 1988-1990. 1991 LSI Logic Corporation. All rights reserved. Output buffer drive strengths of 0.8, 1.6, 3.2, 4.8. 6.4 and 9.6 mA are available and determined by the user during the design phase. Also Able is a slew rate control circuit that allows dV/dt of each output to be tailored to individual load conditions. LRH 10000 compacted array chip. All design and manufacturing done in the USA. Fully supported by MDE design tools for verify, cation, simulation, and layout. Channel-free architecture for maximum layout. Flexibility. Random routing with hierarchical functional placement. Configurable output drive up to 9.6 mA with slew rate control capability. Inputs and outputs protected from overvoltage and electric latchup. TTL/CMOS I/O compatibility. Efficient implementation of large logic blocks. Clock driver distribution methodology. Advanced packaging available. ESD protection, 2000V. Military capability up to MIL STD-883, Class S. 51. Description. Features. LRH 9000 device. Inletted chip. Carrier. 52. RASIC. LSI. LRH 9000. Radiation. Hardened series. RASIC is the LSI logic family of radiation. Hardened ASIC, application specific. Integrated circuits. The RASIC LRH 9000. Series of radiation hardened silicon gate. HMOS logic arrays exhibits bipolar speeds, while at the same time, offers high radiation resistance, low power consumption, high noise margins and ease of design. Total dose specification, 200 crads, SIL, fully functional to 500 crads, SI. Upset resistant for dose rates 1x10⁹ rads. SI/section. No latch up observed up to 1012 rads, SIL/section. Limit of source capability. SEU. No SEU latch up. Speeds higher than 74's TTLL.LNS, 1. Epitaxial silicon substrates. Silicon gate 1.5 micron drawn gate length. 1.I micron effective channel length, HMOS. Technology. 2 levels of metal interconnect. Compatible with the industry standard LL9000. Series macrocell and macro function libraries. The speed and range of gate counts available in the radiation hardened LRH 9000 series make. It ideal for LSI implementation of a variety of high-performance functions that are required to operate in a radiation environment. Optimal structure of 2 N-channel and 2 P-channel transistors. Complexities ranging from 1443 to 10,013 gates. Ceramic package pin counts ranging up to 224. Custom packaging available. All design, manufacturing including assembly. Done in USA. Fully supported by LSI Logix Mo design. Tools for pre and post radiation conditions. All non-power pads configurable as inputs. Outputs DR bidirectionally/O. TTL/CMOS I/O compatibility. Configurable output drive up to 9.6 RNA. Input protection circuitry. LRH9320Q evaluation device available. Secure design and manufacturing facilities. Military capability up to MIL STD-883, Class S. Notice, the United States government imposes special requirements for the authorization to export semiconductor products that are designed or manufactured to provide radiation hardening or radiation tolerant qualities. Copyright 1987, 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. Introduction. Features. LSI L63500 DATAC ARINC 629 Terminal device. Preliminary. The L63500 data bus terminal controller is specified in ARINC 629. Primarily developed to function as a bus interface terminal in a multi-PLE transmitter data bus. The L63500 simplifies I/O design and allows flexibility in the physical layout of user systems. In addition, it minimizes problems associated with centralized data communication systems, loss of all communication, application complexity, etc. The L63500 is an ideal device for application in aircraft, avionic fly-by-wire systems, factory automation systems, and other control systems requiring high reliability and performance. The L63500 is currently available in a 1BO pin ceramic pin grid array. A surface-mountable leaded chip carrier version is under development. Both package options are available processed to the requirements of MIL STD-BB3 with operation guaranteed over the military 125°C/ -55°C temperature range. During operation, bus access control is distributed among all terminals and decisions concerning transmission go-ahead are determined autonomously. The data bus access protocol is carrier sense multiple access clash avoidance, CSMACA, which enables ARINC 629 compliant, Boeing certified autonomous bus control. Manchester 2 biphase coded serial data, 2 megabit data rate, direct memory access capability, periodic and aperiodic protocol modes, provides transmit and receive interrupt vectors, automatic shutdown on error of transmitted data. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. Equal priority access for all terminals even during overload conditions. Under normal operating conditions, the terminals transmit at a fixed update rate, periodic. When overload conditions exist, the terminal transmits continuously, aperiodic, utilizing 100% off-bus. Transmitted information, messages, are formatted by the scheduler. Each message consists of a set of word strings which are stored in the transmit personality prom. In addition, the word strings contain labels which provide subsystem identification. Once the transmitted information is received by another terminal, the serial data is decoded and tested for proper format. The label of each word string is compared to the information stored in the receive personality prom. If correlation between the personality and transmitted data exists, then the subsystem will initiate the proper I/O activity. If no correlation exists, the system will remain idle. During transmission, the receiver acts as a data monitor. Erroneous transmissions are terminated, and after 7 consecutive errors, the transmitter is disabled. Data validation based on format and parity. Voltage, current, and fiber optic transmission. Media supported. CMOS 1.5 micron drawn gate length. 0.9 micron effective channel length, technology. Low power dissipation. Plus 5V supply voltage. 53. I. LSI. Cell-based ASICs. Description. Features. LSI. LCB007 series. Cell-based ASICs. The LCB007 series of cell-based ASICs. Application-specific integrated circuit SLO is a family of standard cell format, semi-custom solutions available for implementing a wide variety of complex logic functions for digital applications. Based on a 1.0 micron drawn gate length, 0.7 micron effective channel length LMOS process technology, it offers very high density and high performance that rivals full custom design methodologies. 1.0 micron gate length, 2-layer metal, silicon gate MOS technology. Up to 200,000 equivalent gate capacity. High-speed performance. 350 PS through high drive NAND, ND2CI. Gate. 450 PS through standard drive 2 input NAND. Gate, ND2AI, standard load equals 2, VDD equals 5V. Ta equals 25 degrees CI. Latch up immunity over 200 mA. Electrostatic discharge, ESDI protection of over 2001 V. Up to 422 signal OS with choice of input, output, or bidirectional buffer. MOS or TIL input levels. Schmidt trigger inputs. Configurable output drive up to 24 mA. 1 slot 24 mA available with commercial specifications only with slew rate control. Capability. 3.3V input and output capability. High density memory blocks. High speed static RAM up to 144K bits. Up to 5 ports available. Contact programmable ROM up to 1 MB. Specialized memories, including FIFOs, UFOs and CAMs. Memory blocks compiled to any user specified widths and depths. Extensive macro libraries. Gate level, SSI, MSI, LSI, VLSI, and RISC. Building blocks. Over 200 macro cell and 300 macro function. Types available. Each macro cell available in a minimum of 4 drive strengths. Copyright 19B9, 1990, 1991 LSI Logic Corporation. All rights reserved. Fully supported by LSI Logic's MDE registered design. Tools, the easy-to-use LCB007 design tools. Produce circuits which are guaranteed to work. The first time to predetermined specifications. The LCB007 also features many SSI, MSI, LSI, and VLSI building blocks, including high-density TIE memory capacities of up to 1 MB of ROM and 144K bits of RAM. All megafunctions available as, or can be converted into, megacells. Built-in scan circuitry for all megacells, user-defined test circuits on all memories, choice of system-level test structures for the balance of logic. Full netlist compatibility with all other LSI logic. ASIC products. Full military capability. Fully supported by LSI Logic's MO design tools. Library compatible with 1.0 micron gate length. LCA 100K compacted array plus trademark series and Li10K embedded array TM series. Typical LCB007 series cell-based ASIC. 57. Description. Features. 58. LSI. LCB15 series. Cell-based ASICs. The LCB15 series of cell-based ASICs, application-specific integrated circuits, is a family of standard cell format, semi-custom solutions available for implementing a wide variety of complex logic functions for digital applications. Based on a 1.5 micron drawn gate length, 0.9 micron effective channel length, MOS process technology, it offers high density and high performance that rivals full custom design methodologies. Fully supported by LSI Logic's MDE registered design tools, the easy-to-use LCB15 design methodology yields designs which are guaranteed to work the first time to predetermined specifications. The LCB15 also features many SST MSI, LSI and VLSI building blocks including high-density memory capacities of up to 2 MB of ROM and 144K bits of RAM. 1.5 micron gate length, 2-layer metal, silicon gate MOS technology. Up to 100,000 equivalent gate complexity. Capacity. Typical gate delays of 570 ps, ND2C2 input. NAND gate with 8 standard loads, 5 VVDD. Ta equals 25 degrees Celsius. Electrostatic discharge, ESD, protection of over 2001 V. Full military capability. Up to 348 pads, 328 signal OS, 256 testable. With choice of input, output, or bidirectional buffer. MOS or TTL input levels. Schmidt trigger inputs. Different output drive capability and slew rate. High-density memory blocks. High-speed static RAM up to 144K bits. Up to 5 ports available. Metal programmable ROM up to 512K bits. Diffusion programmable ROM up to 2 M bits. Specialized memories including FIFOs, UFOs, and CAMs. Memory blocks compiled to any user. Specified widths and depths. Typical cell-based ASIC design. Extensive macro libraries. Gate level, SSI, MSI, LSI, and VLSI building blocks. Over 200 macro cell and 300 macro function types available. Each macro cell available in a minimum of 3 versions varying in drive strengths. All megafunctions available as, or can be converted into, megacells. Built-in scan circuitry on all memories and megacells, Choice of system-level test stroke. Tours for the balance of logic. Full netlist compatibility with all other LSI logic. ASIC products. Fully supported by LSI Logic's Mo design. Tools. Copyright 1986, 1987, 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. LSI. IEEE P1149.1/JTAG. Testability bus. Overview. Block diagram. IEEE P1149.1/JTAG. Testability bus. Preliminary. LSI. The IEEE P1149.1/JTAG testability bus is a proposed standard protocol for board test. LSI. Logic supports this testability bus with special cells and design methodology. The IEEE P1149.1/JTAG testability bus is a boundary scan scheme controlled by 4, optionally 5, pins. In addition to boundary scan, a designer can add internal scan path, LSSD, BIST or cross-check test capability or other special test modes. LSI Logic supports PL149.1/JTAG in a variety of cell-based and array-based technologies. The JTAG testability bus offers improved board level testing and diagnostic capabilities for systems where bed of nails testing is impractical. Board test vectors may be introduced, and resulting outputs read out from the board edge connector. Individual boards or an entire system may be tested in this fashion. Block diagram. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. The JTAG testability bus in and of itself does not improve IC testability per SE, but it does provide a standardized gateway for IC toured test schemes such as scan, LSSD, BIST, or cross-check. The Joint Test Action Group, JTAG, is an international group of companies who are seeking test solutions for boards and hybrid assemblies. They have involved the IEEE in the effort to develop an industry-standard boundary scan test methodology. The result has been a proposed standard known as IEEE P1149.1. While the specification will not be final until voted on by the committee, LSI Logic offers JTAG capability now, based on the preliminary specification standard test access port and boundary scan architecture, Test Technical Committee of the IEEE, June 1989. Any specification changes will be incorporated in future revisions. Boundary scan path. TOT. 1 TMS test access. TCK port, TAP. 2. 61. I. LSI. DSP standard products. :::. Description. Features. Block diagram. LSI. L64032. 32x32-bit. Multiplier accumulator. The L64032 is a high-speed 32x32-bit parallel multiplier accumulator which provides single precision, 32x32, and multiple precision, 64x64, fixed point multiplication and single precision multiplication with accumulation. The device is fabricated with a 1.5 micron drawn Gate length, O.S micron effective channel length. MOS process. High speed is obtained through the use of modified Booth encoding, Wallace tree adders and a high-speed carry select adder. 32x 32-bit parallel multiplication and product accumulation. 64x 64-bit fixed-point multiplication. Fast cycle times. Commercial military. 125 ns 160 ns. 100 ns 125 ns. Bones loons. Low power consumption SU-MW at 10 MHz. Supports unsigned integer, 2's complement. Integer, unsigned fractional and 2's compl. Ment fractional input formats. CLKX. CLKY. The L64032 is useful in DSP, digital signal processing, applications such as Fourier transforms, digital filtering, power series expansions, and correlations. In these applications, the 32-bit word length yields a signal-to-noise ratio and dynamic range of up to 192 dB. This device is also useful for general computational tasks such as matrix manipulations, graphics processing, and arithmetic acceleration. Supports unsigned integer, 2's complement. Integer, unsigned fractional, 2's complement. Fractional, shifted, and 2's complement fractional, unshifted, output formats. Positive and negative product accumulation. Temp register supports product register. Preloading. Full rounding capability. All registers offer full built-in scan testing capability. 132-pin CPGA or PPGA, ceramic or plastic. Pin grid array, package. 32x32. Multiplier. Array. OEPD plus dash. P3532 P31:0. Copyright 1986, 1987, 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. 65. Description. Features. 66. L64134. LSI. 32-bit MOS. IEEE floating point processor. The L64134 is a high-speed processor which contains a full 32-bit floating point multiplier and a full 32-bit floating point ALU on a single chip. This 3-bus device has a clean architecture with no internal pipelines. It is ideally suited for high-speed graphics and DSP, digital signal processing, applications. The L64134 supports the ANSI/IEEE standard P754-1985, commonly called IEEE, format. The device has been implemented in a 1.0 micron drawn gate length, 0.7 micron effective channel length, MOS process for high speed with low power dissipation and is packaged in an industry standard 144-pin ceramic pin grid array. L64134 is functionally equivalent and pin compatible with the L64133. The L64134 has minor variations from the L64133 in terms of performance, flag generation, and exception handling. In all cases, the L64134 behaves in a manner which is more consistent with the accepted interpretation of IEEE standard. Provides separate 32-bit floating point multiplier and floating point ALU on a single chip. Fully supports all boundary conditions of the IEEE format except operations with denormalized numbers, which are treated as 0. 3 bus architecture for high bandwidth. 6 ported internal core for superscalar performance. Separate register enable signals. Fast floating point operation times. Commercial military. 50 ns 60 ns. 60 ns 80 ns. 80 ns 100 ns. No internal pipelines for low latency. Architecture optimized for sum of products and product of sums calculations. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. L64134 chip. All input registers can be selected as edge-triggered flip-flops or level-triggered latches. All output registers can be selected as edge-triggered flip-flops or transparent buffers. Single master clock. 4 separate input registers. Provides conversion from integer to floating point and from floating point to integer formats. Performs 2-x, 4 Newton-Raphson. Division. Special graphics operations such as min and max. Full serial scan test mode for all input and output registers eases board and system level testing. Description. Features. Architecture. LSI. L64210/L64211. Variable length. Video shift registers. The L64210 and L64211 are 2 high-speed variable length video shift registers. These devices can be used individually or as video line delays for the L64200 series filter processors. The L64210 provides 4 individual 8-bit shift registers, each with a length of up to 1032, and is packaged in a 68-pin plastic leaded chip car, rear or ceramic pin grid array. The L64211 provides 8 individual 8-bit shift registers, each with a length adjustable to 516, and is packaged in a 120-pin plastic or ceramic pin grid array. Variable length video shift register. Acts as a variable length line delay, reformat. Ting serial, raster scanned video, data into a 2D video signal for image processing. Can work individually or with any of the LSI Logic L64200 series filter processors. L64210 contains 4 separate 8-bit shift registers whose length can be varied from 24 to 1032. L64211 contains 8 separate 8-bit shift registers whose length can be varied from 12 to 516. High data rates. Commercial 20 MHz, 15 MHz, military 16 MHz, 12 MHz. The L64211 contains 8 individual 8-bit variable length shift registers which can be used as video line delays. The L64210 has every other shift register output connected to external NAL package pins and effectively has 4 individual 8-bit shift registers. The length of the shift registers is controlled by the value residing in the level triggered length, JE.TCH register controlled by an active low-E input. The length of each of the 8 shift registers of the L64211 can be varied from 12 to 516 bits by loading the length register according to number of shifts equals 4 length, plus 8. Copyright 1987.1988, 1989, 1990, 1991 LSI Logic Corporation. L64210/L64211 chip. Control available to blank, force to 0, data. Outputs during horizontal video blanking inter vals. Control available to blank, force to 0, data. Inputs, which could be used to ignore invalid data during vertical video blanking intervals. Input data can be sent to all 8 internal shift registers simultaneously. L64210 is available in a 68-pin PLCC, plastic, leaded chip carrier, or CPGA, ceramic pin grid array, package. L64211 is available in a 120-pin PPGA, plastic, pin grid array, or CPGA, ceramic pin grid array package, where 0 is an illegal input. Since the L64210 internally cascades 2 shift registers together, each oft resulting 4 registers can be varied from 24 to 1032 bits long, and its length is determined by the equation number of shifts equals 8 length plus 16. In a video or image processing system, the length of each shift register is normally set to the number of pixels per video line. When used in this fashion, as a video line delay or as a front end to any oft LSI logic real-time image processing chips, the line delay outputs the pixels vertically adjacent to, in the same column as, the input pixel. 67. Description. Features. Pin listing and description. 68. L64212. Variable length. Video shift register, HVSR. LSI. The L64212 is a high-speed variable length video shift register. This device can be used individually or as video line delays for the L64200 family of processors. The delay of the L64212 can be set to any value between 11 and 4140. The L64212 features fully static operation and 40 MHz data rates. The L64212 can be operated in a circular buffer mode, in which the buffer is filled once and then read continuously. The L64212 has 4 delay elements each with a maximum delay of 1035. 2 data inputs allow operation in 18-bit applications with delays up to 2070 or as 2 independent 9-bit line delays. The L64212 is packaged in a 95-pin grid array. Variable length video shift register. Acts as a variable length line delay, reformat. Ting serial, raster scanned video, data into a 2D video signal for image processing. Contains 4 separate 9-bit shift registers, whose length can be varied from 11 to 1035. Programmable for any delay value between 11 and 4140. DLO. 9-bit input data bus. Data inputs are loaded into the first stage of the first shift register at the rising edge of CLK while shift/hold is high. DL1. 9-bit input data bus. Data inputs are loaded into the first stage of the third shift register at the rising edge of CLK while shift/hold is high. Only active when internal control signal to in is high. CLK. System clock, when SLCLK is low, active at the rising edge. WCLK. System clock, when SLCLK is high, active at The rising edge. Used to load circular buffer. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. L64212 chip. High data rates. Commercial military. 40 MHz 40 MHz. 30 MHz 30 MHz. Variable length circular buffer. 3-state outputs for double buffered memories. Available in 95-pin CPGA, ceramic pin grid. Array, package. SELCLK. Selects either CLK, when low, or WCLK. When high, as system clock. SRWE. Enables writing of data into the shift registers. Held high for line delay applications and ing loading in circular buffer applications. Held low during reading in circular buffer applications. CI.auto CI.7. Control input bus. This bus is common to all L64200 series devices. On the L64212, the bus is used to load the length of each of the delay elements and other control information. Description. Features. Architecture. LSI. L64220. Rank value. Filter, RVF. The L64220 computes a given rank of the input values in a moving window and outputs the rank value. The operation is similar to a linear transversal filter except that the output is chosen from a sorted list of the input values rather than a weighted sum of input values. Some examples of useful rank values include the max, minimum, and median. Median filtering has been shown to be effective in removing noise that has a probability density with long tails, i.e., spiky noise while preserving monotonic changes in the input data. The maximum and minimum can also be used to suppress certain types of noise in a nonlinear manner. The rank value filter can be reconfigured for operation as an 8x8, 4x16, 2x32 filter or as a 1x64 120 filter. Values can be masked from the computation, giving the user very general control over the window of the filter. Thus, the size and shape of the window can be varied for many applications. 64-tap, 12-bit reconfigurable rank value filter. Processor, RVFL. Sorts and selects output data value based upon input rank, 0000000 equals min, 111,111 equals maxi. Configurable for 8x8, 4x16, 2x32 or 64-tap. Window size. Operates on signed or unsigned data. 8 separate 12-bit input buses. Configurable window shape and size. The L64220 rank value filter, RVFL, sorts all the values within a window and outputs the value of interest as determined by the rank selector. Commonly used rank values are the maximum or minimum value within a set of inputs. The most common application of the device will be as a median filter, which has excellent properties for removal of impulse-like noise. The device is a standalone filter which can operate on either 120 or 2D windows where each data point is up to 12 bits in length. The L64220 is easily reconfigurable to perform RVF operations with a variety of window sizes and shapes. Copyright 19B7, 19BB, 19B9, 1990, 1991 LSI Logic Corporation. All rights reserved. L64220 chip. Double buffered coefficient / control registers. High-speed real-time operation. Commercial military. 20 MHz 16 MHz. 15 MHz 12 MHz. Extremely useful as a median filter to remove impulse like salt and pepper noise. Fully compatible with other LSI logic L64200 series devices. The rank value filter operates at very high speeds and is useful in high-end applications, such as radar signal processing, image processing, high-speed data communications and other areas where performance and processing power are important. The device contains 8 individual 8-tap shift registers, RVFO RVF71, each 12 bits wide. By controlling the input source to each 8-tap shift register section, the rank value filter can be configured as a 64-tap 1-to-0 rank value filter or as a 2D filter with a 2x32, 4x16 or 8x8 window. 69. Description. Features. Architecture. 70. LSI. L64230 binary. Filter and template. Matcher, BFIR. The L64230 is a 1024-Ta high-speed binary transversal filter processor and template matcher. The processor can be configured as a 1-to-0, 1-dimensional filter for radar or other signal processing applications, or as a 2-to-0, 2-dimensional filter for image processing applications. The processor accepts 2-to-0 data directly from a L64210/L64211 variable length video shift register or other video source. The coefficients can be changed in time to perform adaptive filtering and correlation. The window and / or precision of a 1-to-0 or 2-to-0 filter is expandable using more L64230 processors with minimal external logic. The processor is ideally suited for real-time image processing applications, like video pattern matching, noise removal, and the morphological operations, erosion and dilation. The maximum window size is 32x32 for a single chip. Video output format. Ting circuitry is also available on chip to clip the output to a single bit data throughput of 20 MHz. BACOM makes the processor suitable for radar processing. Implemented in 1.5 micron drawn gate. Performs for filtering, template matching, erosion and dilation. Compatible with the L64200 family of products. 10 24-tap sections, each operating on L-bit data. And 1 112-bit coefficients. Reconfigurable for 1-to-0 and 2-to-0 correlation / convolution / morphology. Multiple processors can be used to extend data and / or coefficient precision. The core of the processor is organized as 32 tap filter sections. The outputs of all 32 tap sections are summed and delayed by the variable length shift register. This delayed output is added to an incoming partial result to form the processor output. The partial result input is used to sum partial results in a multi-processor system and to set threshold value to clip the output to a single bit. The variable length shift register is used only in multi-processor systems to compensate for additional latency acquired in the partial result path. Each filter tap performs the basic XNOR and N operations. The AI, J, and byte, J are stored in double buffered registers. Byte, J controls the XNOR gate. On AI, J controls the AND gate. The XNOR gate performs inversion, erosion, or magnitude differ. Copyright 1987, 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. Length, 0.9 micron effective channel length, low. Power MOS technology, the L64230 is available in a 155 lead ceramic pin grid array package. L64230 chip. Multiple processors can achieve window sizes of over 64K top ES. 16-bit output precision. Double buffering of coefficients. High-speed operation. Commercial military. 20 MHz 16 MHz. 15 MHz 12 MHz. Available in 155 lead CPGA, ceramic pin grid array package. Insync, template matching. The AND gate POR forms masking, template matching, or L-bit multiplication, for filtering, dilation, erosion. The outputs of all taps are summed to produce the final result. It should be noted that no significant bits of any signal are lost. The processor has 32 single-bit inputs, 010, 0131. For 1-to-0 filtering, the only active input is 010. When performing 2D operations over an XM window, n of the inputs are active. Normally, when performing 2-to-0 operations, an L64210/211 video shift register with the raster scan signal as its input would provide the n active data inputs. In this case, the output of the processor, n, represents the raster scanned output. Description. Features. Architecture. LSI. L64240. Multi-bit filter. MFIR. The L64240 is a 54-tap high-speed transversal filter processor consisting of two 32-tap sections with 8-bit wide coefficients and data. The processor can be configured as a 1-to-0, one-dimensional filter for radar or other signal processing applications, or as a 2D, two-dimensional filter for image processing applications. The processor accepts 2D data directly from a L64210/L64211 variable length video shift register or other video source. The coefficients can be changed to perform adaptive filtering and correlation. The window and/or precision of a 1-to-0 or 2D filter is expandable using more L64240 processors with minimal external logic. The processor is ideally suited for real-time image processing applications such as video, pattern matching, noise removal, inverse filtering, edge enhancement, and edge detection. The maximum window size is 8x8 for a single chip. Video output formatting circuitry is also available on chip to alter gain, threshold, and other parameters. Worst case commercial grade data throughput of 20 MHz make the processor suitable for radar processing. Implemented in two 32-tap sections, each 8-bit data and coefficients. One 32-tap section, each 16-bit data or coefficients. Reconfigurable for 1-to-0 and 2D correlation/convolution. Multiple processors can be used to extend Data and slash or coefficient precision up to 24 bits. Multiple processors can achieve window sizes of over 1024 taps. 2's complement or unsigned 8-bit input data. And coefficient. Output precision up to 40 bits for 1-to-0 process. ing, up to 24 bits for 2D processing. The L64240 multi-bit filter is a standalone finite impulse response (FIR) filter which can operate on either 1-to-0 or 2D data. It is easily reconfigurable to perform FIR filter operations with a variety of window sizes and shapes. It operates at very high speeds and is useful in high-end applications such as radar signal processing, image processing, high-speed data communications and other areas where performance and processing power are important. 1.5 micron drawn gate length, 0.9 micron. Effective channel length, low power MOS. Technology, the L64240 is available in 155 lead ceramic pin grid array package. L64240 chip. Double buffering of coefficients. Format adjustment for video display. On-chip barrel shifter for precision expansion. Block floating point format output. Configurable as an IIR filter. High-speed operation. Commercial military. 20 MHz 16 MHz. 15 MHz 12 MHz. Ability to perform Sobel edge extraction. Available in 155 lead CPGA, ceramic pin grid array package. The L64240 performs convolution/correlation operations of the type LL 10 yin 0 L high XL Ni 100 L1KL 2 DYLN M OLLHLKXLNI MK 10 OB0. The device contains 8 individual 8th order FIR filters, FIRO FIR 7. Copyright 1987, 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. 71. I. 1.1.1 I. Lil. Il. I. 1. Description. Features. Block diagram. 72. LSI. L64243. 3x3 multi-bit. Filter, MFIR3. The L64243 is a 9-tap high-speed transversal filter. Processor consisting of a 9-tap section, with 8-bit wide coefficients and data. The processor can be configured as a 1-to-0, one-dimension filter for radar or other signal processing applications, or as a 2D, two-dimensional, filter for image processing applications. The processor accepts 2D data directly from a L64210/L64211 variable length video shift register or other video source. The coefficients can be changed to perform adaptive filtering and correlation. The processor is ideally suited for real-time image processing applications such as video pattern matching, noise removal, inverse filtering, edge enhancement and edge detection. The max minimum window size is 3x3 for a chip. Data throughput of 40 MHz makes the processor suitable for radar processing. The L64243 is implemented in a 1.5 micron drawn gate length, 0.9 micron effective channel length, low power MOS technology. 9 taps, 8-bit data and coefficients. Reconfigurable for 1 to 0 and 2D correlation/con. Volution. 2's complement or unsigned 8-bit input data. And coefficient. Output precision up to 20 bits. Double buffering of coefficients. CI.O. To D-1H-I. Rejayer.O. 2. We Rejayer.3. L64243 chip. High-speed operation. Commercial military. L64243-40 MHz 40 MHz. L64243 30 MHz 30 MHz. L64243-20 20 MHz 20 MHz. Available in 68-pin CPGA, ceramic pin grid array, or 68-pin PLCC, plastic leaded chip carrier, package. CLK I CI.7-I OIO.OC-HTLL____R, 2 010.7 011.0 to DH-, 011.7 012.0 to DT+-L 012.7 FR2. Copyright 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. 2 internal. Pipeline stages. 00.0, 00.19. Description. Features. LSI. L64245. FR filter processor. Preliminary. The L64245 is a device for computing FR filters on continuous data streams at data rates up to 40 MHz 1 to 0, one-dimensional, filters with a range of data sample rates and filter lengths. Can be implemented. Input and coefficient data are both 10-bit. Signed or unsigned values. Both real and complex, INQ, data types are supported. The L64245 is capable of implementing a range of filter functions. Decimating filters, interpola, TORs, interleaved, and complex filters are all supported. The length AHI filter in all cases. 2610*10 multiplier accumulators. 208 coefficient registers. Real and complex filters. Interpolation and decimation. Up to 8 independent interleaved data. Stream. Copyright 1991 LSI Logic Corporation. All rights reserved. Is determined by the input or output data rate. As this data rate drops below the device's clock rate, the number of hops available increases. The L64245 consists of 26 processing elements. Each element is a 40 MHz multiplier combined with 8 coefficient registers and an 8 tap shift register. This makes it possible to implement real filters ranging from 208 taps at 5 MHz to 26 taps at 40 MHz. Coefficients not being used by a multiplier can be updated without affecting the operation of the filter. Clock/data rates. L64245 30 MHz. L64245-40 40 MHz. 68-pin CPGA, ceramic pin grid array, or PPGA. Plastic pin grid array, package. 73. Description. Features. Architecture. 74. L64250. LSI. H-histogram/HOF. Transform processor. HHP. The L64250 computes histograms and modified Hoff transforms for data sets up to 224 points, or images up to 40 S6 x 4096 pixels. In addition, pixel location operations may be performed in which the x and y coordinates of pixels of designated gray values are stored. Data rates up to 20 MHz and data precisions up to 9 bits are accommodated. Histogram and Hoff transform calculation performed on images up to 4096 x 4096 pixels. 512 XCOACUP tables provided to perform user-defined point-wise transformations. Real-time histogram equalization. High data rates. Commercial 20 MHz, 15 MHz. Military 16 MHz, 12 MHz. The architecture of the L64250 accommodates the implementation of multiple algorithms with the same memory-based circuitry. The particular operation that is to be performed is defined via a group of mode latches. The accumulation memory, ACC RAM, holds the histogram, modified Hoff transform PAR, tile results or the x and y pixel coordinates. 512 x 9 LUT RAMs hold any combination of the histogram equalized transfer function, user-specified transfer functions, the function needed to perform the modified Hoff transform, stank, or a calc, or a table indicating which pixel locations should be stored. The x and y counters are used when performing modified Hoff transforms and pixel location and contain the x and y coordinates within the image. The LUT, adder and counters Copyright 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. L64250 chip. 2 system clocks provided for different pixel and host controller data rates. Marker circuit allows users to flag points of interest on the histogram, modified Hoff transform or accumulated histogram. Available in a 68-pin CPGA, ceramic pin grid array, or 68-pin PLCC, plastic leaded chip car. Rear package. Put the Hoff transform parameter for each point in the image. The user controls the X and Y counters via the count, CX, SI, and reset. RX, RE, pins. The I/O controller is used to generate address ES for the RAMs when reading results from the processor or loading the LUTs. The processor output comes from either the ACC RAM, the LUT RAM, or the marker memory depending on the type of operation being performed. 2 clocks control the flow of data in the SYS. TEM. CLK1 is the pixel or input data clock. CLK2 is provided to allow the user to read data from or write data into the RAMs at a lower rate than the data input rate. CLK2 can be tied to CLK1 when all operations are performed at the data input rate, e.g. histogram equalization. Description. Features. L64260 block diagram. L64260/L64261. High speed. Versatile FIR. Filter, VFIR. LSI. The L64260/61 compute inner products in many different forms. FIR filters to perform decimation, interpolation, adaptive filtering, and 2 to 0. 2-dimensional filtering can be implemented. In addition, matrix and matrix vector multiplication can both be performed. Each processor contains 4 high-speed mags each, with 4 data and 4 coefficient registers. An on-chip sequencer is used to control the chip when repetitive operations are performed. There are 2 versions of the processor. The L64260 comes in a 223-pin ceramic pin grid array with 8 16-bit data inputs bonded out. The L64261 comes in a 144-pin ceramic pin grid array that does not provide the use of all I/O pins. The L64261 has 2 16-bit data inputs, 3 12-bit data inputs and 3 12-bit data inputs that are shared with the buses needed to cascade parts. In applications not requiring both the additional data input buses and the ability to cascade parts, the L64261 can be used. The L64260 is useful in applications in which either very high I/O bandwidth is required, example, 4 16-bit mags. On-chip control functions reduce system size. Multiple chips can be used to increase performance. Flexible architecture with 16 coefficient and data registers. High I/O bandwidth for adaptive filtering. Matrix or matrix vector multiplication. General inner products. Variable input and output data rates for decimation. Regear. We. CLK. CT-**-1. CLK-I. CIO 010 SIL 011. Control. 2 taps. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. 00. L64260/L64261 chip. General inner products, or the extra data precis. Zion is needed. The L64261 is aimed primarily at filtering and matrix multiplication applications. In these applications, not all of the data input buses are necessary. And interpolation can perform one chip 4x4 convolution. High data rates. Commercial military. 40 MHz 30 MHz. 30 MHz 25 MHz. L64260 is available in a 223-pin GPGA, ceramic pin, grid array, package. L64261 is available in a 144-pin CPGA, ceramic pin, grid array, package. CI2012 CI3013 16 SRO 75 Description. Features. Block diagram. 76 L64270 LSI 64-64 Crossbar switch. XBAR. The L64270 is a 64-64 crossbar switch in which any of the 64 outputs can be connected to any of the 64 inputs without any blocking constraints. In addition, any output can be set to a constant value or put in a high impedance state. Each of the 64 switches can be operated in a flow-through mode with a delay of 25 ns from input to output, or in a pipelined mode with a delay of 15 ns from clock to output. The device can be put into a bus and / or a bidirectional mode to simplify operation with multi-bit unidirectional or bidirectional buses. The L64270 is implemented in a 1.5 micron drawn gate length, 0.9 micron effective channel length, low power MOS technology. Non-blocking 64 to 64 crossbar switch. Pipelined or flow-through modes. Multiple chips can be used to increase switch size. Outputs can be set to constant values. Can easily switch buses of different widths. Can be configured as 64 bidirectional ports. Double buffered control signals. Can perform arithmetic or logical shifting and bit rotation. CI.O. 2 dash dot LT CI.7 010 2 dash comma 4 dash 016364 Rejayer.O 2 Rejayer.6 Copyright 1989 1990 1991 LSI Logic Corporation. All rights reserved. Z63 L64270 chip. High data rates. Pipeline flow-through. Mode L64270 JC4040 MHz 25 ns. L64270 JC3030 MHz 35 ns. 160-pin PQFP, plastic quad flat pack, package. Description. Features. Pin listing and description. The highest numbered bit is always the most significant. LSI L64280 Complex FFT Processor, FFTP. Preliminary. The L64280 FFTP, Fast Fourier Transform Processor, is a floating-point complex FFT processor and is designed for primary use with the L64281 FFT-SR, Fast Fourier Transform Video Shift Register. In real-time FFT systems, it can also be used in a single processor configuration in which system cost is reduced along with system performance. The FFTP includes the FFT controller and complex exponential ROM needed to compute transforms of 2048 points or less. For longer transforms, external controllers and coefficient storage devices are required. The device performs both the forward and inverse transforms and can accept data in either normal order or bit reversed order. A variety of operating modes and data formats can be chosen. The input data can be either a floating point or fixed point number. Likewise, the output data can be either a floating point or fixed point number. For fixed point outputs, a user-supplied scale factor determines which internal bits are output. Computes FFT butterflies at 20 MHz rate. Real or complex multiplication accumulation. Integer or floating point data formats. Internal FFT controller for up to 2K point FFT. Internal complex exponential, real sinusoid ROM. For up to 2K point FFT. 40-bit internal accumulation for high precision. Applications in modulation and demodulation. EDI.0:3. 4-bit input exponent set to constant for fixed point data input. RD1.0:19. 20-bit real data mantissa input. 101.0:19. 20-bit imaginary data mantissa input. Edo.D3/0VF.0:3. 4-bit output exponent and overflow flags. In floating point output mode, the output data. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. In addition to performing FFTs, the device can be operated as a complex Mac, 2 real Macs or as a Mac with 1 complex and 1 Real operand. The user can either input a complex or real coefficient or input the phase of a complex exponential or real sinusoid. L64280 chip. Internal controller for single processor systems. High data rates. Commercial military. 40 MHz 30 MHz. 30 MHz 25 MHz. Available in a 144-pin CPGA, ceramic pin grid array package. Exponent appears on these pins. In fixed point. Output mode, OVF.O high indicates overflow of the data on RDO, and OVF.L is the sign of the data on RDO. OVF.2 high indicates overflow of the data on EDO, and OVF.3 is the sign of the data on EDO. RDO 0:19. 20-bit real data mantissa output. 100.0:19. 20-bit imaginary data mantissa output. 77. Description. Features. 78. LSI. L64281 FFT. Video shift. Register, FFT-SR. Preliminary. The L64281 is a high-speed FFT, fast Fourier transform, video shift register. It is used to perform data formatting in real-time FFT systems. Using the L64280 FFTP, fast Fourier transform processor, or as a flexible variable length video line delay. The FFT-SR, fast Fourier transform video shift register, features fully static operation and 40 MHz data rates. When used in an FFT system, the FFTP devices generate all control signals for the FFT-SRs, simplifying the system design. A single FFT-SR can perform the data formatting required at each stage of the FFT if the length is limited to 2K points and the data word widths are limited to 47 bits. Multiple FFT-SRs can be cascaded and or paralleled when longer transform lengths or wider data words are required. The user has access to all 48 single-bit delay element inputs and outputs, which makes very flexible video line delays and data buffering possible. The device can be operated in 1, 2, 4, 8, 12, 16, and 48-bit modes. The input and output off device can be independently operated in serial or parallel modes. For example, the input can be serial and the output parallel, video line delay, or the input can be parallel and the out. High-speed FFT data formatting. Flexible video line buffering. Serial to parallel data conversion. Parallel to serial data conversion. Internally configurable for different data word widths. Contains 48 independent I-bit shift registers, whose length can be varied from 14 to 1034. Copyright 1990-1991, LSI Logic Corporation. All rights reserved. L64281 chip. Put serial. The delay of each internal shift reg register is 4n plus 14, where OS, NS, 255. Therefore, a 48-bit signal can be delayed up to 1034 cycles, and a single-bit signal can be delayed up to 49,632 cycles. All data outputs available. High data rates. Commercial military. L64281-40 40 MHz 40 MHz. L64281-30 30 MHz 30 MHz. Available in a 132-pin CPGA, ceramic pin grid, array, package. Description. Features. Pin listing and description. Signal.o is always the LSB, LSI, L64290. Object contour tracer. The object contour tracer is used to locate the contours of objects in a binary, 1-bit, image. It will return the sequence of x, v coordinates and discrete curvature values for each contour. In addition, the bounding box, area and perimeter of each contour is returned. The device can store images internally with sizes up to 128 x 128 pixels. For images of up to 1024 x 1024 pixels, external RAM is used. Searching for objects can be restricted to a subset of the image to decrease the object detection time. When using the internal RAM, the image is automatically run length coded, which allows the processor to skip runs of 8 or more pixels when searching. The tracer will find all contours including contours within other contours for all of the objects within the search window. The user can force the tracer to ignore those contours which touch an edge of the frame or which are in the interior of an object. The contour tracer can be used in object/tar get tracking and identification applications. Finds all object contours. Internal RAM for 128 x 128 pixel images. Handles 1K x 1K pixel images with external RAM. Automatic run length coding decreases search time. 20 MHz clock rate. User selectable search window. Outputs object contour features. X, N, V, N, Cov, N, slope, N. Bounding box, area, perimeter. XIO.O XIO.9. 10-bit bus for loading, operating and searching parameters into the device. Also used to read contour features and the external RAM X coordinate. Data is latched internally when CS is high and RW is low. Data is output on this bus when CS and RW are high. The XIO bus floats when CS is low. YIO.O YIO.9. Similar to the XIO bus, but carries the RAM V coordinate. Copyright 19B9, 1990, 1991 LSI Logic Corporation. All rights reserved. The discrete curvature, when normalized, provides insensitivity of the identification process. With respect to translation, rotation, and scaling of object, the device can also be used to compress black and white images by coding and transmitting only the contour information. L64290 chip. Execution time, image dependent, for NXM. Image. Typical. Worst case, checkerboard pattern. 4.5 nm cycles. 58-pin CPGA, ceramic pin grid array, package. Register.o 5-bit register address. Selects one oft. Internal data registers to be output on the XIO and VIO buses when CS and RW are high. If CS is high and RW is low, the register with an address of register will be loaded with the data on the XID and VIO buses. CS chip select. When high, data can be read from or written to the internal data registers. When low, the XIO and VIO buses float. 79. LSI. Video and still image. Compression. Description. Features. LSI. L64710. 8 error correcting. Reed-Solomon codec. The L64710 contains a ARS, Reed-Solomon encoder and a ARS decoder. This pipelined high-speed, error correction device implements an ARS code with 8 bits, 1 byte, per sim. Ball. The encoder appends 16 redundant check bytes to every K message bytes. The message length K is user programmable between 38 and 239. Each ARS code word consists of n equals K plus 16 bytes of data. Thus the code word length n may range between 54 and 255 bytes. The decoder is capable of correcting up to 8 byte errors per code word. Sustained through put data rates up to 40 bytes per second. Commercial, are supported for both the encoder and decoder. The L64710 is ideally suited for ensuring data integrity in high-performance storage media and communication channels. The device is implemented in AL.0 micron drawn gate length, 0.7 micron effective channel length, HMOS. Technology. 8 bits, 1 byte, per code symbol. 16 bytes of redundancy per code word. Percentage redundancy as low as 6.79%. Corrects up to 8 byte errors per code word. Corrects single burst up to 57 bits long. Systematic Reed-Solomon code for easy retrieval of message data. User selectable code word length of between 54 and 255 bytes. Separate encoder and decoder for full duplex operation. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. L64710 chip. Pipelined architecture with high data rate. Commercial military. 40 MHz 40 MHz. 30 MHz 30 MHz. Fully static design with no minimum speed requirement. Built-in test modes. Available in a 68-pin CPGA, ceramic pin grid array, package. I83. Description. Features. 84. LSI. L64715. 2 error correcting. BCH encoder decoder. The L64715 implements the forward error correction, bit filling and synchronization scheme. Specified in CHIT, International Consultative Committee for Telephones and Telegraphs, Rec. Emendation H.261. The forward error correct encode is a 2 error correcting BCH code. The device contains both an encoder and a decoder. For full duplex operation, the device processes blocks of 512 bits. Each block consists of a 511-bit BCH code word and a single internally generated or user-supplied frame bit. The encoder appends 18 bits of redundant check bits to every 493 bits of message to form the BCH code word. The message consists of either 493 bits of data or a fill indicator bit and 492 bits of data or a fill indicator, and 492 fill bits. The BCH decoder can correct up to 2 errors per code word. The number of errors that have been corrected is reported for channel characterization. When internal framing and synchronization is selected, the encoder appends a single frame ing bit, as specified in CHID recommendation. H.261, to each BCH code word. The decoder will automatically detect the synchronization pattern to determine the code word boundary. External synchronization can also be provided, in which the code word boundary for the decoder is provided externally. Code word size of 511 bits. Corrects up to 2 bits of errors per code word. Separate encoder and decoder for full duplex operation. Optional synchronization and bit filling. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. The device can be programmed to operate with or without bit filling. When the fill mode is selected, the first message bit is used to indicate if the rest of the message has been filled or contains data. Sustained encoded bit rates of up to 30 or 40 bits per second are supported for both the encoder and decoder in full duplex mode. L64715 chip. Compatible with CHID H.261 requirements. 40/30 MHz data rate for decoder and encoder. Internal BCH decoding buffers. 44-pin PLCC, plastic leaded chip carrier, package. Description. Features. LSI. L64720 video. Motion estimation. Processor, MEP. The MEP, motion estimation processor, detects the relative motion between data blocks in 2 video frames. This operation makes it possible to transmit or store less information in a video compression system. The data block, user selectable for either 16x16 or 8x8, in the current video frame is offset and compared with the reference image. The position of the best match, the minimum error and the zero offset error are returned by the processor. The error computed is the sum of absolute differences. For the 16x16 data block size, errors are computed for offsets of -8 to +7 in both the x and y dimensions. For the 8x8 data block size, errors are computed for offsets of -4 to +3 in both the x and y dimensions. In both cases, multiple devices can be used to increase the search window size. The L6472030 can process a 352x288 image at a 30 MHz frame rate with a 16x16 data block size. When operating with an 8x8 data block size, the L6472030 can process broadcast quality images, 600x480, at a 30 MHz frame rate. 16x16 or 8x8 data block. 32x32 or 16x16 search window. Search window can be increased with multiple devices. Multiple devices can be used for increased performance. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. All input and output data is double buffered to minimize the main memory bandwidth requirements. The search window and data blocks are loaded sequentially while the output values are randomly accessed. The device is available in 68-pin ceramic and plastic PGAs, pin grid arrays. L6472D chip. Compatible with proposed CCID standard. 30/40 MHz clock rates. Double buffered I/O. Simple control. 68-pin CPGA, ceramic pin grid array, or PPGA. Plastic pin grid array, package. 85. I. I. Description. Features. 86. LSI. L64730 discrete. Cosine transform. Processor, oct. Preliminary. The DCT, discrete cosine transform. Processor computes both the forward and inverse DCT over 8x8 data blocks and meets the CHIT, International Consultative Committee for Telephones and Telegraphs standard. Up to 12 bits of data precision is available for the input and output data. The output can also be rounded to 9 or 12 bits. The device supports data rates up to 40 MHz. All DCT coefficients and control signals are generated internally. The user only supplies a signal indicating the beginning off data block, the direction of the transform and the number of bits desired at the output. The device can also perform the loop filtering specified in the CCID standard. This operation is performed at the same rate as the DCT and inverse oct. The discrete cosine transform is ideal for image or video compression systems, as the DCT coefficients can typically be coded with fewer bits of information than the original image. To ensure proper tracking between an 8x8 data block, handle continuous data streams, up to 12-bit input and output precision, computes forward and inverse transforms. Multiple devices can be used for increased performance. Compatible with proposed CCID standard. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. Encoder and decoder, the proposed CCID standard has placed strict limits on the status ticks of the errors encountered when computing the inverse DCT. This device complies fully with these requirements. The device is available in 68-pin ceramic and plastic PGAs, pin grid arrays. L64730 chip. Performs spatially variant loop filtering. 30/40 MHz clock rates. Simple external control. 68-pin CPGA, ceramic pin grid array, or PPGA. Plastic pin grid array, package. Description. Features. LSI. L64735. Discrete cosine transform processor. Preliminary. The DCT, discrete cosine transform, processor, computes both the forward and inverse DCT over 8x8 data blocks and meets the proposed CCID, International Consultative Committee for Telephones and Telegraphs, standard, H.261. The device operates with either signed or unsigned pixel data. 8-bit unsigned pixel data is transformed into 2-bit signed DCT coefficients, while 9-bit signed pixel data is transformed into 12-bit signed DCT coefficients. DCT coefficients are accepted and generated in either raster order or zigzag order. The pixel data I/D is always in raster order. The device supports data rates up to 35 MHz. The cosine basis functions and control signals are generated internally. 8x8 data block handles continuous data streams. 9-bit signed or A-bit unsigned pixel data. Raster order pixel data. Zigzag or raster order DCT coefficients. Compatible with proposed CEL-D standard. Copyright 1991 LSI Logic Corporation. All rights reserved. The user only supplies a signal indicating the beginning of the data block, the direction oft. Transform, the format of the pixel data and the ordering oft DCT coefficients. The discrete cosine transform is ideal for image or video compression systems, as the DCT coefficients can typically be coded with fewer bits of information than the original image. To ensure proper tracking between an encoder and decoder, the proposed CEL-D standard has placed strict limits on the statistics oft errors encountered when computing the inverse DCT. This device complies fully with these requirements. The device is available in 68-pin ceramic and plastic PGAs, pin grid arrays, and 100-pin PQFPs, plastic quad flat packs. Bypass mode 20/27/35 MHz clock rates. Simple external control 68-pin CPGA, ceramic pin grid array, or PPGA. Plastic pin grid array, or 100-pin PQFP, plastic quad flat pack, package. 87. Description. Features. 88. LSI. L64740 oct. Quantization. Processor, DCTQ. The L64740 performs many of the functions required after the oct, discrete cosine transform L and before the IDCT, inverse discrete cosine transform L of the proposed CHIT, International Consultative Committee for Telephones and Telegraphs Low RM8 and H.261, and JPEG, Joint Pictures Expert Group R5. Baseline image compression standards. The device will optionally perform the variable threshold function in CHIT mode and the quantization and the zigzag run length coding in both modes. In addition, the inverse run length coding and inverse quantization can be performed. The L64740 can accept oct data directly from the L64730 oct processor and generate data for the L64730. In addition, the device will accept oct data in raster scanned or transposed formats. When operating as a CHIT encoder, the octo generates the run and level information to be coded and transmitted to the decoder and the quantized oct coefficients, which are processed by the inverse oct processor. The octo accepts the run and level information and reconstructs the oct coefficients, which are passed to the inverse oct processor when 8x8 data block handles continuous data streams, performs quantization and inverse quantization. 2 quantization tables for JPEG operation. Zigzag run length coding and decoding. Supports with proposed CHIT and JPEG standards. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. Operating in a CHIT decoder. Operation in JPEG systems is simpler. In the encoder, the device quantizes the incoming block of coefficients using 2 internally stored tables. After quantization, the coefficients are zigzag run length coded. In the decoder, the inverse oft 2 operations is performed. L64740 chip 30/40 MHz clock rates. Simple external control. 84-pin CPGA, ceramic pin grid array or PLCC. Plastic leaded chip carrier package. Description. Features. LSI. L64745. JPEG coder. Preliminary. The L64745 is a variable length encoder. Decoder used to implement the quantization. Zigzag run length coding and the variable length coding and decoding of events as spec. Ified in the proposed baseline JPEG, joint. Pictures expert group, standard. The device includes 4 quantization tables and 2 AC and OC variable length coding tables. When encoding, the processor will accept LL-bit oct coefficients as generated by the L64735 or similar device. The coefficients are quantized, coded, and buffered into 32-bit words. A 32-word output FIFO makes it possible to read the data in bursts. Compatible with proposed JPEG standard, 8R8. Performs quantization, run coding and variable length coding. 32-word coded data FIFO. 2 downloaded AC and OC code tables. 4 downloaded quantization tables. Can be cascaded with oct in encoder and decoder modes. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. When decoding, the device accepts 32-bit words from the buffer, decodes the events and reconstructs the oct coefficients, which are output in format suitable for processing by the L64735. The encoding and decoding operations can process 1 pixel and / or event each cycle. This feature makes it possible to cascade the L64745 with the oct processor, for high-speed image compression systems. The device can also be used to perform the lossless 2-to-0, two-dimensional, OPCM coding, excluding the 2-to-0 prediction, and to collect statistics for code table generation. Supports lossless mode. Mode for collecting statistics for code table generation. Can be used in non-JPEG systems. 2027 MHz data rates. 84-pin CPGA, ceramic pin grid array, or PPGA. Plastic pin grid array, or 100 lead PQFP, plus. TIC quad flat pack, package. 89. Description. Features. 90. LSI. L64750/51 chit. Variable length. Coder/decoder. Preliminary. The L64750 and L64751 perform the run length and variable length coding and decoding functions of the CHIT, Consultative Committee for International Telephones and Telegraphs. Video compression standard, respectively. The L64750 encoder accepts quantized oct coefficients from the L64740 oct quantization processor and parameters from the L64760 interframe processor and the motion compensator. The parameters include the quantization step size, the motion vectors, the loop filter flag, and the intra-decision flag. The data is multiplexed and coded according to the CHIT H.261 standard. The composite coded data is packed into 24-bit words for transmission or storage. The device encodes each quantized oct coefficient in a single cycle. The L64751 decoder accepts 24-bit words of composite coded data. The header information is decoded and system parameters are passed to the appropriate devices. Each quantized oct coefficient is decoded in a single cycle, and hence can be used in high-speed pipeline systems. The L64751 also optionally performs the inverse quantization and zigzag to raster conversion within each block. When Operating in this mode, the L64751 is connect directly to the L64730 IOCT processor without the need for a quantization processor. Compatible with proposed CHIT standard. Encoder and encoder. Packed 24-bit coded I/O. Simple interface to other L647XX devices. Up to 2027 MHz clock rates. Full or quarter CIF. Copyright 1990. 1991 LSI Logic Corporation. All rights reserved. Both devices were designed to operate with L64730, OCT processor, L64740, OCT quantization processor, and L64760, interframe processor, to form a compact video compers Xeon system that can operate at data rates ranging from those required for full CIF CHIT systems to those needed for processing broadcast quality video. L64750/51. L64750 is available in a 68-pin CPGA, ceramic pin grid array, or PPGA, plastic pin grid array, or 80-pin PQFP, plastic quad flat pack. L64751 is available in a 68-pin CPGA, ceramic pin grid array, or PPGA, plastic pin grid array, or 100-pin PQFP, plastic quad flat pack. Description. Features. Pin listing and description. Signal.o is always the LSB, LSI, L64760. Interframe. Processor. Preliminary. The L64760 performs many of the functions required for the interframe prediction oft. CHIT, Consultative Committee for International Telephones and Telegraphs. Video compression standard. The current frame data and the motion compensated. Optional, previous frame data are supplied as inputs to the device. The loop filtering will be performed if the previous frame data has been motion compensated. The decision is then made to process the data in an intraframe or interframe mode by comparing the energy of the luminance data in the current frame to the energy of the difference between the current and previous frame luminance data. The signal with less energy is sent to the OCT, discrete cosine transform, processor, decision made according to RM8. The reconstructed pixel values are generated by summing the prediction value with the output oft IDCT, inverse discrete cosine transform. In decoder mode, the inter-intra decision is transmitted from the variable length decoder, and the internal decision circuit is not used. All delays associated with internal or external processes are compensated internally and hence are transparent to the user. Compatible with CHIT H.26L. Loop filter. Internal/external intra-inter decision. Performs pixel reconstruction. System delays internally compensated. CFI.07. 8-bit data input bus for current frame pixel data. The data is input 1 macro block at a time, with each 8x8 pixel block raster scanned. This bus is not used in decoder mode. PFI.07. 8-bit data input bus for previous frame pix L data which has been motion compensated. If desired, the data is input 1 macro block at a time, with each 8x8 pixel block raster scanned. Copyright 1990, 1991 LSRL JGIC Corporation. All rights reserved. The device also generates strobes for the variable length coder, L64750, and the quantizer, L64740. In addition, the quantization step size from the channel data buffer is latched by the L64760 and into the quantization processor. At the next macro block boundary, the internal intra decision can be overridden externally for forced updating. L64760 chip. Up to 30/40 MHz clock rates. Simple external control. 100 pin CPGA, ceramic pin grid array, PQFP. Plastic quad flat pack, or PPGA, plastic pin grid array, package. PFO.07. 8-bit data output bus for previous frame. Pixel data. The data is output one macro block at a time, with each 8x8 pixel block raster scanned. This data updates the previous frame. Data store. Pixo.08. 9-bit predicted pixel output bus for data to be coded by the OCT processor. The data is output one macro block at a time, with each 8x8 pixel block raster scanned. This bus is not used in decoder mode. 91. LSI. MIPS microprocessors. Description. Features. RISE products. MIPS architecture. Microprocessors and peripherals. LSI. The LR2000 and LR3000 CPUs are high-speed HMOS implementations of the industry. Standard MIPS RISC, reduced instruction set. Computer. Microprocessor architecture. The MIPS architecture was initially developed at Stanford University under the auspices of DARPA. Both the LR2000 and LR3000 RISC microprocessors are extensions of Stanford MIPS architecture developed by MIPS Computer Systems Inc. This architecture, reduced instruction set computer, RISC architecture, MIPS instruction set, simple 32-bit instructions, register-to-register load store operation. All instructions, except MPY and DIV, EXE, queued in a single cycle. High performance. Fast instruction cycle with 5-stage pipeline. Efficient handling of pipeline stalls and exceptional events. Optional devices tightly pled for high performance. LR2010/LR3010 floating point accelerator, FPA. LR3220 read/write buffer. LR2020/LR3020 write buffers, WB. MIPSET workstation chipset. 32 general purpose registers. On-chip cache control. Copyright 1990. 1991 LSI Logic Corporation. All rights reserved. Makes possible a microprocessor that can execute instructions for high-level language programs at rates approaching 1 instruction per processor clock. The LR2000 and LR3000 microprocessors include on-chip memory management and support for up to 3 external coprocessors, including the single-chip LR2010 and LR3010. Floating point accelerators. On-chip memory management unit, MMU. Fully associative, 64-entry translation lookup. Side buffer, TLB. Supports 4 GB virtual address space. Multitasking support. User and kernel, supervisor, modes. Tightly coupled coprocessor interface. Generates all addresses and handles memory. Interface control. Supports up to 3 external coprocessors. Strong, integrated software support. RISC/OS operating system. SVIO compliant version of Unix. Optimizing compilers. CADA, Vertex. Fortran LPI COBOL. Pascal LPI PLL. Systems Programmers Package. A complete integrated toolkit used to bring up target systems. 95. RISE Products LSI. MIPS architecture. Microprocessor. And peripherals. Components family product code description clock rate, megahertz, packages. LR2000 MIPS RISC CPU 12.5, 16.7 144 CPGA. LR2010 floating point accelerator 12.5, 16.7 84 CLDCCJ. LR3000 MIPS RISC CPU 16.7, 20, 25 172 CLDCC. Military version 16.7, 20 144 CPGA. LR3000A enhanced MIPS RISC CPU 25 33.3 175 CPGA, cavity down. 172 CLDCC, cavity down. LR3010 floating point accelerator 16.7, 20, 25 84 CPGA, cavity down. Military version 16.7, 20 84 CLDCC, cavity down. LR3010A enhanced FP accelerator 25 33.3 84 CPGA, cavity down. 84 CLDCC, cavity down. LR3220 integrated read-write buffer 25 33.3 180 CPGA. 184 PQFP. MIPSET LR3201 RST/int controller 20, 25 64 PQFP. LR3202 L bus controller 20, 25 208 PQFP. LR3203 DROM controller 20, 25 160 PQFP. LR32D04 integrated DROM data buffer 20, 25 100 PQFP. LR3205 block transfer buffer 20, 25 208 PQFP. MIPS 9 RPM 3310 LR3000 and LR3010 module 20, 25 module board. WI32K1 and 0 cache and RIW buffer. RPM 3330 LR3000A and LR3010A module with 33.3 module board. 64K1 and 0 cache with multiprocessor. Support. Embedded LR33000 highly integrated MIPS 2533.3 155 CPGA. Processor-based embedded processor 25 160 PQFP. 96. Description. Features. LSI. LR2000 MIPS. RISE microprocessor. The LR2000 CPU is a high-speed MOS. Implementation of MIPS RISC, reduced. Instruction set computer. Microprocessor. Architecture. The MIPS architecture was entirely developed at Stanford University under the auspices of DARPA. The LR2000 is an extension of the Stanford MIPS architecture, developed by MIPS Computer Systems Incorporated. This architecture makes possible a microprocessor that can execute instructions for high-level language programs at rates approaching 1 instruction per processor clock. It supports up to 3 tightly coupled coprocessors, including the single-chip LR2010 floating point accelerator. The full custom 32-bit VLSI CMOS reduced Instruction set computer shown in the CPU. Chip photo includes 32-32-bit registers. On-chip TLB, translation look-aside buffer. Memory management unit, and cache control. Circuitry. Reduced instruction set computer, RISC. Architecture. MIPS instruction set. Simple 32-bit instructions, single addressing. Mode. Register to register, load store operation. All instructions, except MPY and DIV. Execute in a single cycle. High performance. Fast instruction cycle with 5-stage pipeline. Efficient handling of pipeline stalls and exceptional events. 2-speed versions. LR2000 GC 12.5 MHz 8 VA SMIPS. Equivalents. LR2000 GC 16.7 MHz 10 VAX MIPS. Equivalents. Optional devices tightly coupled for high performance. LR2010 Floating Point Accelerator, FPA. LR2020 Write Buffers, WB. 32 General Purpose Registers. On-chip cache control. Separate external instruction and data cache. Memories. From 4 to 64 KB each. Both cache memories accessed during a single CPU cycle. Copyright 19BB, 19B9, 1990, 1991 LSI Logic Corporation. All rights reserved. LR2000 CPU chip. Dual cache bandwidth up to 133 bytes. Second. Uses standard SRAMs. LR2000 GC 1235 NS access time. LR2000 GC 1625 NS access time. On-chip memory management unit, MMU. Fully associative, 64-entry translation. Look-aside buffer, TLB. Supports 4 GB virtual address space. Multitasking support. User and kernel, supervisor, modes. Seamless coprocessor interface. Generates all addresses and handles. Memory interface control. Supports up to 3 external coprocessors. Strong, integrated software support. RISC-less operating system. System v.3, 4.3 BSD. Optimizing compilers. C-Ada, Vertex. Fortran COBOL, LPIL. Pascal PL1, LPIL. Systems Programmers Package. A complete, integrated toolkit used to bring up target systems. 144-pin CPGA, ceramic pin grid array, package. 97. Description. Features. 98. LSI. LR2010 MIPS. Floating point. Accelerator. Preliminary. The LR2010 Floating Point Accelerator, FPA. Provides high-speed, floating point capability for systems based on the LR2000 CPU. The organization of FPA architecture is similar to that of the CPU, allowing high-level language compilers to optimize both integer and floating point performance. The LR2010, with associated system software, fully conforms to the requirements and recommendations of ANSI/IEEE Standard 754-1985. The LR2010 connects seamlessly to the CPU. Since both units receive instructions in parallel, floating point instructions can be initialized at the same single cycle rate as fixed point instructions. Fully compatible to ANSI/IEEE Standard 754. 1985 Floating point arithmetic. Supports single and double precision data. Formats: high speed throughput, low latency. 2-speed versions: LR2010 LC 12.5 MHz, LR2010 LC 16.7 MHz. Highly pipelined architecture coupled with optimizing compilers generates high throughput. Load/store oriented instruction set initiates floating point instructions in a single cycle and overlaps execution with additional fixed or floating point instructions. Status/control registers implemented to provide access to all IEEE standard exception handling capability. 16 on-chip 64-bit registers individually accessible for flexible operation. Complete instruction set. Single and double precision multiply, divide, add, subtract, negate, absolute value. Copyright 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. LR2010 FPA chip. Conversion to / from all supported formats. Comparison instructions derived from predicates named in IEEE standard. 84-pin CLDCC, ceramic leaded chip carrier. Package. LR2010 FPA Performance Floating Point Bench. Marks. LinPack. Single precision 4.8 M flops. Double precision 2.2 M flops. Whetstone. Single precision 11.4 M whips. Double precision 9.1 M whips. Livermore loops. Single precision. Double precision. Spice. 256. FFT. 9.6x VAX 11/780. 12.1x VAX lanes O. 9.7x VAX 11/180. 23x VAX 11 NSO. Introduction. Features. LSI. LR3000 MIPS. RISE microprocessor. The LSI Logic LR3000 is a 32-bit RISC-reduced instruction set computed microprocessor for use in multi-processing servers to low-cost workstations, and high-performance embed DED controllers through various military applications. The LR3000 consists of two tightly coupled processors implemented on a single chip. The first processor is a full 32-bit CPU, which incorporates RISC techniques to achieve a new standard of microprocessor performance. The second processor is a SYS TEM control coprocessor, referred to as CPO, which contains a translation look-aside buffer, TLB, and control registers to support a virtual memory subsystem with a dual cache band width of up to 200 MB/s. The MIPS architecture grew out of earlier RISC hardware and software development efforts at Stanford University. Developing the hardware and software in tandem enabled the system architects to make performance trade-offs across the hardware/software boundary. They verified that every function or feature that complicated the hardware design measurably enhanced system performance before implementing it. RISC architecture. MIPS instruction set. Load/store architecture supports configurable and ENS and misaligned data. All instructions execute in one cycle, except multiply and divide, and the system execution rate approaches one instruction per cycle. 5-stage pipeline provides precise, efficient handling of pipeline stalls and exceptions. LR2000 compatible instruction set. Complete on-chip cache control supports SEP AutoIt, external data and instruction caches of up to 256 KB each. Both caches are accessible during a single CPU cycle. On-chip memory management unit, MMU. With fully associative, 64-entry translation. Look-aside buffer, TLB, provides fast address translation for virtual to physical memory map. Ping of up to 4 bytes of virtual address space. Seamless coprocessor interface generates all. Copyright 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. LR3000 chip. The resulting instruction set is very well tuned for high-level language use, in contrast to many other machines labeled RISC, which have user-level instructions or instruction mode combinations that are very difficult to reach from compiled languages. Addresses and handles memory interface control for up to 3 tightly coupled external coprocessors, including the LR3010 floating point accelerator, FPA. Strong integrated software support includes the RISC/OS operating system, SVID compliant version of Unix, and high-performance optimizing compilers for C, Pascal, Fortran, Ada, COBOL, and PL/1. Flexible, on-chip multiprocessor support for low-cost duplicate tags or a high-performance secondary cache system. Development system supports complete native hardware, software, and applications. Development environment. 3 speed options, 16.67, 20, and 25 MHz. Provide a wide price/performance range. Multi-source pin compatibility in advanced LSI. Logic 172-pin CLDCC, ceramic leaded chip car. Rear, and 144-pin CPGA, ceramic pin grid array. Packages. 99. I. 1 backslash. 1:1. 2. I. Introduction. Features. 100. LSI. LR3000A MIPS. RISE microprocessor. Preliminary. The LSI Logic LR3000A is a 32-bit MIPS. Reduced Instruction Set Computer, RISC. Microprocessor for use in applications that include multiprocessing servers, low-cost workstations, and high-performance embed DED controllers. The LR3000A consists of 2 tightly coupled processors implemented on a single chip. One processor is a 32-bit CPU, which incorporates RISC techniques to achieve a new standard of microprocessor performance. The other processor is a system control coprocessor that contains a translation look-aside buffer, TLB, and control registers to support a virtual memory subsys TEM with a dual cache bandwidth of up to 267 bytes/second. The LR3000A maintains compatibility with the LR3000 while providing several enhancements. The MIPS architecture grew from earlier RISC hardware and software development efforts at Stanford University. Developing the hardware and software in tandem enabled the system architects to make performance trade-offs across the hardware/software boundary. Any function or feature that complicated the hard MIPS I instruction set. 2 speed options, 25 and 33.33 MHz, provide a wide price/performance range. Load/store architecture supports configurable byte ordering and misaligned data. All instructions execute in one cycle, except multiply and divide, and the system execution rate approaches one instruction per cycle. 5-stage pipeline provides precise, efficient handling of pipeline stalls and exceptions. Complete on-chip cache control supports SEP, AutoIt, external data and instruction caches of up to 256 KB each. Both caches are accessible during a single CPU cycle. On-chip memory management unit, MMU. With fully associative, 64-entry translation. Look-aside buffer, TLB, provides fast address translation for virtual to physical memory map. Ping of up to 4 GB of virtual address space. LR3000A enhanced features include parity, error detection, ignore parity option, byte ordering reversal and a high impedance option. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. LR3000A chip, where design was implemented only if it may assuredly enhance system performance. The resulting instruction set is very well tuned for high-level language use, in contrast to many other machines labeled RISC, which have user-level instructions or instruction mode combinations that are very difficult to reach from compiled languages. For the ADR low bus during multiprocessor stalls. Flexible, on-chip multiprocessor support for low-cost duplicate tags or a high-performance secondary cache system. Seamless coprocessor interface generates all addresses and handles memory interface control for up to 3 tightly coupled external coprocessors, including the LR3010A floating point accelerator, FPA. Strong integrated software support includes the RISC/OS operating system, SVID compliant version of Unix, and high-performance optimizing compilers for C, Pascal, Fortran, Ada, COBOL, and PL/L. Development system supports complete native hardware, software, and applications. Development environment. Multi-source pin compatibility in advanced LSI. Logic 172-pin CLDCC, ceramic leaded chip car. Rear, and 175-pin CPGA, ceramic pin grid array. Packages. Description. Features. LSI. LR3010 MIPS. Floating point accelerator. The LR3010 floating point accelerator, FPA, provides high-speed, floating point capability for systems based on the LR3000 CPU. The organization of FPA architecture is similar to that of the CPU, allowing high-level language compilers to optimize both integer and floating point performance. The LR3010, with associated system software, fully conforms to the requirements and recommendations of the ANSI/IEEE Standard 754-1985. The LR3010 connects seamlessly to the CPU. Since both units receive instructions in parallel, floating point instructions can be initiated at the same single cycle rate as fixed point instructions. Fully compatible to ANSI/IEEE Standard 754-1985 floating point arithmetic. Supports single and double precision data formats. High-speed throughput, low latency. 3-speed versions, 16.7, 20,25 MHz. Highly pipelined architecture coupled with Mising compilers generates high throughput. Load/store oriented instruction set initiates. Floating point instructions in a single cycle and overlaps execution with additional fixed or floating point instructions. Status/control registers implemented to provide access to all IEEE standard exception handling capability. 16 on-chip 64-bit registers individually accessible for flexible operation. Complete instruction set. Single and double precision multiply, divide, add, subtract, negate, absolute value. Conversion to / from all supported formats. Copyright 1988, 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. LR3010 FPA chip. Comparison instructions derived from predicates named in IEEE standard. Available in 84-pin CLDCC, ceramic leaded chip. Carrier, cavity down, and 84-pin CPGA, CRAM. IC pin grid array, cavity down, packages. LR3010 FPA performance floating point bench. Marks. Spec floating point 16.8. Unpack. Single precision 7.1 M flops. Double precision 4.0 M flops. Whetstone. Single precision 13.6 M whips. Double precision 16.4 M whips. Livermore loops. Single precision. Double precision. Spice. 256. FFT. 14.4 x VAX 11 N80. 18.2 x VAX 11/780. 16.0 x VAX 11/780. 29.0 x VAX 11/780. 101. I. 3. F. Description. Features. 102. LSI. LR3010A MIPS. Floating point. Accelerator. The LR3010A floating point accelerator, FPA, provides high-speed, floating point capability for systems based on the LR3000A CPU. The organization of FPA architecture is similar to that of the CPU, allowing high-level language compilers to optimize both integer and floating point performance. The LR3010A, with associated system software, fully conforms to the requirements and recommendations of the ANSI/IEEE Standard 754-1985. The LR3010A connects seamlessly to the CPU. Since both units receive instructions in parallel, floating point instructions can be initiated at the same single cycle rate as fixed point instructions. Fully compatible to ANSI/IEEE Standard 754-1985 floating point arithmetic. Supports single and double precision data formats. High speed throughput, low latency. 2-speed versions, 25 and 33 MHz. Highly pipelined architecture coupled with optimizing compilers generates high throughput. Load/store oriented instruction set initiates floating point instructions in a single cycle and overlaps execution with additional fixed or floating point instructions. Status/control registers implemented to provide access to all IEEE standard exception handling capability. 16 on-chip 64-bit registers individually accessible for flexible operation. Complete instruction set. Single and double precision multiply, divide, add, subtract, negate, absolute value. Conversion to / from all supported formats. Comparison instructions derived from predicates named in IEEE standard. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. LR3010 AFPA chip. Available in 84-pin CLDCC, ceramic leaded chip. Carrier, cavity down, and 84-pin CPGA, ceram. IC pin grid array, cavity down, packages. LR3010 AFPA performance floating point. Benchmarks. Spec floating point 16.8. Unpack. Single precision 7.1 M flops. Double precision 4.0 M flops. Whetstone. Single precision 13.6 M whips. Double precision 16.4 M whips. Livermore loops. Single precision. Double precision. Spice. 256. FFT. 14.4 x VAX 11/780. 18.2 x VAX 11/780. 16.0 x VAX 11/780. 29.0 x VAX 11/780. Introduction. Features. LSI. LR3220 MIPS. Read-write buffer. Preliminary. The LR3220 read-write buffer enhances the performance of MIPS architecture-based SYS TEMS by buffering write and read operations. Using the read-write buffer, the system can perform memory write operations at the cycle rate of the processor, instead of stalling the processor to write data to memory. On memory read operations, the system uses the read-write buffer to pass the read address to main memory and latch the read data from memory. The read-write buffer generates parity and then passes the data and parity to the processor. A single LR3220 provides 6 deep write buffering and 1 level of read buffering for 32 bits of address and 32 bits of data. It operates at the system clock rate, and is available at 25 and 33.33 MHz to support the requirements of LR3000 based systems. Combines the functionality of 4 LR3020 write buffers. Minimizes additional loading on the address and data buses with on-chip data and address. Latches for read operations. Supports big endian and little endian byte order addressing. Uses byte mask outputs to ease system design. Performs block mode conflict detection for block sizes of 8 words or less. Offers separate enable signals for all address and data buses. Supports fast page mode writes for 1 Mbit. DRAM-based memory implementations. Provides 6 deep write buffering of data and addresses. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. LR3220 chip. Supports 2 operating modes. 1. LR3000 mode. Compatible with the LR3000 staggered address and tag bus timing, decodes. ACC tip 1:0 and ADR low 1:0 inputs for byte ordering. 2. Harvard mode. Uses synchronous address latching on the rising edge off clock. Uses byte mask inputs for byte ordering. Offered in both LBO pin CPGA, ceramic pin grid array, and compact LB4 pin PQFP, plastic quad. Flat pack, packages. 103. I. Description. MIPSET system block. Diagram. 104. LSI. MIPSET chips. The MIPSRRRM chips are the industry's first complete set in support of the MIPS RISC microprocessor. The MIPS RISC architecture is regarded as the highest performance microprocessor available today and is already used in a variety of applications including 3D graphics, workstations, super mini computers, online transaction processors and high-performance desktop systems. Virtually all of these systems have required extensive engineering time and effort to complete. The MIPSET chips provide a common solution for the basic functions of a computer, allowing the system vendor to significantly reduce design cache. Max 64 key. MIPSET chips. Copyright 1990-1991 LSI Logic Corporation. All rights reserved. Cost and effort while accelerating time to market. All without compromising performance. LSI Logic's MIPSET chips include the LR3201 reset/interrupt controller, the LR3202L bus controller, the LR3203 DRAM controller, the LR32D04 DRAM data buffer and the LR3205 block transfer buffer along with the LR3000A CPU and the LR3010A floating point accelerator. With the MIPSET chips, cache, main memory, ROM, SCSI, Ethernet, floppy disk, controller, 1 parallel and 4 serial ports, a complete workstation can be implemented with as few as 30 ICs. Description. Features. Block diagram. LR3201 MIPSET RST INT controller. Preliminary. LSI. The LR3201 RST INT controller device is designed to control the reset and interrupt inputs for the LR3000 CPU, and the initialization sequence defined by the LR3000 mode select. Programming of the W, X, Y, and Z cycles during reset. LR3201 chip. Up to 25 MHz LR3000 system. Schmidt trigger type asynchronous reset input. W, X, Y, and Z cycle support for LR3000 CPU. Initialization. Asynchronous reset input, and synchronous reset output for LR3000 CPU. Interrupt input synchronization. Selectable reset output active time length 132 or 8196 clock cycle cell. RSTI star. RLSL. IRSET LE. MSW.4:0. MSX.4:0. MSY.4:0. MSZ.4:0. R3K star. INT star.5:0. CLK. VDD. VSS. Test star. TS2. NGTH select. 5. 5. 5 MUX R. 5-6. Copyright 1990-1991 LSI Logic Corporation. All rights reserved. Synchronizer. N. State logic. _R. IMUX. Synchronizer. 6. Asterisk, active low signal. RS2 star. SCA no star. Into star.5:0. 105. Description. Features. 106. LSI. LR3202 MIPSET. Bus Controller. Preliminary. The LR3202 bus controller is a member of the LR3000 microprocessor peripheral chip family, and is designed to provide the functions critical to implement LR3000-based general purpose computer systems. The LR3202 bus controller interfaces directly with LR3000 cache bus, C bus low, and the complete control logic necessary for data transfer between cache and memory subsystem are supported. The LR3202 acts as a master device for L-bus, which is newly defined by LSI logic and designed to accommodate a chip-level connect with a variety of memory and I/O controllers. Up to 25 MHz LR3000 system. Big endian/little endian mode selection. LR3000 cache bus interface. External read buffers might be required for high clock frequency, 25 MHz, system. Memory and I/O local bus, L-bus, interface. Accommodates general purpose peripheral controllers. Bus arbitration. Arbitration for the access to L-bus, instruction fetch, data read, data write, and DMA request. Block refill operation for both instruction and data read are supported via L-bus burst transfer. Programmable selection of 4, 8, 16 or 32 words block refill mode. 8-level deep write buffer FIFO. Copyright 1990. 1991 LSI Logic Corporation. All rights reserved. LR3202 chip. Boot ROM interface. Boot ROM chip select output signal. 32-bit or 8-bit boot ROM data bus width. Selection, data assembly for 8-bit mode. Programmable wait state cycle control. DROM main memory interface. Interface to LR3203 DROM controller. Programmable DROM refresh interval timer. 3 independent I/O area selection outputs. With programmable wait state cycle control. Vectored interrupt interface, up to 256 type. Vectored interrupts. 2 24-pin CPGA, ceramic pin grid array, or 2 08-pin PQFP, plastic quad flat pack, gull wing, package. Description. Features. LSI LRJ20J MIPSET DROM controller. Preliminary. The LR3203 DROM controller is a member of the LR3000 microprocessor peripheral chip family and is designed to provide interface necessary to build an L-bus-based main MEM or a subsystem. The LR3203, when used in conjunction with the LR3204 DROM data bus buffer, allows the system designer to build a highly integrated memory system. Up to 25 MHz operation in LR3000 system. Variety of DROM components, 1mx1, 256kx4. 4mx LOR 1mx4. Two-way interleaved DROM implementation. Allowing block refill or burst transfer, maximum 32 words, over L-bus, LSI logic local bus, at 100 MB/SEC equals peak transfer rate. Either 8 MB or 16 MB memory area. Supported per LR3203 when used with 1mx1 bit DRAMs. Maximum 16 MB memory area with 2 MB granularity supported per LR3203. When used with 256kx4 bits DRAMs. Copyright 1990. 1991 LSI Logic Corporation. All rights reserved. LR3203 chip. Either 32 MB or 64 MB memory area. Supported per LR3203 when used with 4MX1 bit DRAMs. Maximum 64 MB memory area with 8 MB granularity supported per LR3203. When used with 1MX4 bit DRAMs. Read modify write mode at partial word write. Operation for X4 type DRAM parity bits or ECC. Redundant bits. 160 pin PQFP, plastic quad flat pack, package. 107. Description. Features. 108. LSI. LR32D04 MIPSET. DRAM data bus. Buffer, 16-bit. Preliminary. The LR32D04 DRAM bus buffer is a member of the LR3000 microprocessor peripheral chip family and is designed to function as a data buffer to / from a DRAM array LR32D04 also works as a data parity generator and checker. By generating parity bits when writing a data to DRAM main memory, or checking parity bits when reading a data from DRAM array _ the LR32D04 performs its function as a 16-bit half-word device, thus, 2 LR32D04 SR required to build a system based on M3 chipset. In conjunction with the LR3203 DRAM controller, the LR32D04 DRAM data bus buffer provides a complete interface solution NACs. Sorry for a main memory subsystem built around the various types of DRAM components widely available in the market. Up to 25 MHz LR3000 system. 2 LR32D04s required for 32-bit data bus. Data separator and / or selector for two-way interleaved DRAM bank. Direct drive capability for DRAM data bus. 12 MA type high-speed output buffer. Copyright 1990-1991 LSI Logic Corporation. All rights reserved. LR32D04 chip. Optional read modify write function for facing with 4-bit wide ORM components. Lupin CPGA, ceramic pin grid array, or Lupin PQFP, plastic quad flat pack, package. Description. Features. LSI. LR3205 MIPSET. Block transfer. Buffer. Preliminary. The LR3205 block transfer buffer is a member of the LR3000 microprocessor peripheral chip family and is designed to provide the interface between the system bus, the L bus, and VARI US110 devices via DUC South or 16-bit I/O channels, called the B bus channels and the E channels, respectively. The B bus provides 3 ohms channels for S-bit 110 devices and the E channel is intended to interface with a 16-bit device. Each ohms channel can be programmed independently, and contains the S-word X32-bit FIFO memory, which allows burst mode data transfers between the DRAM main memory subsys TEM and each 110 device. The LR3205 can interface to AMD 7990 LANs and NCR53C90 SCSI controller without any glue devices. Up to 25 MHz LR3000 system. Big Endian / Little Endian mode selection. 4 independent DMA channels, 116/S-bit channel and 3 S-bit channels. Byte-to-word assembly and word-to-byte disassembly function. S-word X32-bit FIFO memories for each channel. Forward burst block transfer to or from main. Memory. Direct interface capability to AM7990 LANs. An NCR53C90 SCSI controller. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. LR3205 chip. Independent polarity control of DMA acknowledge. Edge outputs. Internal or external end of process control for each channel. Reset control outputs for each channel 110. Device. Cascading capability for more than 4 DMA channels. 20 S-pin PQFP, plastic quad flat pack, gull wing, package. 109. Description. Features. 110. LSI. LR33000. MIPS RISE. Embedded processor. The LR33000 processor is a MIPS-compatible single-chip controller designed for high-performance embedded processor applications. With its onboard caches, write buffer and flexible memory interface, it facilitates low-cost embedded processor designs requiring the high performance of 32-bit RISC. The LR33000 consists of a MIPS CPU core, along with system functions which significantly reduce the overall number of chips required to build a system. This reduction in component count helps to substantially cut the overall SYS/TEM cost and power consumption and improve system reliability. This processor maintains user binary software compatibility with the LR2000 and LR3000/A implementations of MIPS architecture, allowing direct portability. Oft growing base of MIPS software and development tools. The LR33000's bus interface design allows it to interface to the rest of system in a simple and cost-effective manner. The LR33000's SYS/TEM on a chip approach integrates the following units onto a single device: MIPS compatible CPU, 8 KB of instruction cache, LKB of data cache, write buffer, timer/counters, DROM controller, 8 and 32-bit wide boot PROM support, programmable wait state generators, and an improved memory interface. RISC architecture. MIPS instruction set. Single cycle instruction execution. LR2000/LR3000/LR3000A user software. Binary compatibility. High on-chip integration. 8 KB iCache. 1 KB dcache. 1 deep write buffer. 3 timers/counters. Integrated DROM controller. Simple I/O interface. Direct DROM interface. Glueless 8-bit boot PROM support. Direct interface to other memories and peripherals. DMA interface support. Programmable wait state generation. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. LR33000 chip. The LR33000 is specifically tuned for applications that requires high performance yet are sensitive to systems cost and power consumption. This embedded processor fits into applications such as laser beam printers, X-window terminals, LAN controllers, I/O processors, disk controllers, graphics rendering and military/avionics. Simple LX clock input. Debug features. Hardware breakpoint registers. Instruction trace capabilities. Cache coherency support. Bus snooping. Cache invalidate command. High performance. 5-stage pipeline. Efficient handling of pipeline stalls and exceptions. Reduced power requirements. 3-speed versions. 25/33/40 MHz. Packages. L55 pin CPGA, ceramic pin CRID array. LBO pin PQFP, plastic quad flat pack. Description. Features. LSI. RPM 3310. MIPS 9 module. The RPM 3310 trademark module is a high-performance MAN CPU subsystem based on the MIPS. RISC, Reduced Instruction Set Computer. Architecture. The 9 module combines LSI, Logix LR3000 MIPS microprocessor and LR3010 floating point accelerator with 64 KB of instruction and data cache on a compact, self-contained module. By INTE grad. ing the 4-phase clock generation circuitry and cache memory on the RPM 3310, all critical TIM ing paths are confined to the module. In addition, the onboard reset configuration logic greatly simplifies adapting the RPM 3310 to operate in a wide range of applications. 18 to 20 VAX MIPS performance at 25 MHz. 14 to 16 VAX MIPS performance at 20 MHz. Integer and floating point capabilities. 32 KB each of instruction and data cache. 6-word deep write buffer. Onboard 4-phase clock generation and reset. Configuration logic. Buffered I/O and control signals. Programmable block refill sizes for data and instructions. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. The compact size of the module is achieved by utilizing a double-sided printed circuit board with direct die attach assembly. Thermal management and electrical properties are greatly enhanced by utilizing this technology. LSI Logix RPM 3310 is the first of a line of MIPS pin and function compatible modules. This means the ability to upgrade your SYS/TEMS performance by simply plugging in LSI Logic's newest 9 module. Instruction streaming. Even parity generation for read operations. Low power consumption. 5 registered interrupt inputs. Compact size, 3.5 x 3.5 x 0.67, packaged on a double-sided PCB. Direct silicon onboard technology. CPU and FPA silicon mounted on integral head. Spreaders. 100 pin amp connector. 111. Description. Features. 112. LSI. RPM 3330. MIPS 9 module. The RPM 3339 trademark module is the second generation of LSI Logic's high-performance CPU subsystem based on the MIPS RISC. Reduced Instruction Set Computer, Architecture. The 9 module combines LSI Logic's LR3000A MIPS microprocessor and LR3010A floating point accelerator with 128 KB of instruction and data cache on a compact, self-contained module. By integrating the 4-phase clock generation circuitry and cache memory on the RPM 3330, all critical timing paths are 0.27 VAX MIPS performance at 33 MHz. Multiprocessing support. Hardware cache invalidation. Integer and floating point capabilities. 64 KB each of instruction and data cache. 6-word deep write buffer. Onboard 4-phase clock generation and reset. Configuration logic. Buffered I/O and control signals. Programmable block refill sizes for data and instructions. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. Confined to the module. In addition, the on-chip reset configuration logic greatly simplifies adapting the RPM 3330 to operate in a wide range of applications. The compact size of the module is achieved by utilizing a double-sided printed circuit board with direct die attach assembly. Thermal management and electrical properties are greatly enhanced by utilizing this technology. Instruction streaming. Even parity generation for read operations. Low power consumption. 5 registered interrupt inputs. Compact size, 3.5 x 3.5 x 0.67, packaged on a double-sided PCB. Direct silicon onboard technology. CPU and FPA silicon mounted on integral head spreaders. 100-pin high-speed amp connector. Overview. Benefits. LSI. MIPS system. Programmer 1S. Package. The SSP, System Programmers Package, accelerates the development of systems based on the high-performance MIPS RISC architecture. SSP allows system developers to execute MIPS software on an instruction set simulator to make cache memory architectural trade-offs early in the design cycle and to debug software on a target system. SPP includes utilities. Start software development early using Simu. Later, simulates the target system, allowing the designer to debug system software before the target hardware is ready. Meet memory system cost and performance goals. Models different memory subsystems, ensuring the target system meets cost and performance objectives. Host. Computer. I. D. II. R. I. To help build standalone software and download the software to a target system. SPP is a source code product that can be customized to the user's target environment. SPP helps shorten development time since software development can begin before target hardware is ready. Develop software easily with a high-level debugger. Symbolically debugs code running on the simulator or a remote target at the source level. Compile and link quickly using the MIPS RIS computer. Offers a robust programming environment in which developers can quickly compile optimized software for a target machine. Debugger RS-232 standalone program. Compilers. Simulator. RISC/OS. I. Ethernet. SPP was designed to meet the unique requirements of customers developing MIPS-based embedded systems and Unix systems. Unlike CISC-based systems, MIPS-based systems often include cache memory to meet cost and performance objectives. SPP includes tools to model memory subsystems. In the past, the use of software simulation was limited by the performance of CISC-based computers. Since SPP is hosted on high-performance MIPS. Copyright 1990. 1991 LSI Logic Corporation. All rights reserved. Debug monitor. Monitor shell. Prom monitor. I. Target. ISTM S. RIS computers, Instruction set simulation is a viable alternative for software development before the target hardware is available. SPP includes a target monitor for standalone software development. In addition, SPP includes a standalone I/O library and a high-level debug GER for both simulation and target execution. Because SPP is provided with source code, the user can configure SPP to a specific target environment. 113. Description. Features. 114. LSI. Milsto 1750A. L64500. Microprocessor. The LSI Logic L64500 is a monolithic 1.5 micron drawn gate length, 0.9 micron effective chan length MOS chip which implements the MIL STD1750A. Notice 1, instruction set. Architecture, LSA. The L64500 is a 16-bit central processing unit, CPU, used for real-time processing. The CPU uses a sophisticated ALU architecture which is expandable up to 32 bits depending on the operation and uses SEP, AutoIt address and data buses to improve SYS/TEM performance. It also contains independent instruction operand fetch and execution units. The L64500 can be augmented with the L64550 MBU chip to implement optional enhancements of MIL STD1750A. The L64550 includes a memory management unit, MMU, with memory expansion capabilities up to 1 M. Words of memory, the block protect unit. BPU, memory fault status register, MFSR. The bus arbitron unit, BAU, with 6 bus MOS. TERS, startup ROM interface, discrete 1/0 port. Trigger go counter and other options. The L64500 CPU and the L64550 MBU chips were designed as a system to optimize the performance. The L64500 is included in LSI Logic's MDE registered design tools as an ASIC library. Single chip high performance microprocessor. Implements MIL STD1750A. Notice 1. Instruction set architecture. 1.5 micron gate length MOS 2-layer metal cell-based technology. 30 MHz operation over full military range. Power dissipation 1W. TTL compatible interface. Flexible packaging capability. Available as ASIC hard macro library element. Copyright 1990-1991 LSI Logic Corporation. All rights reserved. Chip layout. Element. This element can be used as a hard macros when combined with gate arrays or standard cells, or can be used in multi-chip system simulations when adding new ASIC chips to the system. The L64500 is available in several speed grades from 15 MHz to 30 MHz over the full mil. Iterary temperature range of -55 degrees to 125 degrees Celsius. Continuous panel mode operation. Performance optimized architecture. Split data and address bus. Variable width ALU, up to 32 bits. Instruction prefetch. Multi-port register files. Timers A and B included on chip. 64K word address space expandable to 1 M. Word with optional MBU chip. Description. Features. LSI. Milsto 1750A. L64550. MBU peripheral. The LSI Logic L64550 memory management and block protection unit device is a monolith. IC 1.5 micron drawn gate length, 0.9 micron. Effective channel length, MOS chip. Designed to support the L64500 CPU, MIL STD. 1750 AISA. The L64550 contains a number of MIL STD 175OA support options including the Memory Management Unit, MMU, with map. Ping RAM, Block Protect Unit, BPU, with Protection RAM, Memory Fault Status Register. MFSR, Watchdog Timer, and Startup ROM. Interface. In addition, the L64550 contains auth-ER options such as, a bus arbitrator with up to 6 bus masters, extended addressing capability to 8M words, a discrete I/O port, sophisticated CPU/MBU handshake to increase performance, and bus timeout timer. The MMU allows addressing of up to 1M word memory. In applications not requiring adherence to the standard, addressing can be extended to 8M words. The MMU performs the logical to physical address translation and protection of logical space. The BPU provides write protection in 1K page granularity for up to 1M word of physical memory for both L64500 CPU and DMA access. If desired, the MMU and the BPU can be individually disabled. 1.5 micron gate length MOS technology. 30 MHz operation over full military range. Power dissipation. Memory Management Unit, MMU, with 512x16. Cache RAM. Block Protect Unit, BPU, with 128x16 cache RAM. Hit/miss mechanism. Discrete I/O ports. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. Chip layout. The L64550 MBU and L64500 CPU are included in LSI Logic's MDE registered design tools as ASIC library elements. These elements can be used as gigacells when combined with gate arrays, or standard cells, or they can be used in multi-chip system simulations when adding new ASIC chips to the system. The L64550 is available in several speed grades from 15 MHz to 30 MHz over the full military temperature range of -55 degrees Celsius to 125 degrees Celsius. Extended addressing to 8M words. Bus arbitration unit with up to 6 bus masters. Memory Fault Status Register, MFSR. Startup ROM interface. Bus timeout timer. Watchdog timer. TTL compatible interface. Flexible packaging capability. 115. Description. Features. Radiation test data. Technical information. Ordering information. 116. Milsto 1150A. L64501. Radiation hardened. Microprocessor. LSI. The L64501 CPU from LSI Logic is a radiation hardened, single chip implementation of the MIL STD 1750A instruction set. The cell-based L64501 provides separate address and data buses for enhanced performance, and it utilizes the LSI Logic radiation hardened tool ER metal MOS process technology for reliable operation. The L64501 can interface directly with the L64551 memory management and block protect unit, MBU, also available from LSI logic, to provide optional MIL STD 1750A enhancements and to optimize system performance. Total ionizing dose specification 200 CRAD, SI. No single event upset, SE ULACHUP detected. Tested to let equals 70 MeVCM2/Ma. SEU cross-section of 3.13 times 10 to the power of -6 cm/bit. 24.7 MeVCM2 per milligram, let, threshold. Guaranteed post-radiation clock frequency of 25 MHz. MIL STD 883C/38510 Class B and Class S. Screening options. Silicon gate epitaxial 2-layer metal. LRH 10000 MOS technology. MIL STD 1750A, Notice 1, Instruction Set. LSI logic characterized the L64501 for total ionizing dose radiation effect and single event upset, SEU, phenomena. Total dose radiation. Testing was performed in accordance with MIL STD 883C, method 1019.2, and utilized a cobalt-60 gamma ray source. Following irradiation up to 200 CRAD, SI, the L64501 devices passed test characterization at 25 MHz. LSI logic conducted SEU testing at Brookhaven National Laboratory using the to shorten the design cycle for L64501 based systems, L64501 CPU and L64551 MBU models are available in LSI Logic's MDE registered design tools. The MDE design tools provide extensive design flexibility through its multi-chip and SYS TEM simulation capabilities. The radiation-hardened L64501 operates at 25 MHz over the military temperature range, -55 degrees Celsius to 125 degrees Celsius, and utilizes a single 5V plus or -10% power supply. CFAC certification for L64501 CPU and optional L64551 MBU. Optional timers A and B implemented on chip. Directly interfaces with optional L64551 MBU, which provides memory management and block protect capabilities and additional MIL STD 175OA options. TTL compatible interface. Available in 144-pin CPGA, ceramic pin grid array, and CLDCC, ceramic leaded chip carrier packages. Tandem Van de Graaff facility. SEU testing utilized 2 ions, chlorine 35, 202 MeV, and nickel 58, 240 MeV. For more information on total dose or SEU radiation testing, please refer to MIL STD 175OA. Single event upset, SEU, test methodology. An LSI logic test procedure report, or contact the Military Microprocessor Group of LSI Logic Corporation. Refer to the L64500 MIL STD 1750A Microprocessor Technical Manual. October, 1989. L64501 GM25. TT. Screening option, M Class B. S Class S. L, _______ package option, G144 pin CPGA, ceramic pin grid array. L144 pin CLDCC, ceramic leaded chip carrier. Part number, radiation hardened. Copyright 1990, 1991 LSI Logic Corporation, all rights reserved. Description. Features. Radiation test data. Technical information. Ordering information. L64551. Milsto 1740A. Radiation hardened. MBU. LSI. The L64551 MBU, Memory Management and Block Protect Unit, from LSI Logic is a radiation hardened, single chip memory management unit which supports the L64501 CPU. While the L64501 provides the required 1750A functionality as defined in MIL STD 1750A, the L64551 focuses on the system implementation aspects and optional features off standard. For example, the L64551 includes on-chip contrologic and fast mapping RAMs to implement both a memory management unit, MMU, and a block protect unit, BPU. The MMU provides logical to physical address translation and logical protection, and the BPU provides physical block protection. Other on-chip functions include watchdog and bus timeout timers, a memory fault status register, MFSR, multimus bus arbitration, and an extended addressing capability for up to 8 M words of physical total ionizing dose specification of 200 CRAD, SI. No single event upset, SEU, latchup expected. Test results available Q489. SEU cross-section, CM2/bit, to be determined. Test results available Q489. Threshold, MEVCM2 per milligram, let, to be determined. Test results available Q489. Guaranteed post-radiation clock frequency of 25 MHz, MIL STD 1750A, Notice 1, Instruction Set. CFAC certification in an L64501 based system. Memory. The L64551 can interface directly with the L64501 CPU, also available from LSI Logic. To provide these optional MIL STD 1750A enhancements and to optimize system performance. To shorten the design cycle for L64501 based systems, L64551 MBU and L64501 CPU models are available in LSI Logic's MDE registered design tools. The MDE design tools provide extensive design flexibility through its multi-chip and SYS TEM simulation capabilities. LSI Logic manufactures the L64551 MBU in a two-layer metal HMOS process. The radiation-hardened L64551 operates at 25 MHz. Guaranteed after exposure, over the military temperature range -55 degrees Celsius to 125 degrees Celsius, and utilizes a single 5V plus or minus 10% power supply. MMU, BPU, MFSR, timers, multi-master arbitration. TIL compatible interface. MIL STD 883C/38510 Class B and Class S. Screening options. Silicon gate epitaxial 2-layer metal LMA 9000. HMOS technology. Directly interfaces with L64501 CPU. Available in 144-pin CPGA, ceramic pin grid array, and CLDCC, ceramic leaded chip. Carrier, packages. SEU and total dose radiation data expected in Q489. Refer to the L64500/64550 MIL-STD1750A microprocessor technical manual and datasheet. October, 1989. L64551GM25. TT. Screening option, M class B. S class S. Package option, G144 pin CPGA, ceramic pin grid array. L144 pin CLDCC, ceramic leaded chip carrier. Part number, radiation hardened. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. 117. I. 1. LSI. Spare microprocessors. Description. Features. Components. RISC products. Spark architecture. Microprocessors. And peripherals. LSI. LSI Logic offers a broad range of Spark compatible microprocessors and peripherals, designed to form the core logic of today's high-performance workstations and embedded control applications. The Spark architecture was developed by Sun Microsystems based on RISC, reduced instruction set computer, research done at the University of California, Berkeley. Spark stands for Scalable Processor Architecture. Because of its relative simplicity, the Spark architecture will scale well as advancing semiconductor technology allows Spark processors to be implemented in smaller geometries. This will allow higher operating speeds and proportionally higher performance. LSI Logic's Spark product line includes 3 microprocessors, the L64801 integer unit, LU, the L64811 enhanced integer unit, LU, and the reduced instruction set computer, RISC. Architecture. Spark instruction set. Simple 32-bit instruction format. Large windowed register file. L64801 120 registers 7 windows. L64811 136 registers 8 windows. L64901 120 registers 7 windows. High performance. Single cycle execution for most instructions. Efficient 4-stage instruction pipeline with hardware interlocks. Multitasking support with user and supervisor modes. Multiprocessing support with tightly coupled coprocessor interfaces. Family product code description. Spark IHO integer unit. L64901 embedded processor. The L64801 EXE. QTs up to 15 MIPS, and the L64811 executes up to 29 MIPS. The L64901 embedded processor has been specially optimized for embedded control applications and executes up to 15 MIPS. All 3 processors are complemented by peripherals specially designed to support work station and embedded control applications. The Spark AIT20 supports the L64801U and includes the peripherals required to build a Spark station. L-compatible workstation. The Spark AIT25-33 and -40 support the L64811 and provide the functionality required to build a high-performance workstation based on the Spark standard. The L64901 embedded processor is supported by the L64951 system controller, which contains the cache control, DRAM control, and other peripheral logic required to implement embedded control systems. Artificial intelligence support using tagged arithmetic instructions. Sun OS operating system based on Unix 4.3. BSD. Optimized high-level language compilers. C, Fortran, Ada, Pascal, Lisp. Complete peripheral chipsets. Spark AIT20 for Spark Station 1 implementations. Spark AIT25-33 and 40 for high performance workstation implementations. Clock rates packages. 160 POFP, 179 PPGA, 179 CPGA, 164,801. L64804. 164,821. 164,822. L64823. L64824. L64825. L64826. Floating point unit. Memory management unit. Data buffer. 20. 20. 20. 20. 20. 20. 20. 20. Clock controller. Cache controller. Video controller. DRAM controller. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. 121. Components. Continued. 122. RISC products. Spark architecture. Microprocessors. And peripherals. Family product coda. Spark AIT 2533-40 L.64811. L64814. L.64815. L64850. L64851. L64852. L64853. L64900 Embedded Control L64901. L64951. LSI. Description Clock rates packages. Advanced Integer Unit 2533,40 207 PPGA, 207 CPGA. Advanced Floating Point Unit 2533,40 143 PPGA, 143 CPGA. Memory Management, Cache 2533,40 223 CPGA. Control, and Cache Tag Unit. DRAM Controller 2533,40 223 CPGA. Standard I/O Interface 2533,40 208 PQFP. M-Bus to S-Bus Controller 2533,40 223 CPGA. S-Bus DMA Controller 25,120 PQFP. Spark Embedded Processor 20,25 160 PGFP, 144 PPGA. System Control Processor 20,25 160 PQFP, 144 PPGA. Description. Features. LSI. L64801 Spare. Integer Unit, LU. The L64801 integer unit, is a high-performance MAN CMOS implementation of a Spark scalable processor architecture, 32-bit RISC microprocessor. This integer unit provides the CPU function in Sun's Spark Station 1 and LSI Logic's Spark AIT20 chipset. The L64801 features a large register file to optimize procedure calls, variable assignments, and context switches. Execution speed improves significantly because this register architecture minimizes the number of external memory accesses. Most of the L64801 instructions execute in a single cycle due to its 4-stage pipeline that minimizes interlocks, a bus structure that allows single cycle instruction/data accesses and an optimized branch handler. High performance operation. Commercial. L64801C 2012 VAX MIPS. L64801C 2515 VAX MIPS. Military. L64801M15. L64801M20. 9 VAX MIPS. 12 VAX MIPS. Open architecture. Multiple vendor sourced. Variety of binary compatible price/prefer. MANS options. Optimized for operation under high-level LAN. Gauges such as C, Fortran, Pascal, Ada and the Unix operating system. External MMU, memory system, and floating point unit assure flexible interface for the largest range of applications and price/prefer. MANS levels. 32-bit virtual address bus. Supports up to 4 bytes of direct address space. Allows a variety of memory management and caching schemes. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. L64801 chip. Simple instruction format with fast instruction cycle with a 4-stage pipeline. Single cycle execution for the majority of instructions. Large central register file divided into 7 overlapping windows of 24 registers each, plus 8 global registers. All pipeline interlocks implemented directly in hardware. High-performance coprocessor interface for concurrent execution of floating point or other coprocessor instructions. Multitasking support with user/supervisor mode and privileged instructions. Artificial intelligence support through use of tagged instructions. Option to use as an ASIC core. 179-pin CPGA or PPGA, ceramic or plastic pin. Grid array, packages. 160-pin PQFP, plastic quad flat pack, package. 123. 2. I. Description. Features. 124. LSI. L64804 spare. Floating point unit, FPU. The L64804 floating point unit provides floating point support for Spark AIT20 systems. The L64804 includes a floating point data path and a floating point controller. The data path consists of a multiplier, an ALU, a divider/square root unit and a register file. The register file is a provides single chip implementation of floating point functions. Includes 64-bit multiplier. Includes 64-bit ALU. Includes 64-bit divide/square root unit. Includes internal register file. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. 3-port configuration that can be used in either 64-bit by 16 word or 32-bit by 32 word configurations. The floating point controller handles IEEE exceptions and provides an interface between the data path and both the INTE GER unit and main memory. Interfaces directly to LSI Logic L64801 integer unit and Fujitsu's S20/S25 integer unit. Interfaces directly to main memory. Complies with ANSI/IEEE 754 Standard 4. Binary floating point arithmetic. Description. Features. LSI. L64821 spare. Memory Management Unit. MMU. The L64821 MMU, Memory Management Unit, manages the translation of virtual addresses into physical addresses using a two-level map ping scheme. The mapping scheme supported by the L64821 includes a page map and a segment map. The L64821 also prioritizes interrupt, manages two-level virtual address translation map, provides decoding and timing strobes for all Sun4 Type 1 devices, including keyboard, mouse, serial controller chip, time of day clock, EPROM, floppy disk controller, audio DAC, S-bus expansion slots. Copyright 1990. 1991 LSI Logic Corporation. All rights reserved. Requests generated by external devices and provides a mechanism for software generated interrupts. The L64821 includes an S-bus interface and all signals needed to interface with the other members of SPARC-AIT20 chipset. Prioritizes 15 levels of interrupts. Replaces all MMU read/write buffers. Updates MMU statistics bits during bus cycles. Includes the Sun4 interrupt register to provide software interrupts and interrupt enabling. Includes a 4-bit context register to support switchable MMU contexts. Includes 2 internal counters to generate programmable high-resolution periodic interrupts. Includes S-bus interface signals. 125. I. Description. Features. 126. LSI. L64822 spare. Data buffer. The L64822 data buffer provides a data interface between the S-bus and the main memory. In LSI Logic's SPARC-AIT20 chipset, the L64822 includes internal read and write buffers. An internal parity checker generator creates parity bits during memory write operations and checks parity during memory read operations. The L64822 generates an S-bus error acknowledgement in the case of a parity error. Assembly/disassembly logic interfaces 8-bit I/O devices to the 32-bit IU data bus. The Sun4 parity control register is located in the L64822. Generates and checks parity during main memory operations. Performs buffered write operations in conjunction with L64824 cache controller. Assembles 8-bit I/O data into 32-bit words for IU data bus. Copyright 1990.1991 LSI Logic Corporation. All rights reserved. L64822 chip. Disassembles 32-bit words into 8-bit data for I/O devices. Forces no op on memory exceptions. Description. Features. L64823 Spark. Clock controller. LSI. The L64823 clock controller generates all clocks necessary for a system based on the SPARC-AIT20 chipset. The L64823 can support either the LSI. Generates all system clocks. Generates write enables for data/instruction. And tag caches. Generates serial controller clock. Generates refresh clock and periodic interrupt clock. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. Logic L64801 integer unit or the Fujitsu S20/S25 integer units. The L64823 also generates various write enable and clock signals. 127 I 2 IL 1 2 IJ 11 2 Description. Features. 128 LSI L64824 Spark Cache Controller. The L64824 cache controller manages the data/instruction and tag caches in a Spark AIT 20 system. The data/instruction cache is based on 16-byte lines. The tag cache is based on 20-bit words. The cache size can vary from 4096 to 16,384 lines deep. The L64824 determines cache hits and misses and initiates cache fill operations as needed. During write operations, the L64824 flushes cache lines as required to ensure system data integrity. The L64824 also includes an internal SBus controller to manage SBus operations in a Spark AIT20 system. Standard SBus operations implements write-through instruction/data cache with 16-byte line size. Supports cache size from 64 KB to 256 KB. Controls all cache operations, including fills on cache misses, flushes on cache writes, tag comparison. Performs SBus controller functions, including SBus reads and writes, bus master requests and grants, bus monitoring for unacknowledged transfers. Copyright 1990-1991 LSI Logic Corporation. All rights reserved. Including bus requests and grants, bus time outs, bus arbitration, and rerun initiation are controlled by the L64824. The L64824 also performs byte-to-word assembly operations so that byte-wide devices such as EPROMs and peripherals can communicate with the L64801 integer unit. Upon receipt of a reset signal from the IU, the L64824 generates an SBus reset signal. Performs buffered writes with external write buffer. Assembles data from byte-wide devices into 32-bit words for IU. Contains set of 4 SUN4 error registers for diagnosing bus errors. Maintains copy of SUN4 context register. Contains SUN4 system enable register. Generates system reset. Description. Features. LSI L64825 SBus Video controller. The L64825 video controller generates the signals needed to control the video RAM and the external DACs that drive the video display. The L64825 also includes an SBus interface key. Provides a single-chip video subsystem. Interfaces to SBus. Software control of video timing and display. Resolution. Supports 256x4, 128K/8, and 64K/4. Video RAMs. Supports 1-8 and 24-bit per pixel frame. Buffers. Copyright 1990-1991 LSI Logic Corporation. All rights reserved. Parameters of the video display, including video timing and resolution, are software programmable. The L64825 supports the Sun Auto Configuration feature. Supports up to 4 video clocks. Includes built-in video shifter for L-bit frame. Buffers, maximum pixel clock up to 100 MHz. Supports Sun video monitor sense lines for auto configuration. Interfaces directly to VRAM and video DACs. With no external components. 129. Discretion. Features. 130. LSI. L64826S bus. DRAM controller. The L64826 DRAM controller handles all address handling, RAS and CA decoding and control for a memory system of 4 or 8 SIM memory modules. The L64826 includes 2 sets of output buffers, each driving a supports LM and 4M DRAM SIMs. Drives up to 8 SIMs with no external buffers. Can be combined with other L64826S to drive up to 32 SIMs for a maximum memory size of 128 bytes. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. Group of 4 SIMs. The L64826 supports 1-bit and 4-bit SIMs. Up to 4 L64826S. Can be connected in banks to support a maxi mum memory configuration of 32 SIMs. Supports high-speed burst mode with fast page RAMs. Contains refresh logic and timer. Description. Features. LSI. L64811 spare. Enhanced integer unit, LU. The L64B11 enhanced IU, integer unit, is a high-speed CMOS implementation of the SPARC 32-bit RISC, reduced instruction set. Computer, architecture processor. This architecture specifies a processor which can execute instructions at a rate approaching 1 instruction per processor clock and which supports both a tightly coupled floating point unit and an implementation definable coprocessor. The L64B11IU provides simple instruction format. All instructions are 32 bits wide and aligned on 32-bit boundaries in memory. There are only 3 basic instruction formats, featuring uniform placement of opcode and address fields. Register-intensive architecture. Most instructions operate on the contents of 2 registers and place the results in a 3rd register. Only load and store instructions. Access off-chip memory. Delayed control transfer. The IU always fetches the instruction which follows a control transfer instruction, and either executes it or annuls it depending on the state of a bit in the control transfer instruction. This feature allows compilers to rearrange code and place a useful instruction after a delayed control transfer, for optimal use of the processor pipeline. Concurrent floating point operation. Floating point instructions can execute currently with non-floating point instructions. Other floating point instructions and coprocessor instructions. RISC architecture, simple instruction format. Most instructions execute in a single cycle. Very high performance, 4-stage pipeline. Has a 25 ns instruction cycle at 40 MHz. 29 million instructions per second, 29 MIPS. Large windowed register file, 136 general per pose 32-bit registers organized as B overlap. Ping windows of 24 registers each. 32-bit address bus and B-bit address space. Identifier, as, support large virtual address. Space. Hardware pipeline interlocks. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. L64811 chip. Fast interrupt response. The IU samples the interrupt inputs on every clock cycle and can acknowledge them in 1 to 3 cycles. The IU can access the first instruction of an interrupt service routine in 6 to 8 cycles of receiving the interrupt request. The L64B11 IU is part of the LSI Logic L64B11 chip family, which implements and supports Spark-based system development, multiprocessing support, user/supervisor modes, artificial intelligence support, high-performance floating point and co-processor interfaces support concurrent execution of floating point and coprocessor instructions. 1.0 micron drawn gate length 2-layer metal CMOS technology. 207-pin CPGA or PPGA, ceramic or plastic pin. Grid array, packages. 2.5 watts maximum power dissipation. 131. I. 2. I. Description. Features. 132. LSI. L64814 spare. Enhanced floating point unit, FPU. The L64814 enhanced FPU, floating point unit, is a high-performance, CMOS implementation of Spark, scalable processor architecture, FPU. The FPU combines a floating point controller with a high-throughput floating point processor to provide a single chip floating point solution for Spark-based systems. The FPU implements the IEEE 754-1985 standard for floating point arithmetic. It operates concurrently with the IU to execute single and double precision floating point operations, as well as register-to-register move instructions, floating point loads and stores, and floating point queue and state register instructions. Supported floating point operations are add, subtract, multiply, divide, square root, compare, and convert. Each instruction not implemented in the L64814 hardware generates an instruction trap, so that the instruction can be emulated in software. Note that the FPU handles all IEEE exceptions in hardware, except for denormals in the floating point multiplier unit. High performance operation provides double precision unpack floating point operation, assuming 25% degradation due to cache misses at device performance. L64814-25 MHz 3.04 mFlops. L64814 33 MHz 4.00 mFlops. L64814-40 MHz 4.80 mFlops. Low-cost solution integrates a floating point controller and floating point processor on a single chip for cost-efficient system implementation. Wide range of operating frequencies including 25/33/40 MHz versions. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. The L64814 FPU is part of the LSI Logic Spark AIT chipset family, which implements and supports Spark-based system development. L64814 chip implements IEEE exception handling directly in hardware. 64-bit wide internal data path for all floating Point operations results in highly efficient DO/BLE precision performance. Connects directly to the L64811I integer unit. LU. Pin compatible with the Witek Abacus 3171. And Texas Instruments TMS 390C602 floating point units. Advanced, 143-pin cavity up PPGA or CPGA. Plastic or ceramic pin grid array, package. Description. Features. The MCT in the Spark CPU core. L64815 Spark. Memory management. Cache control and cache tag unit. LSI. The L64815 MCT, memory management, cache control, and cache tag unit, provides two essential functions for Spark: scalable processor architecture, CPU cores, memory management and cache control. The MCT's memory management function implements the Spark reference MMU, memory management unit. The cache controller manages a direct, mapped, combined instruction and data cache. In addition, the MCT provides an interface between the 32-bit local bus and the 64-bit bus. The L64815 MCT is made by LSI logic using 1.0 micron drawn gate length, 0.7 micron effective channel length, silicon gate MOS technology. The MCT is a member of LSI Logic's Spark AIT chipset family, which implements and supports Spark-based system development. The memory management unit of the L64815 incorporates a 64-entry, fully associative TLB translation look-aside buffer. Uses least recently used, LRU, replacement algorithm for the TLB. Uses 4096 byte or greater page size. Supports 3-level page mapping. Supports sparse address spaces. Supports large linear mappings. Supports 256 contexts. Provides page-level protection. Performs 32-bit virtual to 36-bit physical address translation. The write-through, no allocate cache controller of the L64815. The MCT is part of a high-performance, general-purpose, reprogrammable computer based on Sun Microsystems Spark. Such a compute requires three main components: a CPU core, main memory, and an input/output I/O subsystem. A Spark CPU core consists of following elements: a Spark-compatible IU. Copyright 1990-1991 LSI Logic Corporation. All rights reserved. L64815 chip. Provides 2048 virtual address cache tags. Provides 32-byte block size. Provides hardware misprocessing. Includes 32-byte line buffer. Supports cache sizes of 32, 64,128 and 256 KB. Supports line-by-line cache freezing. In addition, the L64815 supports 25/33/40 MHz operation. Uses 64-bit bus as its main memory interface. Is available in two 23-pin CPGA, ceramic pin grid array, package. Provides block fill capability. Provides block copy capability. Integer unit, an FPU, floating point unit. An MMU, memory management unit, and a cache. These elements provide data, integer, and floating point arithmetic processing power, and the flexible, fast memory management. Required to support multiple processes running simultaneously from a large physical memory. 133. Introduction. Features. System diagram. 134. LSI. L64850 MBUS. DROM controller. The L64850 DMC, DROM controller, is a high-performance CMOS integrated circuit that provides a direct interface between an MBUS and a DROM array in a Spark-based system. The supports up to 4 bytes of DROM address space. 1 to 128 byte burst mode MBUS transactions. Even or odd parity generation and checking. With disable option. Parity arrow res re R. Staggered copy for RAS refresh for dual bank memory systems. Figure 1. Typical spare-based system. Copyright 1990. 1991 LSI Logic Corporation. All rights reserved. L64850 provides single chip control for high performance, low-cost memory systems, and supports 4MX9, 4MX8, 1MX9, and 1MX8. SIMs and 4MX1 and 1MX1 DRAMs. MBUS Level 1 and 2 operations. Built-in scan chain to provide 99.97% fault COV. Array test vector. Advanced 223-pin CPGA, ceramic pin grid. Array, package. Supports 100 NS, 70 NS DRAMs. Introduction. Features. System diagram. LSI. L64851. Bus to standard. 110 bus interface. The L64851M2 STDI0, bus to standard I/O bus interface, is a high-performance CMOS interface chip that interfaces an bus and a STOIO, standard, 8-bit I/O bus. As an bus interface to I/O devices, the L64851M2 STDI0 accepts requests for I/O service from an bus master, converts them to I/O bus protocol and redirects them to a designated device on the I/O bus. In addition to the bus interface, the L64851 provides 3 other bus function. AL modules, a 4-level bus arbiter, a watch dog timer that generates bus timeout, and an interrupt level encoder that generates the interrupt request levels for the Spark IU integer unit. These 3 additional modules allow the L64851 to be used in systems that do not have an M2S chip. Supports bus access to 8 I/O devices on a standard, 8-bit bus. Data packing for full use of bus bandwidth. Accesses 1 byte of I/O address space per device. Programmable latency delays for I/O devices. 1 to 128 byte bus burst transfer capability. Bus arbiter supports up to 4 bus masters. Bus watchdog timer times out bus masters. 8000, 2 clock cycles after assertion of MBB. Figure 1. Typical Spark-based system. Copyright 1990. 1991 LSI Logic Corporation. All rights reserved. L64851 chip. 15-level U interrupt level encoder supports 13 external devices and 2 internal, programmable timers. IRL7:1 can be generated in hardware, external devices, software, interrupt bit 7:1, or both. Through IU device polling. Maskable interrupts, except for IRL15. 2533 and 40 MHz system clock speed. 5 MHz clock for SCC timing. Advanced, 208 pin, square GoLang PQFP. Plastic quad flat pack, package. 135. Introduction. Features. 136. LSI. L64852. Bus. Controller. The L64852 M2S, Bus controller is a high-performance CMOS integrated circuit that provides all the control, arbitration and memory management functions needed to interface MBUS and SBUS subsystems. The M2S acts as an intermediary while moving data between BUS and SBUS devices, instead of transferring control of one bus to the other bus. When an MBUS device initiates a read from or write to an SBUS device, the M2S chip responds as an MBUS slave and then becomes the SBUS master for the data transfer. Conversely, when an SBUS device initiates a data access to the MBUS, the M2S chip responds as an SBUS slave and becomes the MBUS master. The M2S contains an MBUS arbiter to control MBUS access and an SBUS controller. The SBUS controller contains both an SBUS arbiter to control SBUS access and an IOMMU input/output memory management unit. The IOMMU, which supports the SBUS virtual addressing scheme, includes a 16-entry TLB, provides complete MBUS and SBUS master/slave logic, supports arbitration for up to 4 MBUS MOS TERs, including itself, manages SBUS transactions and supports arbitration for up to 6 SBUS master/slave devices. Incorporates a 16-entry fully associative TLB translation look-aside buffer in the IOMMU. Uses the LRU, least recently used, replace meant algorithm in TLB. Performs 32-bit virtual SBUS to 36-bit physical MBUS address translation. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. L64852 chip. Translation look-aside buffer, and virtual to physical address calculation logic. The M2S also contains low-level protection and diagram gnostic logic for the two bus subsystems. Performs 32-bit virtual SBUS to 28-bit physical SBUS address translation and SBUS slave device selection using table walking logic. Provides two sets of internal data buffers for data transfer. Performs bus protocol conversion. Tracks internal status and generates error and busy signals. Stores system and bus error information in a readable error register. Advanced 223-pin CPGA, ceramic pin grid array, package. Description. Features. LSI L64853 SBUS DMA controller. The L64853 SBUS DMA, direct memory access controller by LSI Logic provides a complete SBUS interface for SBUS peripheral subsystems. The L64853 is a high-speed, low-power, dual-port device. It provides master/slave type peripherals with a single chip solution for interfacing to the SBUS. The principal components of the L64853 are two functionally distinct DMA channels, an 8-bit and 16-bit channel, and an SBUS interface with associated bus arbitration logic. The L64853 is ideal for both master and slave Peripherals as it operates either in master mode or in slave mode. As an S-bus master, the L64853 generates, upon request from a device, attached to either channel, sequences of S-bus data transfers, reads or writes, between the peripheral controller and main memory. In operation at clock frequencies up to 25 MHz. Packing/unpacking of S-bus words into bytes or half words for use by the peripheral controllers. Support for 8 or 16-bit peripherals. Supports byte, half-word, or word transfers on the S-bus. Operation in virtual address space with the Spark MMU providing virtual to physical address translations. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. S-bus terminology, the L64853 is a DVMA. Direct Virtual Memory Access, master, that is. It generates virtual addresses on the S-bus data lines and employs the S-bus controllers. MMU, Memory Management Unit, to translate these virtual addresses into physical address. Yes. When the L64853 is an S-bus slave, software reads and writes the internal registers on the L64853 and also on the two peripheral controllers. The CPU uses the L64853 as a conduit to access the two peripheral controller chips. The DMA controller operates at a maximum clock frequency of 25 MHz. The L64853 is implemented in a 1.5 micron CMOS process and is packaged in an inexpensive 120-pin plastic quad flat package, PQFP. Support for rerun acknowledgements. Inclusion of 24-bit address and data counters. Packaged in a low-cost, 120-pin PQFP, plastic quad flat package. 137. Description. Features. 138. L64853A S-bus. Direct Memory Access, DMA. Controller. LSI. The L64853A S-bus DMA, Direct Memory Access, controller is a high-speed, low-power, dual-port device that provides a complete S-bus interface solution for S-bus peripheral subsystems. The principal components of L64853A are its two functionally distinct DMA channels and its S-bus interface with associated bus arbitration logic. The L64853A supports both 8 and 16-bit peripherals through two independent DMA channels, a 16-bit channel and an 8-bit channel. The L64853A is ideal for both master and slave peripherals as it operates either in master mode or in slave mode. Operation at clock frequencies up to 25 MHz. Support for 8 or 16-bit peripherals. Support for byte, half-word, or word transfers on the S-bus. Operation in virtual address space with the Spark MMU providing logical to physical address translations. Support for rerun acknowledgements. Inclusion of 24-bit address and data counters. Copyright 1990. 1991 LSI Logic Corporation. All rights reserved. During S-bus DMA transfers, the L64853A packs the data into one of two 32-byte caches. For optimum bus performance, the S-bus DMA controller supports concurrent 5 MB/section SCSI and 1.25 MB/SEC Ethernet transfers. The L64853A is pin and software compatible with the L64853S bus DMA controller. The L64853A provides additional features over the L64853, such as support for forward S-bus bursts and data block chaining. The L64853A operates at clock frequencies of up to 25 MHz. The L64853A is implemented in a 1.5 micron CMOS process and is packaged in an inexpensive 120-pin plastic quad flat pack. Age, PQFP. Inclusion of 232-byte caches for data FERS. Forward burst operation. Data block chaining. Packaging in a low-cost, 120-pin PQFP, plastic quad flat pack, package. Pin and software compatible with the L64853 S-bus DMA controller. Description. Features. LSI L64855 S-bus video frame buffer. The L64855 video controller generates the signals needed to control the video RAM and the external DACs that drive the video display. The L64855 also includes an S-bus interface. Key. Provides a single-chip video subsystem. Interfaces to S-bus. Software control of video timing and display. Resolution. Supports 256x4, 128K x8, and 64K x4. Video RAMs. Supports 1-8 and 24-bit per pixel frame. Buffers. Copyright 1991 LSI Logic Corporation. All rights reserved. Parameters of the video display, including video timing and resolution, are software programmable. The L64855 supports the Sun Auto configuration feature. Supports up to 4 video clocks. Includes built-in video shifter for 1-bit frame. Buffers, maximum pixel clock up to 100 MHz. Supports Sun Video Monitor Sense lines for auto configuration. Interfaces directly to VRAM and video DACs. With no external components. 139. Description. Features. 140. LSI. L64901 spare. Embedded processor. Preliminary. The L64901 Spark embedded processor is a high-speed implementation of Spark 32-bit RISC architecture, and it is fabricated by LSI Logic in a 1.5 micron drawn gate length, 0.9 micron effective channel length, CMOS. Process. The L64901 processor provides simple instruction format. All instructions are 32 bits wide and aligned on word boundaries in memory. There are only 3 basic instruction formats, which feature uniform placement of opcode and other fields. Register-intensive architecture. Most instructions operate on the contents of 2 registers and place the results in a 3rd register. Only load and store instructions. Access off-chip memory. Delayed control transfer. The L64901 always fetches the instruction, which follows a control transfer instruction, and either executes it or annuls it depending on the state of a bit in the control transfer instruction. This feature allows compilers to rearrange code to place a useful instruction after conditional branches, for optimal use of the processor pipeline. Fast interrupt response. The L64901 processor can access the first Instruction of an interrupt service routine with int thre.e to 6 cycles of receiving the interrupt. Request. Spark RISC, reduced instruction set. Computer, architecture. Simple instruction format. Simple LX clock input. Most instructions execute in a single cycle. Low cost. 4-stage pipeline. Large windowed register file. 120 general-purpose 32-bit registers. 7 overlapping windows of 24 registers each. Hardware pipeline interlocks. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. LN 4901 chip. ASIC implementation. The L64901 processor is implemented in LSI Logic's advanced submicron MOS process, which offers up to 200,000 usable gates on a single integrated circuit. LSI Logic's ASIC methodology facilitates modifications to the processor and provides users the ability to increase system integration or to reduce SYS/TEM cost. The L64901 is part of LSI Logic's L64900 embedded processor family for Spark-based systems. Separate 32-bit address and data buses. User/supervisor modes. Privileged instructions. Artificial intelligence support. 1.5 micron gate length, 2-layer metal CMOS. Technology. 160-pin PQFP, plastic quad flat pack, and 144-pin PPGA, plastic pin grid array, packages. 0.8 watts maximum power dissipation. Available in 20 or 25 MHz versions. Description. Features. LSI L64951 Integrated System Controller. Preliminary. The L64951 Integrated System Controller, LSC, is a member of the L64900 family of embedded solutions. Manufactured in LSI Logic's advanced 1.5 micron drawn gate length MOS process, the ISC provides memory control, address decode and other support services. For the L64901 Spark embedded processor, a 32-bit implementation of the Spark RISC architecture. Designers can use the L64901 and the L64951 to build a low chip count, high performance embedded processor core. The ISC includes a host of features that make the implementation of a processor core straightforward. In addition to a variety of glue logic, the ISC includes the 5 major features described below. The ISC includes a DRAM controller that can control up to 4 banks of DRAMs. The address range for each bank is programmable. The DRAM controller also includes refresh logic. The ISC provides 8 chip selects to control SRAMs, EPROMs, and I/O devices. The address range and control signal timing for each chip select are programmable. The ISC includes an interrupt controller that prioritizes and encodes 8 external interrupt lines and 2 internal interrupt sources. Interrupts can be individually masked or masked by priority. In addition to the major functions described above, the ISC provides many of the glue logic functions that are required to complete a processor core. Those functions are included in this list of features. DRAM control with programmable address. Decoders for up to 4 banks of DRAMs. 8 chip selects with programmable address. Decoders and control signal timing for SRAM. EPROM and I/O control. Interrupt control for 8 external and 2 internal interrupts. Copyright 1990, 1991 LSI Logic Corporation. All rights reserved. L64951 chip. The ISC provides 3 DMA channels, 2 for use by I/O devices and 1 for block transfers by the processor. These DMA channels allow large blocks of data to be transferred between I/O devices and memory with minimal processor involvement. The 2 I/O DMA channels generate interrupts when a transfer is complete. The interrupt levels are programmable. The ISC includes cache control logic that allows construction of a high-performance cache memory. The ISC provides 8 protection registers to permit or prohibit access to blocks of memory. These protection registers can also be used to set breakpoints to ease software debug. 3 DMA channels with programmable interrupt levels. Programmable memory protection and debug. Breakpoints. Data bus buffer control signals. Reset logic. Processor bus request and acknowledge sig. NALs for I/O devices. Low-cost 160-pin PQFP, plastic quad flat pack. Package and 144-pin PPGA, plastic pin grid. Array, package. 20 MHz operating speed. 141. Sales offices and design resource centers. LSI. Comprehensive design support. Features. US sales representatives. European sales representative. LSI. Global design resource centers. LSI Logic maintains the world's largest ASIC design support network. 39 design resource centers provide access to qualified LSI Logic application engineers and a full range of hardware and software design tools. Whether customer engineers elect to work at or through a design center, experienced appli. Full support for all LSI Logic channeled and channel-free trademark array and cell-based ASIC designs. Experienced LSI Logic application engineers offer detailed and comprehensive design assistance, access to major software and hardware tools and environments, mainframes, workstations, silicon compilers, PLD converters and logic synthesizers, hardware accelerators, SSI, MSI, LSI, and VLSI technology libraries. Midwest Technical Sales 314-298-8787 913-888-5100 Genesis 617-270-9450 Denmark, Finland. EV, Johansson Electronic as Fintronics AB 45.1.839022011.358.692.6255. Copyright 1989, 1990, 1991 LSI Logic Corporation. All rights reserved. Cation engineers offer expert training and design assistance. Comprehensive support. Includes design training, access to extensive technology libraries, use of CAD equipment and tools and distribution of design literature, data books and technical information. Demonstration facilities to introduce customers to the latest tools and technologies. Full customer facilities for on-site or remote design entry and simulation. Design courses offered on-site. Worldwide design tool network for fast and comprehensive service and support. Full marketing and sales support. Norway. Semi-devices as 47.9.8765550. Spain. Amitron. 0034.1.2479313. 145. LSI. Distributors. US, Alabama, Florida, Minnesota. While laboratories. By state: Huntsville, Miami/FT, Lauderdale, Minneapolis. 503-643-7900. Hamilton Abnet, Hamilton Abnet, Hamilton Abnet. 205-837-9177305-979-2802612-932-0678. Oklahoma. Tulsa. Arizona, Orlando, Missouri. Hamilton Abnet. Phoenix, Hamilton Abnet. Kansas City, 918-252-7297. Hamilton Abnet. 407-628-3888. Hamilton Abnet. 602-961-640-1913-888-0155. Pennsylvania. St. Petersburg, Pittsburgh. While laboratories: Hamilton Abnet. St. Louis, Hamilton Abnet. 602-437-2088813-573-3930. Hamilton Abnet. 412-281-4150. 314-537-4250. California, Georgia, Texas. Calabasas, Atlanta, New Jersey, Austin. While laboratories: Hamilton Abnet. North Jersey, Hamilton Abnet. 818-880-9000404-447-7500. Hamilton Abnet. 512-832-4306. 201-575-3490. Chatsworth, Illinois. While laboratories: Hamilton Abnet. Chicago, South Jersey. 512-345-8853. 818-594-8200. Hamilton Abnet. Hamilton Abnet. 708-860-7780609-424-0110. Dallas. Costa Mesa. Hamilton Abnet. Hamilton Abnet. Indiana, New Mexico. 214-404-9906. 714-641-4100. Indianapolis, Albuquerque. Hamilton Abnet. Hamilton Abnet. While laboratories: Gardena. 317-844-9333505-765-1500-214-235-9953. Hamilton Abnet. 213-217-6700. Iowa, New York, Houston. Cedar Rapids, Long Island. Hamilton Abnet. Irvine, Hamilton Abnet. Hamilton Abnet. 713-240-7898. While laboratories: 319-362-475-7516-231-9800. 714-863-9953. While laboratories: Kansas, Rochester. 713-879-9953. Sacramento, Kansas City. Hamilton Abnet. Hamilton Abnet. Hamilton Abnet. 716-475-9140. Utah. 916-648-3264-913-888-0155. Salt Lake City. Syracuse, Hamilton Abnet. San Diego, Kentucky. Hamilton Abnet. 801-972-4300. Hamilton Abnet. Lexington. 315-437-2641. 619-571-7500. Hamilton Abnet. While laboratories: 606-259-1475. North Carolina. 801-974-9953. While laboratories: Raleigh. 619-565-9171. Maryland. Hamilton Abnet. Washington. Baltimore. 872-3604 Seattle. Santa Clara Hamilton Avnet. Weil Laboratories 301-995-3580 Ohio 206-881-6697. 408-727-2500 Cleveland, Massachusetts Hamilton Avnet Weil Laboratories. Sunnyvale Boston 216-349-4910-206-881-1150. Hamilton Avnet Weil Laboratories. 408-743-3300-617-272-7300 Columbus, Wisconsin. Hamilton Avnet Milwaukee, Colorado Hamilton Avnet 614-882-7389 Hamilton Avnet. Denver 508-532-370-1414-784-4510. Hamilton Avnet Dayton. 303-799-0663 Michigan Hamilton Avnet. Detroit 513-439-6700. Weil Laboratories Hamilton Avnet. 303-457-995-3313-347-4270 Oregon. Portland, Connecticut Grand Rapids Hamilton Avnet. Danbury Hamilton Avnet 503-526-6200. Hamilton Avnet 616-243-8805 Sales offices with 203-797-1100 Design Resource Centers. 146. Printed in USA. Sales offices and design resource centers. LSI Logic Corporation. Headquarters 1551 McCarthy Boulevard, Milpitas, California 95035. Tel 408-433-8000. Telex 171,092. Fax 408-434-6457. Alabama 600 Boulevard South, Suite 104J. Huntsville AL 35802. Tel 205-883-3527. Fax 205-883-3529. Arizona 8283 Hayden Road, Suite 270. Scottsdale, Arizona 85258. Tel 602-951-4560. Fax 602-951-4580. California 2540 North 1st Street, Suite 201. San Jose, California 95131. Tel 408-954-1561. Fax 408-954-1565. 2 Park Plaza, Suite 1000. Irvine, California 92714. Tel 714-553-5600. Fax 714-474-8101. 10731 Trina Street, Suite 209. San Diego, California 92123. Tel 619-541-7092. Fax 619-689-7145. 15821 Ventura Boulevard, Suite 275. Encino, California 91436. Tel 818-379-2400. Fax 818-783-5548. Colorado 3801 East Florida Avenue, Suite 400. Denver, Colorado 80210. Tel 303.756_8800. Fax 303-759-3486. Florida. 1333 Gateway Drive, Suite 1019C. Melbourne FL 32701. Tel, 407-339-2242. Fax, 407-831-3919. 1900 Glades Road, Suite 201. Boca Raton FL 33431. Tel, 407-395-6200. Fax, 407-394-2865. Illinois. 1 Pierce Place, Suite 400E. Itasca, Illinois 60143. Tel, 708-773-0111. Fax, 708-773-4631. Maryland. 6903 Rockledge Drive, Suite 230. Bethesda, Maryland 20817. Tel, 301-897-5800. Fax, 301-897-8389. Printed in USA. 100.830.652.4.1 OK.dtp.g. LSI. 10480 Little Patuxent Parkway, Suite 500. Columbia, Maryland 21044-3456. Tel, 301-740-5664. Fax, 301-740-5603. Massachusetts. 9 Hillside Avenue, Prospect Place, Waltham, Massachusetts 02154. Tel, 617-890-0180, Design CTR. Tel, 617-890-0180, Sales of C. Fax, 617.890.6158. Minnesota. 8300 Norman Center Drive, Suite 730. Minneapolis, Minnesota 55437. Tel, 612-921-8300. Fax, 612-921-8399. New Jersey. 379 Thornall Street, Edison, New Jersey 08837. Tel, 908-549-4500. Fax, 908-549-4802. New York. 1065 Route 82, Hopewell Junction, New York, New York 12533. Tel, 914-226-1620. Fax, 914-226-1315. Eastview Park. 7979 Victor Pittsford Road, Victor, New York 14564. Tel, 716-223-8820. Fax, 716-223-8822. 4914 West Genesee Street, Suite 104. Camillus, New York 13031. Tel, 315-468-1646. Fax, 315-488-2947. North Carolina. 4601 Six Forks Road, Phase 2, Suite 528. Raleigh, North Carolina 27609. Tel, 919-783-8833. Fax, 919-783-8909. Ohio. 4027 Colonel Glenn Highway, Suite 415. Dayton, Ohio 45431. Tel, 513-427-5655. 5476. Fax, 513-427-5828. Oregon. 15455 Northwest Greenbrier Parkway. Suite 210A. Beaverton, Oregon, 97006. Tel, 503-645-9882. Fax, 503-645-6612. Pennsylvania. 3 Neshaminy Interplax. Suite 301. Trevose, Pennsylvania, 19053. Tel, 215-638-3010. Fax, 215-638-3064. Texas. 5316 Highway 290 West. Suite 431. Austin, Texas, 78735. Tel, 512-892-7276. Fax, 5i2.892.6564. 5080 Spectrum Drive. Suite 1010 West. Dallas, Texas, 75248. Tel, 214-788-2966. Fax, 214-233-9234. Washington. 3015 2th Avenue NE. Suite 205. Bellevue, Washington, 98004. Tel, 206-822-4384. Fax, 206-827-2884. LSI Logic Corporation of Canada Incorporated. Headquarters. Petro-Canada Centre, STE. 3410. 150 6th Avenue Southwest. Calgary of T2P3Y7. Tel, 403-262-9292. Fax, 403-262-9494. PO. Box 8249. Station F. Edmonton of T6H4Pi. Tel, 403-450-4400. Fax, 403.450.441i. 3600 Gilmore Way number 306. Burnaby, BC V5G4R8. Tel, 604-433-5705. Fax, 604-433-8443. 260 Hearst Way. Canada on K2L3HL. Tel, 613-592-1263. Telex, 053.3849. Fax, 613-592-3253. .401 The West Mall #1110. Etobicoke on M9C5J5. Tel, 416-620-7400. Fax, 416-620-5005. 755 St. Jean Boulevard number 600. Point Claire, PC. H9R5M9. Tel, 514-694-2417. Fax, 514-694-2699. France. LSI Logic SA. Tour Chenonceau. 204 Rond-Point du Pont de Sèvres. 92516 Boulogne-Billancourt. Paris, France. Tel, 33.146.206600. Telex, 631,475. Fax, 33.146.203138. Israel. LSI Logic Limited. 40 Sokolov Street. Ramat Hasharon 47235. Tel, 972.3.5403741. Telex, 371,662. Fax, 972.3.5403747. LSI Logic Logo Design. CDE, Channel Free, Co-Designer, Embedded Array, LDS. LDSL, MO and Modular Design Environment are registered trademarks and Chipsizer, CMO, Compacted Array. Compacted Array Plus, Direct Drive. EasyASIC, Fastest Floor Planner, Lightning, Logic Integrator, LSIM, MIPSET, 9. Write First Time, Self-Embedded, Silicon Integrator, Spark AIT and System. Integrator are trademarks of LSI Logic Corporation. Sun Microsystems is a Regis. Tiered trademark of Sun Microsystems Incorporated. VM/CMS is a trademark of IBM Corporation. DEC, VMS, MicroVAX, and VAX are trademarks of Digital Equipment Corporation. Unix is a registered trademark of AT&T. Domain 9 is a trademark of Apollo Computer Incorporated. AM7990 LANS is a registered trademark of Advanced Micro Devices Inc. NCR53C90 is a trademark of NCR Corporation. SPICE is a trademark of Meta Software Incorporated. Italy. LSI Logic SPA. Centro di Arenzionali Italiani. Palazzo Oriane Ingressa 1. 20041 A Great Brian, Mill. Tel, 39.39.60568881. Fax, 39.39.605787. Japan. LSI Logic K.1L. Headquarters. Kokyusei Ishin Akasaka. West Wing 13th floor. June 1, 20 Akasaka, Minato-ku. Tokyo T108. Tel, 81.33.589.27. Fax, 81.33.589.2740. Futabakuden Building 4F. 3-4-4 Kuden Enlanami. Chiyoda-ku. Tokyo 102. Tel, 81.33.5275.1731. Fax, 81.33.5275.1739. 2-10-1 Kashuga. Yatabe Mache. Tsukyubagum, Ibaragi 305. Japan. Tel, BL.29B.52.8371. Fax, 81.298.52.8376. Twin 21 Mid Tower 31st floor. 2+61 Shiramai, Higashiku. Osaka 540. Tel, 81.6.947.5281. Fax, 81.6.947.5287. Tama Plaza Daisen Building. 2-19-2, Utsukushi Gaoka. Midori-ku. Kanagawa 227. Tel, 81.45.902.41. Fax, 81.45.902.4533. LSI Logic Corporation of Korea Limited. 7th floor Namseol Building. 1304-3, Sokodong. Sokoku, Seoul. Tel, 82.2.561.2921. Fax, 82.2.554.9327. Netherlands. Elslogic/Arkobel. Griekenweg 25. Postbox 344. NL 5340 OSS. Tel, 31.4120.30335. TWX, 37,489. Fax, 31.4120.30635. Scotland. LSI Logic Limited. Lomond House. Beveridge Square. Livingstone F546QF. Tel, 44.506.416767. Fax, 44.506.4i4836. Sweden. LSI Logic Export of Torshamnsgaten 39. S16440 Kista. Tel, 46.8.703.4680. Fax, 46.8.7506647. Switzerland. LSI Logic Sulzer AG. Orlenstrasse 36. CH2555 Brugg/Biel. Tel, 41.32.536363. Fax, 41.32.536367. Taiwan. LSI Logic Corporation. 3F2, 678-ton Hua SRD. Taipei, Taiwan ROC. Tel, 886.2.755.3433. Fax, 886.2.755.5176. United Kingdom. LSI Logic Limited. Headquarters. 1 Maidstone Road. Sidcup, Kent. De 145 Hu. Tel, 44.81.302.8282. Fax, 44.81.300.06. Grenville Place, The Ring. Bracknell. Berkshire RG12 IBP. Tel, 44.344.426544. Telex, 848,679. Fax, 44.344.481039. West Germany. LSI Logic GmbH. Headquarters. Arabellastrasse 33. 8000 Munich 81. Tel, 49.89.92693030. Fax, 49.89.917096. Niederkasseler AM. Seestern, Lowegate. 4000 Dusseldorf II. Tel, 49.211.59611066. TWX, 858-7248. Fax, 49.21i.592130. Buchsenstrasse 15. 7000 Stuttgart I. Tel, 49.711.22625151. TWX, 723,813. Tel, 49.711.22611124. AE Advanced Electronics. Theaterstr. 14. 3000 Hanover 1. Tel, 49.5.36811756. Fax, 49.511.36811759. AE Advanced Electronics. Stefan George Ring 19. 8000 Munich 81. Tel, 49.89.93009855. Fax, 49.89.93009866. Sales offices with Design Resource Centers. LSI Logic Corporation reserves the right to make changes to any products and services herein at any time without notice. LSI Logic does not assume any responsibility or liability arising out of the application or use of any product or service described herein, except as expressly agreed to in writing by LSI Logic, nor does the purchase, lease, or use of a product or service from LSI. Logic convey a license under any patent rights, copyrights, trademark rights, or any other of the intellectual property rights of LSI Logic or of third parties. All rights reserved. Add me to your mailing list. C. Yes, I'm interested. Have someone call me right away. D. I would like information. Please attach business card or print. Name, title. Company. Address MS. City state ___ zip. Phone. ASIC Design Tools DL64210/11 Variable length. D. Third-party tools Video shift registers. D. SeamDitim Tools DL64212 Variable length. D. Silicon 1076 VHDL Video shift register. Design Services DL64220 Rank Value Filter. D. Design Building Blocks DL64230 Binary Filter and D. Cell Development Template Matcher. D. Full Scan Testing and ATPG DL64240 Multi-Bit Filter. Default Grading DL64243-3x3 Multi-Bit Filter. D. Spice Models DL64245 for Filter Processor. 0 Layout DL64250 Histogram/HOF. RJ Applications Engineering Transform Processor. Support DL64260/61 High Speed. Array-based ASICs. Versatile for filter. IJLCA 200K Compacted Array TMDL6427064x64 Crossbar Switch. Turbo Series. DL64280 Complex FFT. IJLFT 150K Fastest Trademark. Processor. Array Series. DL64281 FFT Video Shift. JLCA 100K Compacted. Register. Array Plus Trademark Series. DL64290 Object Contour. IJLE 100K Embedded. Tracer. Array TM Series Video Compression. IJLCA 10000 Compacted JL6470108 Error Correcting. Array TM Series Reed-Solomon Codec. IJLMA 9000 Microarray DL647152 Error Correcting. Series BCH Encoder Decoder. IJLDD 10000 by CMOS Direct DL64720 Video Motion Estimation. Drive Trademark Array Series Processor, DCT. JLAD 310 by CMOS Analog/Digital DL64730 Discrete Cosine. Array Series Transform Processor. Radiation Hardened ASICs. DL64735 Discrete Cosine. DLRH 10000 Radiation Transform Processor. Hardened Series. DL64740 DCT Quantization. DLRH 9000 Radiation Processor. Hardened Series. DL64745 JPEG Coder. DL63500 DATAC ARINC 629. DL64750/51 CCM Variable. Terminal Device. Length Coder/Decoder. Cell-based ASICs. DL64760 Interframe Processor. DLCB007 Series Cell-based. SPARC Microprocessors. ASICs. DL64801 Integer Unit. DLCB15 Series Cell-based ASICs. DL64804 Floating Point Unit. JTAG. DL64821 Memory Management. DIEEE P.1149I/JTAG. Unit. Testability Bus. DL64822 Data Buffer. DL64823 Clock Controller. DSP DL64824 Cache Controller. JL6403 232-bit Max EL64825S bus video controller. DL64134 32-bit MOS DL64826S bus DROM controller. IEEE floating point DL64811 enhanced integer unit. Processor. Date. DL64814 enhanced floating point unit. DL64815 memory management, cache control and cache tag unit. DL64850 bus DROM controller. DL64851 bus standard I/O bus interface. DL64852 bus DOS bus controller. DL64853S bus DMA controller. DL64853AS bus direct memory access DMA controller. DL64855S bus video frame buffer. DL64901 embedded processor. DL64951 integrated system controller. MIPS microprocessors. DLR2000 RISC microprocessor. DLR2010 floating point accelerator. DLR3000 RISC microprocessor. DLR3000A RISC microprocessor. DLR3010 floating point accelerator. DLR3010A floating point accelerator. DLR3220 read-write buffer. DLR3201 RST int controller. DLR3202 bus controller. DLR3203 DROM controller. DLR32D04 DROM data bus buffer. DLR3205 block transfer buffer. DLR33000 MIPS embedded processor. DRPM3310 MIPS 9 module. DRPM3330 MIPS 9 module. DMIPS system programmers. Package. 1750A. D1750A microprocessor. Packaging. Depackaging. LSI. LSI. LSI Logic Corporation. 1551 McCarthy Boulevard, Milpitas, California 95035. Attention, Marketing Communications. MS0102. Place. Stamp. Here. Thank you for completing this response card. This information will help us to serve you better. If you have an immediate need for more information, please call us at 408-433-4288. LSI Logic Corporation, Milpitas, CA. 408-433-8000. LSI Logic Corporation of Canada Incorporated, Calgary. 403-262-9292. Japan. LSI Logic KK. Tokyo. 81.33.589.2711. United Kingdom. LSI Logic Limited. Sidcup. 44.81.302.8282. West Germany. LSI Logic GmbH. Munich. 49.89.926903.0. Order number 13000.